Hello, hi, and welcome to this comprehensive course on getting started with Python. I am Mohit Yadav and I teach at Scalar. This course is specially designed for people who are just starting out with programming. In this course, we will also build a to-do app that will give you some level of confidence in using Python. If you don't already know, Python is the fastest growing language in the world. It is used by a variety of software professionals ranging from software engineers, mathematicians, data analysts, scientists, accountant, network engineers, and even kids. Having said that, what can you do with it? Well, Python is massively used in data analytics. You might have heard about big data. Python is not only a de facto standard for teaching, but it is also widely used in companies like Facebook, Google, Microsoft, etc. It has deep usage in artificial intelligence, machine learning, and deep learning. It is also the first language of choice for most site reliability engineers. A big chunk of engineers in platform engineering community uses Python for automating tasks such as deployment, monitoring, alerting, and other platform engineering tasks as well. We can also do relatively simpler operations like copying files from one location to other, run scripts when our operating system boots up. We can also download data from other websites and pass them easily using Python. Python is also used in designing applications for web, mobile, and desktop devices. Integration testing is another area where Python is widely used. Lastly, some hackers use scripts that are written in, you guessed it right, Python. But what makes Python so popular? The main reasons are, using Python, you can solve complex problems in less time with fewer lines of code. Also, it is a high-level language, so you don't have to deal with memory management like we have to do in C++. It can run across platforms, be it Windows, Mac, or Linux OS. The huge community makes it favorable for people to get their issues solved quickly and in a very responsive manner. Lastly, the large ecosystem of libraries and frameworks and tools means that you have to spend less time in reinventing the wheel. Python is a multi-purpose, beginner-friendly language with a cleaner and a much simpler syntax. Industry leaders like Google, NASA, YouTube, Amazon, Facebook, IBM use Python in some way or the another. And more companies are adopting Python, which are increasing the demand and thereby the salary of Python developers. In fact, Python topped the list of top skills that you can have in 2020, which were followed by React, Angular, machine learning, and Docker. A Python developer earns twice as much of a PHP developer and about 15% more than the Java or a front-end developer. Hence, we at Scalar are offering a free comprehensive full course on Python. Since this course is specially designed for beginners, we will make sure that we hold your hand and take you from a beginner level to an intermediate level. By the end of this course, you will have a full working project in your hand that you can write in your resumes as well. But before we start with the course, I would like to urge each one of you to please like and share this video. Also, comment with your GitHub profile showcasing that you have completed this project. Lucky winners will get a chance to get free guidance about cracking your dream company from Google and Facebook engineers. I hope you will like the course, and I'll see you again at the end of the course.
All right. Now, this course is about Python. So let us quickly go to python.org and quickly introduce what Python is. Right. So I hope that you're familiar with this thing. Python is a programming language, right? So, I mean, what sort of programming language Python is? Well, it is a general purpose programming language. Right? What do I mean by general purpose? It means that it is used for a lot of different things. Right? It is not the case that this programming language is used for one specific thing. For example, if you look at some older languages, for example, Fortran or perhaps COBOL, then those languages would be used only in certain contexts. For example, numerical computing, right? On the other hand, a language like Python, this is used for a variety of in a variety of different domains. Okay. Python is a very high level language, right? Now, what do we mean by very high level? Once again, so if you look back to the very old languages like assembly, languages like COBOL, they had a very simple set of instructions or a very simple set of things that the language provided to you, right? So those languages were very fast, but coding in them was very difficult, right? Or at least very tedious. Now, coming to Python, Python provides you with a lot of features. Right? It provides you with a ton of features so that your life as a programmer, your life as a developer becomes as simple as possible. Right? So both reading Python, learning Python, and teaching Python, right? All of these three things is very simple. Python is a very simple programming language, but that does not mean that it is not powerful. Python is still very powerful, right? Perfect. Now, there are some other things that you might want to know about Python. Things like the fact that it is dynamically typed. Right now, it's okay if you do not know right now what dynamically typed is. As we talk about more data types and the typing system, we talk about object-oriented programming, we will explain what statically typed and dynamically typed means. Right? But for those of you who are familiar with it, just know that Python is a dynamically typed programming language. So there's a misconception in people that Python, because it is a dynamically typed language, it is also a weakly typed language, which is not correct. Now, once again, if you do not understand what weakly typed or strongly typed means, don't worry about it right now. We will explain it later on. Okay. But for those of you who know it, Python is a dynamically typed language, but it is still a strongly typed language. Okay. Cool. Now, Python is multi-paradigm. So, I mean, for those of you who are students of computer science, or for those of you who are kind of into programming, who have been reading blogs online, who have been watching videos online, you might have heard of several things, right? You might have heard of functional programming. You might have heard of procedural programming. Object-oriented programming is very common, right? Object-oriented programming. Or you might have heard of asynchronous programming, right? Event-driven programming. Or you might have heard of several other paradigms of programming. Now, Python is a multi-paradigm programming language in that it supports many different paradigms. Right? So most modern languages are actually multi-paradigm. For example, C++ is multi-paradigm, Java is multi-paradigm, but some are not. For example, Haskell is not a multi-paradigm programming language. I mean, we don't have to worry about Haskell now. Python is a multi-paradigm language. All right. Now, Python sort of has a certain charm to it, right? And the reason being that, once again, Python is very simple to learn, but apart from simplicity and power, it provides a very wide and very mature ecosystem, right? So the tooling for Python, if we come to all the tools that you will use while coding in Python, things like your development environment, right? Your editor, your version control system, all these things, they are very well developed. For example, the most common IDE for Python would be PyCharm, right? So other than that, across all the major editors, for example, in Sublime Text or VS Code or Vim or Emacs, you will find very nice Python extensions, right, that you can install to customize your editor for Python. All right. Apart from that, Python also has a lot of other tooling. For example, for code auto formatting, it has a code linting like Black. It has a code auto formatting like Black. It has PyLint. It has Flake8. Right. Apart from that, it has static type checkers like MyPy. Now, once again, if this sounds all like, I mean, gibberish to you, don't worry. I'm just basically telling you, introducing some concepts of Python to you. It might not make sense right now, but just I mean, go through this. Okay. Perfect. Now, coming to what sort of applications or what sort of code do people write when they write Python code? So, I mean, once again, Python is used across the board. It is used for all sorts of different things, but mostly, if you look at it, you will find Python in two things, right? You will either find people creating websites using Python, right? Writing web servers using some web framework like Django or Flask, right? Or you will use Python. You will see Python being extensively used in data analytics and machine learning, right? So that is a field that has recently caught up right now. That's a buzzword right now, data analytics and machine learning. So Python provides a very nice set of ecosystem for that, right? Things like NumPy, TensorFlow, SciPy, Matplotlib, sklearn, and all these different things like pandas. All right. Apart from that, you will also find Python a lot in things like DevOps, right? So a lot of scripting things and automation things and web scraping, right? Or basically validation things. So automated testing, you will find Python a lot over there. All right. Perfect. So that was a very, very brief introduction to Python. Now, what I would want for all of you to do for this course is to install Python, right? Now, installing Python will depend on what system you are. So I'm currently on Ubuntu. I'm currently on Ubuntu 20.04 LTS, but you might be on Windows. Some of you might be on Mac OS, right? And some of you might be on some other operating system. Okay. So I'm not going to explain all the particular installation steps, but for that, you can go to this particular link, right? So this is realpython.com. So the link for this will also be available in these lecture notes. So if you go to the lecture notes over here, you will find a link to this realpython.com. Right, so this is the link, and it has a very nice guide on how you can install Python on different operating systems. So depending on what your operating system is, be it Windows, be it Mac OS, be it Linux or some other version of Linux, be it Android, even on your iPhone, right, you can install Python. So you can go through this and install Python for your system. All right. So I would recommend that before tomorrow's class, all of you have Python installed on your system. All right. That's a humble request from my side. For today's class, since I still want you all to basically code along with me, for today's class, we will be using an online interpreter of Python. Okay. So basically, we will be using this tool called Repl.it. So repl.it. Right. So once again, this is the link over here. This is the website over here. repl.it. Okay. And if you go to this particular link, repl.it, if you hit enter over there, this is an online REPL for Python. So you will be able to code Python in your browser itself. Okay. So what you can do over here is you can go over and click this button, start coding. When you click start coding, it will ask you what language do you want to code in. Right? So we will select Python because we are coding in Python, and we will click on create REPL. All right. So everyone, I want you to follow along with me. Open repl.it. Okay, repl.it. Create a new REPL over there. Choose Python as a language and create the REPL. And once you create the REPL, you will get a screen like this. Is that clear, everyone? I hope that everyone can see what is written on the screen. So I hope that the text is not too small. My screen is now visible. Okay, perfectly. So I guess some of the lecture needs to be redone. So once again, you will find the link to the lecture notes in the description. Right? So these are the lecture notes. These are the lecture notes, github.com/github.com/Scalar Academy/Intro to Python. All right, can you see my screen, guys? Can everyone see my screen now? Yes, perfect. So you will find the lecture notes over here, github.com/Scalar Academy Introduction to Python. Right? And you will see that currently this repository is almost empty, but it has a link to lecture 1. As we move on, we will populate things over here. Okay, perfect. So if you go to this particular link, lecture 1, this link should be in the video description. You will be able to see how to download Python, right? You will be able to see instructions on how to install Python on your system. Okay, so this is the real Python link. This is the website for this real Python. So if I click on this link, it will open up this website, and it has a nice set of instructions on how you can install Python on your system. All right, so for Windows, for Mac OS, for Linux, it has all the instructions. You can even install it on your iPhone or on your Android phone. Okay. So once again, what I want you to do before tomorrow's class is to go to this link and see how you can install Python for your operating system. Right? And before tomorrow's class, everyone should be ready with a Python installation on their system. For today, what we are going to do is we are going to go to this particular website over here. Right? So we are going to go to this particular website. The website's name is repl.it. Okay, repl.it. Right? So if we go to repl.it, we open this page, we will get a URL, something like this. So just give me a moment. Interesting. Right, we will get a URL. I am not really sure why it is giving this URL. Just give me a second, guys. I think I'm logged in. So let me just quickly log out for you. Right? And if you go to repl.it, you should see something like this, right? Now, what we want to do is we want to click on this button so this button start coding over here, right? And when we click on this button, it will give us a prompt, right? It will ask us that, okay, I am going to create a new REPL, right? And please choose the language which you want to code in. So we are going to code in Python. So let us quickly choose Python over here, and then we will click create REPL. All right, so I want each and every one of you to do this right now. Open up your browser. In the browser, type this URL, repl.it, right? Click on create REPL, choose the language as Python, and finally click create REPL. And once you do that, you will get a screen that looks something like this. Okay. Perfect. Now let me quickly introduce several parts on the screen. There's a lot going on over here. Don't worry about all these things. Today we will be working mostly on this right hand side, on this black side. Okay. So over here, this is called the REPL. This black portion over here, this is called the REPL, R-E-P-L. REPL simply stands for read, execute, print, loop. Right? So this basically means this is an application that will read your code. So whatever you type in, it will read your code, it will execute it, it will print the results, and then it will wait for your code again. Right? So we will see what this is, but for now, this is the REPL. On the left hand side, you can see some sort of a text editor. Right? So you can see the text editor and you can see the files that are available on this system. All right, so we won't be using this left hand side for now. We will be using this right hand side at the moment. All right, and let me quickly zoom in once again. So I just want to make sure that this text is visible. Is this text visible, guys? Yes, perfect. All right. Please maximize the command window. So I'm not maximizing it. I'm just going to resize it a little bit so that it is much more clear. All right. Cool. All right. Is this better? Perfect. Okay. So let us start with the very, very basics of Python. Okay. So some people still cannot see it. Can you guys see it now? Can you guys see it now? Yes. Okay. So we are going to start with the basics of Python. So first of all, what we can do is we can treat Python as a calculator, right? You all have a pocket calculator. You can treat Python sort of as a calculator. So what we can do over here is we can come and type very simple things like 1 plus 1, right? And when we hit enter, we will get the result 2, right? Now Python is much more than a calculator, but we will start very simply. All right, if you enter 1 plus 1, you will get 2. So what other operations does Python support? All sorts of mathematical operations, right? The basic mathematical operations. For example, multiplication. So what is 10 times 20? Well, that is 200, right? So that's multiplication side. You can do subtraction. So 20 minus 14, that is 6, right? You can do division. Now division is a slightly different in Python, right? So if you do 30 by 20, you get 1.5. And in fact, 30 by 20 is 1.5. Right? Now, if you are coming from other languages like C++ or languages like Java, then you would have expected this to give you back 1. Right? So you would have expected that this will be integer division. For those of you who don't know about integer division, do not worry about it. Right? Do not worry about it right now. But by default in Python, this slash sign is the one, it gives you floating point division. If you want integer division in Python, if you want to get an integer result back, then what you have to do is you have to do this double slash. Okay, this double slash is the integer division in Python, and this will give you back 1. Right? Perfect. Cool. Now, this integer division fact, this is for Python 3.8, right? This is for Python 3. So on top, if you see over here, you can see the version of the Python that has been loaded. So it says over here, I'm using Python 3.8.2. All right. Now, if you are familiar with Python, or if you have seen Python earlier, or if you try to run Python on your system, you might be getting Python 2. You might by default have Python 2 installed. Right? Python 2 is obsolete. Please do not use it. Python 2 has been dead for quite some time. Right? Please make sure that whenever you install Python or whenever you use Python, you stick to Python 3 only. In Python 3, you can choose any version. You can choose 3.5, 3.6, 3.7, and so on. But it is always better to stay with the latest version. All right. So whenever you install Python, just make sure that you install Python 3.8. All right. Perfect. So I hope these basic mathematical operations are clear to us. Addition, multiplication, subtraction, normal division, and integer division. Right? This is the normal division. It will give you fractional values, and this is the integer division. Apart from that, we also have another operator for the power. Right? So if you might know, what is 2 to the power of 5? So 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. 2 multiplied 5 times, which is 32. So we have this operator double asterisk. Right? This operator calculates the power. All right, and this does not just work for integers. So you can calculate the square root of 2 as well. So you can do 2 to the power 1 by 2. Right? So 2 raised to the power half will be the square root of 2, and you can calculate the square root of 2 in this manner. All right, perfect. So what if I do something like this? Minus 1 to the power 1 by 2. What is this supposed to be? So this is the square root of minus 1, right? Does the square root of minus 1 exist? Does the square root of minus 1 exist? Well, depends on how much you know about mathematics, right? So in real numbers, the square root of minus 1 does not exist. But we can extend the real numbers into complex numbers. Right? And in complex numbers, we can define something called the imaginary number iota. Right? And iota is defined as the square root of minus 1. Well, Python, unlike most languages, Python by default supports these complex numbers. So if I hit enter over here, you will see that I'm getting some value. I'm getting some really, really weird value. First of all, this weird value, it is not a number. It is not a normal number. It is a complex number. So it has two parts to it. It has a bracket. In the bracket, it has one part. It has some part over here. This is the real part. Then it has a plus sign. And then it has an imaginary part, 1j. Right? Now in mathematics, you would usually write I. Right? However, I in programming languages is very frequently used as a variable name, right? As a loop variable. So Python has chosen to use the J notation, right? To use the J notation for this imaginary number. All right. So, I mean, why is this result? This is basically saying that this is 0 plus 1j. This is 0 plus 1j. Now, while calculating this, it made a very slight error. It did not give you back 0. It gave you 0 point followed by 17 zeros and then a 6.12. Right. So do not really worry about this result. This is some nuance of floating point calculations. Right. So once you study how the floating point numbers are stored in memory of computers, you will get to know that yes, errors like this are very common when you are working with any particular computer. All right, of any particular programming language. This is not specific to Python. Okay, perfect. All right, cool. So far we have covered addition, subtraction, multiplication, division, integer division, and power. And we saw that there are complex numbers as well. Okay. Now, as you had studied way back in class 3rd or class 2nd, there is something called baud mass, right? So if you want to group operations together, you can use a bracket to group operations together. In programming languages, you will always use these brackets. Right? So in mathematics, you can use these brackets or you can use these brackets as well to club operations together, to club expressions together. In programming languages, we always use the parentheses, the round brackets. Okay, so if I want to say that 2 plus 3 times 4, right, then the result I should get back is 14 because 3 times 4 will be executed first, right? Asterisk multiplication has a higher precedence than addition. Right? So 3 times 4 will be executed first. So this will be 12 and you will get 14 back. If you want to do 2 plus 3 first, then you will have to put this inside bracket, inside these parentheses. Right? So just like in normal mathematics we do, so that we can get 5 times 4, which is 20 back. All right, perfect. So I hope that everyone is clear that you can use Python as a very, very simple calculator. Now let us move on to more programming things. All right, perfect. Let us move on to more programming things. Okay, so just before we move on to programming, I just want to point out one more thing. So Sukanya has asked a very nice question over here. Sukanya asks, what is the maximum range of integer in Python? Right. So now if you are coming from languages like C++ or Java, then you are familiar with the limits that integers have. So for example, a 32-bit integer, cannot store every possible number. Right? It can store numbers only up till a certain value. So there's an upper limit to how much data you can store in a 32-bit integer. Right? Similarly, there are 64-bit integers and so on. In Python, these integers are not really limited. Right? In Python, all the integers are big integers. Right? So basically, what you can do over here is you can come here and you can calculate 2 to the power 1000. Now, 2 to the power 1000 is a pretty large number. Right? 2 to the power 1000 is a pretty large number. If you try to calculate this in C++ or Java, then it will overflow the integer. But in Python, because the integers are not limited by a particular bit size, they're just limited by how much RAM you have. Right? So you will easily get the result back. And it will be a huge, massive number. Right? This huge, massive number over here. Okay? Perfect. Cool. Now, one tip. If you are in this REPL and you want to clear the screen, right? Currently you see some output. Right? If you want to clear the screen, if you want to get rid of the output, what you have to press is Control and L. So Control plus L. That is what you have to press. Now, if you're on Mac OS, you might call that Command plus L. Okay, if you're on Mac OS, you will call it Command plus L. But on other systems, Windows and Linux, you will press Control plus L. So I'm just going to press Control and L, and you see that whatever was there on the screen, it has vanished. All right. Perfect. Harsh is asking, so is the maximum 2 to the power 32? No, Harsh, the maximum is not 2 to the power 32. In some other programming languages that have 32-bit integers, if you have a 32-bit integer, the maximum number you can store is 2 to the power 32. But Python can very simply store 2 to the power 33 and any larger number as well. Okay. Perfect. Okay. So moving on, let us move on to some more programming related things. So let us quickly introduce variables. Right? Suppose that you wanted to calculate the area of a rectangle. Right? So what does a rectangle have? A rectangle has some width, it has some height. Right? So you all know about rectangles, they have some width and they have some height. And how do you calculate the area of a rectangle? The area is width times height. Right? So what you can come over here and do, and you can declare a variable. So a variable like width. You can type width and you can put the equals to sign 2. Right? Width equals to 2. Now this is not the mathematical notation. If you are familiar with college level algebra or class 10th level algebra, then you might assume that we have written an equation here. We have written that the width is always equal to 2. That is not what we are saying over here. What we are saying over here in programming, this equality is saying this is an assignment operator. What we are telling it is take this value 2 and put it in this variable width. Right? Or basically, this value 2 can also be called by the name width. Okay, that is what we are saying. Similarly, we can come over here and say height equals to, let's say, 40. Right? So we can say width equals to 2, height equals to 40. Now, if you want to calculate the area, we can come over here and say, okay, take the value which is in width. Take whatever value is in width and take whatever value is in height. And when you press enter, you will not really get anything. If you want to print out the value of area, you can type out area over here and it will show you that yes, area is 80. Okay. Yes. Right. So there's one thing that I want to introduce to you. So back when we were doing simple calculations like 1 plus 1, the result was printed out. Right. But when we did this area equals to width into height, the result was not printed out. Right? So this is specific to the REPL. This is specific to the environment we are currently working in. Right? So in this environment, if there is a result and you assign it to a variable, right? If you calculate 1 plus 1 and then you assign it to a variable, then it won't be printed out. Right? Then you will have to manually print it by telling X, right? By saying X or by saying the name of the variable. Right? On the other hand, if you do not assign it, then it will directly be printed out. All right. Perfect. So I hope this variable example is clear. Width equals to 2, height equals to 40, area equals to width times height. Yes. Perfect. Now there is one more variable over here in the REPL when you are working. Suppose you wanted to get back the last thing that you have calculated. Right? Suppose that you wanted to get the last thing that you have calculated. So I calculated 2 plus 32. Right? And the result was 34, but I did not really save it anywhere. I did not really save it anywhere in any variable. Well, the Python REPL will automatically save it in a variable called underscore. Okay, so you do see the symbol underscore over here. So underscore, if you put underscore over there and press enter, you will see 34 printed out. So whatever was the last result that you calculated, Python will save it in this variable called underscore. All right. Perfect. All right. Cool. So I hope this is clear. Let me quickly clear the screen. So I'll press Control L to clear the screen and everything is gone. Okay. Now let us move on to something more advanced. So basically, let's talk about strings now. So whenever we are doing programming, the first program that everyone writes is called a hello world program. It's called a hello world program. So in Python, the hello world program goes something like this. You type print, then you type a open parenthesis, an open quotation mark, hello world, right? Then a close quotation mark, then the close parenthesis, right? There are no semicolons in Python, right? I mean, you can put a semicolon, but it will be ignored. Okay, you don't really need to put semicolons in Python. So when you press enter over there, you will see hello world printed out to your screen. All right, you will see hello world printed out to your screen. So let us basically talk about what this is. Let us talk about what we wrote over here. So print is a function. Right? Print is a function. Right? We will come to what functions are and how to define functions, how to define our own functions. We will come to that. Right? This thing over here, including this quotes, right? So this quote, hello, just give me a second, guys. Right? Quote, hello, world, right? This thing over here, including the quotes, this is known as a string. So you might be coming from other programming languages, so you might already be aware of strings. A string is nothing but just a sequence of characters, right? A sequence of letters. This is string. Okay. So basically, a string is another data type in Python. Just like 1 plus 1 gives you back a result. That result will be an integer. Right? Similarly, if you do 1 plus 2.5, that will give you back a result. The result will be a floating point number. Similarly, this hello world in these quotes, this is a string. And you can assign it to variables as well. So you can say my string equals to hello world, right? Hello world. You can come over here and say that. And now if you want to print the value of my string, you can do print my string, right? And it will print hello world. Is that clear? Yes. Okay, so some of you are worried about what just happened. A black screen came up, right? This black screen came up and I entered a command and exited. Don't worry about that. That is just something I will need to do from some time to some time in the background. Okay, don't worry about that. All right, cool. So you can have strings and you can store the strings in variables as well. Now, one thing that you will notice is I use this underscore thing over here. Right? I use this weird symbol underscore in the variable name. So this is known as the camel case. Camel case. Right? Different programming languages have different styles. They have different styles of coding. They have different patterns and they have different. They have different styles of coding basically. So in something like Java, you will use a variable name that looks something like my string, right? But in Python, we prefer using underscore. So we will write my string. Okay, so this is very, very important. If you write a Python program in camel case, people are going to be very upset, right? So please make sure that you always write snake case. So this is the snake case. It has snakes in between, underscores in between. Okay, perfect. Moving on. So now that we are talking about strings, let us talk about what these strings are. Right? So if you want to talk about a string, if you want to declare a string, if you want to write a string, you always have to include it. You always have to enclose it. You always have to enclose it in these quotes. So on the left hand side there must be a quote, and on the right hand side there must be a quote. Okay, so this is how you put a string. So basically, if you do not put a quote on the right hand side, then it will give you an error. If I do not put a quote on the right hand side, it will give me an error. It will give me a syntax error saying that, okay, I was trying to find a quote over here, but I did not find any quote. And I encountered the end of line. Okay, cool. Now, this is one way you can talk about strings in Python, but there are many, many other ways. Right? There are many, many other ways. For example, in Python, you can also use the double quotes. Right? So there are two symbols. There's the quotation mark and there's a double quotation mark. You can also use the double quotation mark in Python. Well, this is perfectly fine. Now notice that even though I entered double quotation, right, in the output, it gave me back single quotations. In the output, it gave me back single quotations. These are exactly the same. Right? A string with a double quotation and a string with a single quotation, they're exactly the same. It is just that you can use whatever you want. If you want to use single quotation, you can use it. If you want to use double quotation, you can also use it. Idiomatically, right? Most Python people prefer using the single quotation mark. Okay, perfect. So let me clear the screen once again. Control L, clear screen. Okay, so suppose that I wanted to say hello. So I wanted to, so suppose that we have Lakshay in the chart over here. Right? I wanted to write a string like Lakshay said hello, right? Hello, right? So I wanted to say something like this. So notice that in this string, I want these quotations. I want these quotations to be a part of my string, right? In Python, I can do this very simply. I can start my quotation. I can start my string by this quotation. I can say Lakshay said hello, and I can end it like this, right? So I will get Lakshay said hello, and it will have these quotations. If I print this variable, it will give me Lakshay said hello. Right? This will be printed out. Right? Is that clear? Now this is possible. This is possible because our strings are currently delimited by single quotations. Right? Had you started your string by double quotation, Lakshay said hello, right? And if you try to do something like this, then you will get an error. Why will you get an error? Because what Python thinks is that, okay, your string started over here and it ended over here. Right? It ended over here. Then there was some weird thing. I don't really know what this is. But then another string started over here and ended over here. Right? So Python is confused what really happened. All right. So whenever you encounter situations like this, for example, if you have this single quoted string, if you have something over here, right? Something over here, and if you want to include some quotation, right? Single quotation over here, then how will you do that? Right? How will you do that? You will escape it. So you'll have to escape these characters. These are special characters that you have to escape. How do you escape a character? You put a backslash in front of it. Right? Notice that this is not a forward slash. This is not the division symbol. Division symbol is called a forward slash. This is the reverse division symbol. This is the backslash. So if you escape it like this, now this thing works. Okay, now this thing works. All right. So once again, this string that we had over here, which Python was earlier confused by, right? Python was earlier confused by this particular string. Just give me a second. So my bad. So Python was earlier confused about this string. Lakshay said, right? Hello. Okay. So if I want to fix this, I just have to escape this quotation and this quotation, right? And now Python will be happy. Is that clear? Perfect. Now, this is not the only type of string that Python supports. Python supports a lot of varieties of strings. So Python supports something called f strings. Python supports something called byte strings. Right? Python has, raw strings, right? And many other things. Okay. So Python has a lot of variety of strings. As we move on throughout the course, we will be discussing these variants. Right? So in fact, we will be seeing f strings today as well. All right. But I hope that most of the things about strings are clear. Okay. Now there's one more thing that I want to introduce, which is the comments. So in most programming languages, when you're writing your code, right, you might want to describe that code. You might want to talk about that code or basically explain that code, right? And whatever you write, you want it to remain with your code. You don't want to put it somewhere else, right? And so the issue is that you don't want those comments. You don't want those explanations to be executed by the computer. Right? Those are just some comments that you have placed for your understanding. So every language supports some sort of a comment syntax. Right? So in Python, the comments are done by using this pound symbol, this hash symbol. Right? So if I do something here, right, I can write anything here, and Python will ignore it. Okay, so it will not execute this line. Any line that has this hash, it will not execute this line. And I can go a little further. So I can say 1 + 1, right? And then I can put a hash, and then I put something here. Right? So in this line, this part will be executed. Right? But everything that is after this hash, will be ignored. Okay? So if I do this, I will get back 2. This something here will be completely ignored. All right? Perfect. So these are comments in Python. Now, most languages have a multi-line comment as well. Python doesn't really have a multi-line comment syntax. Right? Python doesn't really have a syntax for multi-line comments. All the comments in Python are single line. So if you do something here, right, something here, right, it is not the case that you can add a new line over here. It is not the case that you add a new line over here. If you want to add a new line, you will have to type another hash symbol. If you want to move the comment to the next line, you will have to put another hash symbol. Otherwise, it won't be considered a comment. All right. There is a different thing that we use in Python to represent multi-line comments, and that is the triple quoted strings. The triple quoted strings, let us not worry about them right now. Okay, as we move on, we will discuss more on that. All right. Perfect. Perfect. So I hope this is clear. The strings part is clear and the comments part is clear. Now let us move on to very, very simple input and output in Python. Right. So before we move on to input and output in Python, let me quickly show you, if you want to read something, if you want to read a particular value in Java, what you have to write. Right. So I'm just going to compare the languages over here. So in Java, you would do something like this: import java.io.star. Right. Then you will do public class main class. Right. You will do public static void main string args. Right. You will do throws IO exception. Right. And in there you will do something like buffered reader br equals to new buffered reader new input stream reader reader system.in, right? And then when you finally want to use something, if you want to read something, you will say string input, string my input equals to br.readline. This is what you will have to write in a language like Java to read a simple value, a simple string from the user. Now this is horrific, right? This is horrific. In Python, you don't have to do any of these. In Python, you don't have to do anything that complicated. Python is very simple. It is very elegant. Basically, what you can do is you can simply do input, give me a string. Right? You can do as something as simple as this. Right? You don't really have to put this as well. So you can remove this. You can remove this as well. So if I just write input with these two brackets and I hit enter, it will wait. Right? It did not give me anything back. The reason it did not give me anything back is because it is waiting for an input. Okay, it is waiting for an input. So I can give some input over here, some input over here. And when I press enter, this input will be returned to me. Right? This function will give me back whatever I have inputted. Sorry. I can also store this in a variable. So I can say x equals to input. If I do x equals to input, it is once again waiting for input, and I will have some value over here. Right? And when I press enter, this value has been assigned to x. So if I do x over here, then you will see that okay, this x has this value. Right? Perfect. Now when you are so it doesn't really look nice, right? When I did some input over here, it doesn't really look nice that the person does not really know what to do. It tells me nothing. It just waits around. Not the best thing. So what I can do over here is I can come and say input, and I can give it a prompt. Right? I can give it a prompt like give me a string. Okay. So now when I press enter, this prompt will be displayed. This prompt will be displayed so that the user knows that okay, I have to enter something. So something is entered. Right? Now once again you will see that all right, this does not look pretty. Right? This does not look pretty. So usually in your prompt you would want to include a space at the end. Right? You would create something like this. You would write something like this. So you will in this string itself you will include a colon and a space so that you get this pretty output over here. Right? So that if you type something, then it is clear that okay, this was the prompt and this was the input. All right. So this is the basic way we do inputs in Python. Cool. Now, suppose you want to read an integer, right? Suppose you want to read two values. Suppose you want to read two numbers and you want to add them up. Okay. So let me just clear the screen. So what will you do? If you do A equals to input, right? So let me enter 10. And if you do B equals to input, let me enter 50, right? And if you try to add them up, A plus B, right? If you try to add them up, you get this weird result 1050. 10 plus 50 is not 1050, right? 10 plus 50 is 60. Right? So what happened over here was whenever you do an input, the value is returned as a string. Right? So don't worry about what I'm typing right now. But if I ask for the type of it, right, then it will say that, okay, it is a string. Okay, what I am trying to get as input is a number. What I am trying to get as input is a number. So for example, a thing like type of 10, this will be an integer. So I'm trying to get an integer. So what you will have to do is you will have to convert this number into an integer, convert this string into an integer. The way you can do that is simply put the int function around it. Right? So if you have int 10, right, if I have int 10, it will give me back the number 10. Okay, I give it a string with 10 and it will give me back a number with 10. So I can come over here and say a equals to int input, right? And now it will wait for an input. It will take that input, it will convert it into an integer, and then it will save it in the variable a. Is that clear? So if I press enter, now I can enter a value 1024, and now a has an integer. If I ask for the type of a now, it will be an integer. All right? Perfect. So what we are going to do is we are going to say a equals to int input, right? And so we have some value over here. B equals to int input. We have another value over here, and now we can do a plus b, and it will give us back the result 30. All right, very basic stuff. Okay, moving on. So now basically what I want to introduce is, so this still feels a little weird, right? This still feels a little weird that when we ask for input, we have to give the input immediately. So now let us move on from the REPL. So this black portion is called the REPL. Let us move from this to a file. On the left, you see main.py. This is a file. This file is stored over here. Okay, this file is stored over here in this directory, files. All right. So let us try to write our programs over here in the left part. Okay. So I can write the same program in the left part. I can say a equals to int input, right? And over here you will see something popping up. So this is called IntelliSense. This is called autocomplete. Right? So your editor, if your editor is good, it will try to tell you, it will try to give you some documentation, it will try to help you in writing the code. Okay, so it will tell you that this int function, this converts a number or string to an integer. Right? Similarly, if you go to this input function over here, right? If you go to this input function, it tells you that this reads a string from the standard input. All right. So I can come over here and I can say a equals to int input, and I can say b equals to int input. And then I can say print, I can actually say a plus b, right? Now let me try to run this. So to run this, I will hit this big green button over here. Right? I will hit this big green button. Now, when you have Python installed on your system, finally, this is not, I mean, there will be no big green red button over there. Right? So we will see how to run the Python from our terminal, from our command line, when all of you have installed Python. Right? So in the next class, we'll see how to actually run Python from the command line. But for now, to run this program that we have written in this file, all we need to do is hit this button. And as soon as we hit this button, you will see that nothing is really happening. That is because it is waiting for input. Right? It is waiting for input. So I can give it a number like 5, I can give it a number like 6, and it ends. It doesn't really give me anything. It doesn't really give me anything. The reason it doesn't give me anything is because I have not printed out these results. Right? I have not printed out this result. So when we were in the REPL space, if I did 1 plus 1, the REPL automatically printed out the value. Right? The REPL automatically printed out the value because the REPL is sort of interactive. Right? This will not happen in Fusion. When you're writing actual code, if you want to print, you have to specifically tell the computer to print. So if I come over here and I say print, right now if I execute this program, the program will print. But before that, let me make one more fix. So let me come over here and give a prompt over here. Right? So I can say enter first number, right? And I can come over here and say enter second number, right? And now when I execute this program, you will see that, okay, now I get a pretty prompt over here. Now I get a nice prompt over here. Enter first number. My first number is suppose 12. Enter second number. It is suppose 54. Right? And then it will give me the addition back. 12 plus 54 equals to 66. Is that clear? Yes, this is how we do input and output in Python. Simply the input function. If you want to convert it into an integer, you pass it into the int function. Right? And to print something, you simply print the value. Okay? Very simple. Perfect. So this is basically what I want to leave you with today. I mean, today we just covered the very basics of Python. Going forward, we will step up our pace. So towards the end of this particular video series, what we want you to do is we want you to create a complete web application in Django and deploy it. Right? So you will have your own website up and running. Okay. So to do that, we will have to pace things up a little. Do not worry though, if you have any question whatsoever, right, feel free to post it in the chat. Okay. During the class, if you feel that I'm going too fast or if you feel that something is not clear, feel free to ask a question in the chat. Questions are always welcome. All right. Now, once again, before tomorrow's class, what all of you have to do is you have to go to this particular link, Real Python, Python 3 installation and setup guide. Right. So the URL for that is realpython.com installing Python. Right. Realpython.com installing Python. This is the particular link. Okay. So just go over there and see how you can install Python on your operating system. All right. So once you're done with that, we will resume the class tomorrow. There's one more thing. So if you look in the video description of this particular video, you will see several links. Right? So first link will be to this particular, one of the links will be to this particular repository. Right? One of the links will be to this particular GitHub repository. It will start with github.com. Okay. There will be another link. That link will take you to a discussion forum. That link will take you to Scalar chat. Right? So that link will take you to an interface, chat.scalar.com. So that is a community where you can come and interact with other students. Right? So whoever is watching this YouTube series, those people can come over there. They can chat live with each other. Other students who are at Scalar Academy, right? So at a tech university, those students will be there, so you can chat with them as well. The TAs, the mentors, the instructors, right? Me included. So we will all be present in the chat. So if you have any questions, any further questions, anything that you would like to ask, anything that you would like to clarify, anything that you need help with, just post it over there and we will be able to reply to you. All right. So links in the video description, and see you tomorrow, same time. Okay, 6:30 to 7:30 is the class. Tomorrow we are going to pace it up a little bit. Please make sure that you have Python installed. Perfect. So let us end the class and see you tomorrow, same time. All right. Bye-bye.
Basically, we'll start with the recap for the previous session. Let's just begin with the recap from the previous session. So basically, we discussed about variables in the yesterday's session. Let's say that a variable lecture day is 2, and we try to print this variable. So what do you think will be the output for this? So I'll be using VS Code as my text code editor. And basically, we have this integrated terminal here. And to run the file, I can just say Python 3 and the file name. So it gives the output as 2, right? So now basically we also learned about numbers. So numbers which can be integers, float, or complex, right? So if you remember, let me create a variable square area that is 36, right? And let me create a variable circle area that is something like 6.28. And let's say iota is -1 raised to the power of half. So if we try to print out all these variables, let's say I print out square area and circle area, and then let's say iota. So what's going to be the output? So if we use a comma in the print statement, basically that separates all those variables by a space. By default, end line is the separator. So using a comma here, we can print multiple variables directly. So if I run this program, I should get all these variables 36, 6.28. You see there is a space here. Then again, there is a space here. And you can see that we get the third variable, that is iota, which is a complex number, right? So numbers can have these 3 types. So all good till this point. Any doubts about variables and numbers? So we also looked at some basic mathematical operators. So for example, we looked at plus, we can say square area plus circle area, right? So this should basically give me 42.28. So if I try to run this, I will get a 42.28 here, right? So any issues till this point? Great. So let's also see, we also looked at some other mathematical operators that we can use. Let's say 4 into square area. And then let's say we try to use the division operator, iota by square area. So you see that it will give you these three lines, right? And you can remember that by default end line, or basically end line is basically \n. This is the default separator. So whenever you print anything, by default you will see a \n, that is a new line, right? How to print new line? Okay, Rohit is asking a question. Rohit says how to print output in new line without multiple print statement. Okay, so for that basically we can use, let's say we can use the format strings. So let's say I can say print f, and basically what I will say is, let's say I want to print out square area, circle area, iota. So I can say square area, then a \n. So whatever is inside these curly braces will get printed. Then circle area, \n, and then iota. So let's try to run this. I'll just use an integrated Python interactive. So VS Code also provides this Python interactive shell. Right from the file we can use this. Let me show you the output of this. Just, it's taking a few minutes. Yeah, so you can see that. Okay, square area, I think square area is defined here. Let's just try to print square area till this point. Okay, basically I have to rerun all these things. Let me just rerun all the code from the beginning. Okay, let's use that one only. This is a little slow here. Let's use the terminal itself. That would be easy. Yeah, okay. So let's try to run this thing now. So it should basically, we are doing here a formatted string, right? Whatever is inside the curly braces will get printed, like whatever is the value of that variable. So you can see that all these three values, 36, 6.28 and iota value gets printed here, right? So that's how we can use formatted strings, or we call them F strings, right? So you also learned how to take input from the user. So basically about end and separate keywords, Harsh, you can try to look up the documentation, right? Let's continue. We also learned about taking the input. So let's say I want to take two numbers as input from the user. So number one is int of input. Number two is again int of input. And then I try to print their sum. So that's how we can do this. And now it is asking, it is basically waiting for an input from the user. So let me give 100 and 200. So you see that the output gets printed here, that is 300. So Arijit, the issue here was not this. I basically switched to a different, like I tried to run the file in a different environment. So that's why I had to redeclare. Yeah. So let's continue. Print number one from plus number two works here. So that's how we take input from the user. And one more thing, like there is one special value that is equal to none. So that here basically means nothing. So like in other languages, you have null. So it is something like that. So if a variable has no value, we say that it has none value. Okay, it's waiting on input 2 and 3, 5. And finally, you can see that none gets printed here. So a variable which has no value, we give it the value none, or it will have the none value, right? So Himanshu is asking which editor are you using? I am using the VS Code editor. How to take inputs in a single line. Harsh, we will look at that later. Sai Teja is asking where can I access the lecture notes? You can access them from the Scalar Academy Intro to Python repository. Tarun, if you couldn't understand anything, just look at the lecture notes once. Like if you have started, this was just a recap of the previous session, right? So maybe you might have to go back at the previous session once to get these things in detail. So let's continue. Now we will start with control flow today. So we will be basically be learning control flow. Yeah, so Aditya is asking about certificates. So one basic announcement here for today's session is like we will be providing you some digital certificates which you will be able to access after the end of these all the sessions that we will have. So after the entire series on Python gets ended, you will be having a test. We will be creating a test that you can access, and that will test basically will assess what all you have learned from the sessions, right? So if you will be able to score above a threshold, you will be getting that certificate. So that we will be sharing complete details at the end of the lecture series, right? So Rahul, just try to think about that once. Yeah. Will the notes be there on GitHub with the name? Yeah. So notes repository, you can see. Let me also add it here. You can see the lecture 2 notes in this, right? So let's continue the session. Basically, let's now go to operators. So we'll first look what operators basically are there. We just saw the addition, multiplication, subtraction, division, integer division, these kind of operators from yesterday's class. So today we will be continuing and building upon some more operators which we need to basically do control flow. So our main agenda for today is understanding control flow. So let's start with some of the operators. We'll look at some relational operators first. So relational operators are basically like less than, greater than, equal to, less than, equal to. So let us say you have a variable a equal to 3, right? And you want to know whether a condition a less than 3 holds true or not. So you can just create a variable less than 3 and say a less than 3, right? So this equal to is basically an assignment operator. So equal to is an assignment operator. It is not checking for equality, it is assigning. So if I say a equal to b, so what basically happens is this variable a gets the value b. So value b gets assigned to the variable a, right? Value b gets assigned to the variable a, right? So what do you think will be stored in the variable less than 3? So basically, there are two type of Boolean variables that come into picture here, true and false, right? So a condition would have either a true value or a false value. So here a less than 3, what do you think? A less than 3 is true or false? So what should be the output in variable less than 3? What do you all say? False. So everyone says false, right? So let's try to print the variable less than 3. And also let's try to print what is the type of variable less than 3, right? So let's try to see Python 3 operators.py. So you can see that the output is false and the type of this variable is class bool, right? So this variable basically stores a false value, a Boolean false value, right? Had it been a less than equal to 3, the value here should have been true, right? So that's how you can use the conditional relational less than and less than equal to operator. Similarly, there is greater than and greater than equal to, right? Now, there are two more operators that are equal to, double equals, and not equal. So let's say we want to check whether a equals to 3. So equals 3. So I can simply say a equal to 3, right? So this condition gets evaluated and then this gets assigned into this variable equals 3. So if I try to print out equals 3, this should give me the variable result true. So as you can see, it is true. Let me comment out the above ones. So you can see a is equal to 3. So that's why this variable equals 3 gets me true. So now what if, let's say I say equals 3 is a not equal to 3, right? So then if you, let's say not equals 3, right? So this variable exclamation equal to refers to the refers to the relational operator not equal to. It will return true if a is not equal to 3. So let's say if we try to print not equals 3, it should give us a value false. Why? Because a is uh, not equals 3, right? A not equals 3 is false because a is equal to 3, right? Had it been 5, so if a had been 5, that it would, then it would return true, because 5 is not equal to 3. That means it is true, right? 3 is not equal to 3 was false. So any doubts till this point? Everything is clear till this point? Shall we resume? Okay. So similarly, we can compare strings as well. Okay. Similarly, we can compare strings as well. So let's say that we have two strings. Let's say we have string 1, s1 equal to interview bit, s2 equal to scalar. So when we say print s1 is less than s2, so what it will does is it will compare the strings lexicographically. So in the dictionary order, basically it will check starting from the first character if I is less than s. So basically I is less than s, so it will return true. So as you can see, the last print that will be giving us true, right? So had I been using here, let's say s1 is small s, right? S1 is scalar and s2 is capital S, right? So then basically what happens is then this will print a false. Why? Because small s is not less than capital S. So in computers, basically in programming, the characters are stored in ASCII format. So you can just remember this. This is an American standard code for information interchange, and basically the capital letters come before the small letters. So you can just remember this fact and try researching more about this, right? So let's continue. If everything is clear, if you have any questions, please ask. Okay. So let's now continue. We will resume with the control flow. So now we have learned about some of the operators. Okay, let's also look at some of the logical operators. So there are three more logical operators that are and, or, not. So basically, before we get to control flow, we must know how to operate on these conditional or the logical operators, right? So if you can see, let's say we have a variable x equal to 5, and I say result 1 is simply nothing but x is less than 1 or x is greater than equal to 10. So what do you think is going to be the output of this variable? So here what we are doing is we are combining two conditions. So this will be having one result, one Boolean value. This will be having another Boolean value. So when we say two Boolean values or, so that will return true when either of those Boolean values is true. So here x less than 1 is false, x greater than equal to 10 is also false. So both of them are false, so the output should be false. So you can see that the last statement returns a false, right? So if I had said that x is equal to 11, so then it would be giving me a value of true. Why? Because the second condition, x greater than equal to 10, now returns a value true. So either of the two conditions have to be true for the or operator to return true. Similarly, for the and operator, both of the conditions have to be true. So if I now say x less than 1 and x greater than equal to 10, and I try to print result 2, so it will basically give me a false value here. Why? Because x less than 1 is now false, right? So this and operator will give an output of true when both of the conditions are true. So any doubts till this point? Yeah, Pratham, you are right. If the first character equal, then next. So that is how the strings will be compared lexicographically. You're exactly right. So there is one operator not as well. So that will basically return the negation or the opposite of the condition. So let us say if I say print not of result 2. So that should basically print a true here because result 2 was false, right? So you see the last one will be returning a true here, right? So let's continue. Now you have learned about the logical operators, and the relational operators, we are good to go for understanding conditionals. So basically, the motivation behind the conditionals is that in our general life also, decision making plays a very important role, right? So in general life, in real life, we have to make a lot of decisions, right? So in programming also, we have to make a lot of decisions, and depending upon the output of a particular condition, we will be evaluating a condition, and based on the output, we'll be going to some part of the code, and if that condition is true, then some part; if it is false, then some part. So likewise, like, let's take a example. So let's say that your mother tells you to go to vegetable market and says that buy for buying some vegetables, and tells you to buy cabbage, and also says that if cabbage is not available, then buy broccoli. So you have to go to market. You first ask whether whether the cabbage is available. If it is, then you will buy that. Otherwise you will buy broccoli, right? And in the third case, when none of these is present in the vegetable market, you will simply come back home without anything, right? So these conditionals uh, are very important in real life decision making and also in programming, right? So that's why we have the constructs like if, else, and else if. So in Python we will have elif for using else if. So first, let's simply write down a program that takes an integer as input. So we are taking an integer as input, and if this integer is less than 1, so there is a parameter x, and if this parameter x is basically less than 1 or greater than 10, so then the message is rude. So let's say we'll have to print that the message is rude, right? Otherwise it is a polite message, right? So what we can say is if x is less than 1, so whatever is the condition, so this condition will get evaluated. As we have seen in the operators, there are these conditions that we check, right? So it will have a boolean output, true or false, right? So this condition gets evaluated. Now after this, what piece of code gets executed? So you have to write a colon. So the syntax is if followed by the condition, then you write down a colon and then you press enter. So if you have if you are using some code editor, it will automatically give some indentation of 2 spaces or 4 spaces, right? Otherwise you just press a tab, right? So whatever is inside if, that will have to be indented to either two spaces, 4 spaces, something like that. So whatever is inside here now will be the part of if. So if x is less than 1, let's say uh, this is the block of code which gets executed if x is less than 1, right? So we can say if x is less than 1, print that it is a rude message, right? Oh, sorry, yeah. Thank you, Rohit. It is input. Yeah. So otherwise, if x is greater than 10, then also we will say that it is a rude message, right? So that is one straightforward way of doing this thing. So let's try to run this program. So I provide the input, let's say I say 14. So it will give me rude message. Let's say I give -1, it will say rude message. Let's say the input is 5. So it will not print anything, right? Piniseti has asked one doubt. When I press Control I, instead of clearing the screen, it's displaying Control L. So you can just type clear. If you are in the Python prompt, you can just type clear. Okay, so you can, I think you can say Control C, CTRL plus C. So just look it up. Or from Control D, you can exit the Python console REPL, and from Control C, you can give an interrupt, right? So let's continue. So do you see a problem in the above code, right? So first of all, uh, so Tawfiq is asking a question that according to previous lecture, after hash, all terms will be ignored. Okay. Is my screen visible to you clearly? Okay. So let's continue. So basically, after hash, whatever is there is a comment, right? So only this line of code will not get executed. Only the line number 8 is a comment and does not get executed. Does that make sense? Just give me 1 minute. Okay. So basically only this line is a comment and this will get executed, right? So whatever is inside this block, let me say print hello world. So this also will get printed, right? So let's try to run the program. Sorry, I'll say Python 3 conditionals.py. Let's say we give the input 10. So it will print nothing because none of these conditions was evaluated to false. Let's say 11. So both these statements get printed, right? And let's say minus 10, then also both these statements get printed, right? So if I have something here, print I, that will not get printed, right? If I say minus 10. So only these two lines get printed. So I hope that answers your question. So let's now continue. Fine. So the issue with this piece of code is that there is a redundancy in this code, right? So the redundancy here is that you are having the same line of code repeated multiple times, right? This line of code is being repeated multiple times. So let's say that once you have to change your program and like, let's say somehow you have to print some other message and you forget changing the line here, right? So that will lead to an inconsistency, right? So redundancy always leads to inconsistency in code, right? So the better way here is to combine these conditions, right? If x is less than 1 or x is less than 10, then print rude message, right? So this is a better way to write down the same piece of code. So it will work the same as before, but it will be a better coding practice, right? Sorry, it should have been x is greater than 10, right? So I hope you understand this part. So let's now continue. So Bayagani is asking what is the name of that compiler. So this is basically VS Code I'm using and I have installed Python 3 over here. This is not a compiler. Yeah, this is a VS Code code editor that I'm using. Yeah, editor is VS Code. Python is basically an interpreted language, right? Yeah, right. So it's VS Code. Yeah, Rohit. So let's continue. So again, the issue here is, let's say that we also had to print a polite message in the other condition. So let's say that our requirement gets changed and we have to print polite message for all other cases. That is 1 less than equal to x, less than equal to 10. What I can say is if x is greater than equal to 1 and x is less than equal to 10, right? So in this case, we will simply print polite message, right? So let's try to run this piece of code. Let's say 5. So you will see a polite message comes here. Let's say 11. It will give us rude message. So now this code works. But what again is the issue here is it is not that robust. So let's say our condition gets changed. Let's say this condition gets changed somehow. The rude messages come outside the ranges. Let's say minus 10 to plus 10, right? So then we will have to change both these if conditions inside both of these. So robustness is not handled here. So that is why there is another construct that is known as else, if else. So what we can say is after else, we will write colon again. So whatever is inside this else block will get executed when this condition fails. So now we have something to handle the case when the condition returns false, right? So either this gets executed or this, right? So let's try to run again. At 5, it says polite message. 11, it says rude message. So I hope you have understood a basic idea of the conditionals, right? So anyone has any questions? Great. So let's continue. So now there is one more thing. So let us say that our condition of rude message gets changed now. Now let's say that rude message is only for x is less than 1. So we'll say if x is less than 1, then print rude message. and the condition for polite message is same. So else, so what we can do is there is another construct that is else if. So we write it if elif, and we can say the condition x is greater than equal to 1 and less than equal to 10. So what we now have is in the else block also we are checking a condition. So if this condition is false, then our control flow will get to this line, it will check this condition, and if this is also false, then we'll get here. So here we can say that other message, right? So now let's try to run this program. Shashwat says, can we put semicolon in place of colon? No, we cannot do that, Shashwat. So the syntax is you have to print colon to indicate that a new block is starting, right? Vikas, VS Code is basically a code editor where you can write code and it provides an integrated terminal so that it becomes easier, right? So let's continue now. Let's say Python 3 conditional.py. I'll say -10, it will give a rude message. If I say 5, polite message, and if I say any other value that is greater than 10, let's say 11, so it will say other message. So the control flow is first this condition gets evaluated. If this condition is true, then this gets printed and we will get to line number 16 or 17. So if condition at line 10 is true, we'll get to line number 16 directly. So let's have something here, print outside loop. So now let's try to evaluate all three cases. So if I say -10, so it will print rude message and then outside the loop, right? And again, let's say I say 5. So what happens is the first condition returns false. So then we'll check the second condition. So it is now the second condition returns true. So we'll print this and we'll get outside the if else ladder, right? So this is basically what we sometimes call if else ladder, right? First this condition gets executed. If this is false, then this. If this is false, then this, likewise. So if I now say let's say I say 11 or 101, so now both these conditions will return false. We'll check this is true, right? So I hope you have understood a basic idea of control flow. Dhruv was asking a question. The if we used earlier were two separate things, while if and else were interlinked. Yeah, Dhruv, you are exactly correct. If is a statement, not loop. Yeah, if is a statement. Manas, you are exactly correct. If is a statement, not a loop, right? So let's continue. So basically, now I hope you have a basic idea. So now let's try to implement that market situation that we were saying. So let us say that our market has these following vegetables. Vegetable market contains these vegetables. So now what we'll say is, if let's say we were to buy carrot first, if carrot, so there is a construct. So basically vegetable market is a list that contains a list of vegetables. So we will go about lists in the next session. So where we'll see lists, it is a list of strings, right? So we'll understand more about lists in the next class. So if carrot is present in the vegetable market, then we can simply print that we bought the carrot, right? Otherwise, we will check else if broccoli or let's say cabbage is in the vegetable market. Then we can simply say print bought cabbage. And otherwise, when none of the conditions falls true, we can simply say that came back empty-handed, right? So this is the scenario that we were trying to simulate, right? So let's just see. So basically, currently, carrot is basically, let's see. Carrot, you see, it is not in the market, right? So we will buy the cabbage. So it will print bought cabbage, right? So let's say if we remove cabbage also from this vegetable market, it will say that came back empty-handed, right? So you can try to explore about lists and this in operator. We will try to cover it in the next session. Let's continue from here. So now we will look at another interesting control flow, that is loops. So loops basically we use very often in programming, right? Yeah, loops. Let's try to get to loops. So basically, frequently we want to write down a program that is doing repeating some piece of thing again and again, right? So basically, like, what is a schedule of a software engineer or a programmer? He wakes up in the morning, he basically has food, starts writing code, and then basically likewise sleeps at night, and the same procedure keeps on repeating again and again, right? So we are repeating some piece of thing again and again. So in real life we do so, and similarly in programming we need to have this thing, right? So we want to write down a program that will repeat some piece of thing. So let's say you are playing a game in which you get a score of 2 points for every 1 second. So let's say you play a game where you get 2 points after every 1 second, as long as you are alive in that game, right? As long as you are alive in the game, right? So how will you write? So the game developer will basically have some logic that after every 1 second, this score variable will get updated. It will get added. 2 points will get added to that score variable, right? So we need loops frequently in programming. In whatever software you see, loops is very common, right? So let's say that we were trying to print two variables onto the variables from 1 to 10 onto the screen. So we want to write down a program, print numbers from 1 to 10 to the screen. So one basic approach is you will say print 1, print 2, print 3. You will continue like this. You will say print 10, right? So let's see. So it will take a lot of time, right? And likewise, you will write a lot of statements. So how we can do this simply? We have loops, right? Loops comes to the rescue here. So we have for loops in Python or while loops. So let's say that we first look at for loops. So for loops are the ones which we use when we are sure about when our loop will terminate. So in this case, we know that after 10 iterations, our loop will terminate, right? So we have to iterate the print statement 10 times, and that will be printing some variable which will get on incremented each time, right? So there is a range keyword in Python that basically allows us to create a list of numbers onto which we can iterate. So in Python, unlike other languages, so if you are from C++, you have seen something like this. You can write down a loop like this. So if you are from C++ or some other background like C++, Java, you must have seen some programs like this, right? But in Python, you do not have these three things. You do not have initialization, condition, and the updation. So in Python, basically, you have to iterate over some sequence or some container. So iterate over some container, values in some container or a sequence. So this range keyword will be very helpful here to create a range of 10 values in which you will iterate. So what we can say is for I in range 10, we can say print I. So let's try to see what will be the output of this. Vidhan says, I joined slightly late as per normal time. So Vidhan, you can just go through the lecture notes and the recording once the lecture is over. Like, I hope you will be able to understand that part. Also, whatever I will be covering right now will be quite separate. Like, you can start from here also. So for loops, we are looking at currently how we will repeat some piece of code again and again. So the syntax is, this is the variable which we are looping on, and here we have some sequence or some container. So currently we have a sequence. Range of 10 will provide us. So range of 10 will basically provide us with a list of numbers from 0 till 9. So the last value is not included here. So that's why you can see that we got numbers from 0 to 9. So what if you were to print numbers from 1 to 10? That was our end goal, right? So what we can say is range also provides us another feature. So as you can see, it provides us a start and a stop. So the start we can have 1 and stop we can have as 11, since the last value is not included, right? So let us see we were to do this thing. And if you see now, you will get numbers from 1 to 10, right? Arijit says, how does it decide if 10 has to be printed or not? So Arijit, it decides this thing. Basically, this range of 10 will give you a list. So let's see that. So let me go to a Python REPL. So I try to see what is range of 10. So it says that it is range from 0 to 10. So I can convert this to a list. So let's say what is list of range of 0 to 10. So this is basically the list or the container in which we will be iterating. So we'll look more into list in the next section. So let's try to see list of range of 1 to 10, 1 to 11. So if you will see that, it will give us a list of numbers from 1 to 10. The last number is not included. It is an exclusive range. First number is the inclusive range, right? So I hope you get some idea, Arijit, right? So this code works fine now. Sorry. Python 3 loops.py, right? So it is printing numbers from 1 to 10, right? So now let us say that we want to print all even numbers. So how do we do that? So we can also specify the step, basically how much we have to step, right, in the range keyword. So let's see. So we can say that print, for I in range 1 to 11 and will step a value of 2, right? So that is every time the value will get incremented by 2, right? So let's now see, we'll get all even numbers from 1 to 10. Let's print out the previous ones, right? This will give us all odd numbers because we are starting from 1. So had it been that we are starting from 2, we will get all even numbers, right? Does that make sense? So Pratham is saying use and equal to space. Yeah, Pratham. What about reverse range? So reverse range, Stuti is asking what about reverse range? So just try to look upon that. Just take that as a homework, right? Let's continue. Like we have more things to cover. Like what you can do is, or let's just take it. So what we can say is, we will specify the range as minor step as -2, the step that we'll be taking, step increment. So the third argument is the step increment. Let's say we make that equal to -2, right? So now you can see that we can iterate in reverse direction, right? So even if we were to print list of range of 11 to -2, so we can see that we get these numbers in a negative, in the reverse order, right? So let's now continue. As someone Pratham had mentioned, right? Use and equal to space. So let's try to do that, Pratham. So what I can say here is and equal to space. So this will basically use space as a separator instead of end line, right? So now you can see that we get the numbers separated by space. So we can also have a print in the end that basically has a end line as the default separator. End line or the \n is the default separator, right? So let's just run that. You can see that it gets printed very nicely here. So thanks, Pratham, for this. Right. So let's continue now. So if we were to do the same thing using a while loop, right? So how do we do this? So while loops we generally use when we are not sure about the termination point, right? We generally use when we are not sure about the termination point. We know that there is some condition. When that condition evaluates to false, we will stop our loop, right? So about the number of steps before termination, right? In a for loop, we are certain about the number of steps that we have to take. So basically, let's try to write down a while loop here. So let's say a counter variable is 1. So now the condition will be while counter is less than equal to 10. So this is the condition. Whenever this condition evaluates to false, we will stop then and there. Otherwise, we'll keep on iterating inside this loop. So we have this colon, and then we can say print of Himanshu, is your question answered? Yeah, I think that is answered. We can say print counter. Let's say end is equal to space. And then what we have to do is we will have to increment this somehow. So we say counter plus equal to 1. And in the end, we can say print, right? That is for printing the end line, right? So let's try to run this. So you can see that the numbers from 1 to 10 get printed, right? So now what happens is counter is 1. The condition gets evaluated, it is true. So then we print this and we increment counter. So this is basically a shorthand notation for counter equals to counter plus 1. So as we saw the assignment operator, we can write down assignment operator more simply when we have to increment. So this basically is increment and assign. So first counter variable gets plus 1 and then it assigns it, right? So these are in C++ also, and some other programming languages as well, but the counter plus plus. So if you are from C++ or some other similar programming language background, this kind of thing doesn't work here, right? So just be aware, right? So let's try to see now. Yeah. So I hope you have understood how this while loops works as well. Any doubts till this point to anyone, right? Any doubts? Any doubts to anyone? There are some questions. If we have to print doubles of numbers, by the way, between given range, let me see what you are saying to ask, trying to ask Priyal. If you have to print doubles of numbers between between given range using for loop, so that also you can try. That will be a good exercise. So Prakash, that is just the syntax issue, right? Okay. Any other doubts? Aslam, what is the thing that you are not able to understand? Please tell what it is exactly. Why do we use two print functions? So the second print function is just for printing the end line, Dhruv. It just prints the end line because we are using a separator here. So let's say if we do not have this, so it will just print like this, right? In the end, there will be a space. So just to have this extra end line character, right? We are using this last print. I hope that answers your question, Dhruv. Kastub, I am using VS Code editor. I have highlighted this point many times in the session. Pratham, the separator is used when basically we have to assign a different separator from end line, right? Can you show pattern programs? Yeah, we'll take that up later. Pooja will take that up later. Okay. So let's continue now. So let's try to write down a program that will basically print the multiplication tables of numbers from 1 to n. So let us say that we want to print multiplication. So one more thing, you can use multi-line comments as well in Python using triple quotes. So let's say it's a good practice to write down multi-line comments or comments at the top of your program. So we want to write down a program to print multiplication tables of numbers from 1 to n, where n is the input from the user. Karthika says, can you please explain in, sir? We'll take that up in the next session. Himanshu, there is already a video on GSOC that is in the Scalar Academy. You can just check that out. You can just search. There is already a video on that. Okay. So let's now continue. So basically, right now, we will have to print something like this. So let's say n is equal to 5. So we'll have to print something like 1, 2, 3, 4, 5, then 2, 4, 6, 8, 10, 3. So in the first row, basically, we'll get the first multiples of numbers from 1 to n. In the second row, we'll get the second multiples, and likewise, right? In the end, we'll have something like 10, 20, 30, likewise, right? So we have to print this multiplication table. So now basically we try to analyze this problem. So there are two loops running over here. One loop will be from 1 to n and the other loop will be from 1 to 10, right? We have to print 10 multiples of each number from 1 to n. So there are two nested loops involved over here, right? So for nested loops, like you can take up an example, like let's say that in real life scenario, a train has multiple compartments, right? And each compartment has multiple seats, right? So the ticket checker basically goes over each compartment, and each compartment goes over each of the seats, right? He then checks the ticket for each of the passenger in that seat, right? So there is a nesting compartment, and inside compartment is a seat, right? So here also there is a nesting. There are tables of numbers from 1 to n. In each number you have to print 10 numbers, right? So basically, let's try to write this down now. We have understood how we will be doing it. So there will be two loops that will be using it, right? So let's say first we'll take n as input from the user. And then what we can say is for multiple in the range of 1 to, so we'll print 10 multiples. So outside, so consider it is a good, like I will give you a tip, like take your rows as basically outer loops. So if you struggle with nested loops, consider rows as the outer loops and the columns as the inner loops, right? So we can say that 1 to 11, and the inner loop will be for number. So in range 1 to n, right? So we can simply print the, what we have to print number into multiple, right? And we can separate it by a space, right? And after the inner loop gets over, one row will be done. So we can simply print an end line using this, right? So let's try to see what happens. Python 3 multiplication table.py. Let's say we hit the enter. Samsul, very much thank you. Like you are enjoying the session. We can say 5. So you see that all the tables from 1 to 5 gets printed. Like so now there is one issue over here, right? So the issue here is the formatting is not so good, right? So let me just write it here. So there is a formatting operator, like in C++ or other languages you see there is a printf function in C++ generally. Similarly, we can say here printf %4d. So by 4 I mean the width I will specify for each of the elements. So like if each of the number I keep it in a width of 4 units, fixed width, %4d, and then what I have to print is this thing that is number into multiple, right? So this d basically refers to integer, and whatever is inside these brackets I am specifying the integer. So this might be a bit overwhelming. Like just try to look up how to format in Python. Like we have time constraint over here right now, so let's just try to run it. So now you can see that every element will get a width of 4 units. Let's try to minimize this. Let's say 2 units. Sorry for this. Let's say Python 3. So you see that it is very visible very clearly now, right? So I hope you have understood this. Yeah, you can search about format specifiers. Rohit, you are exactly right. So let's continue now. So we'll now look at jump statements. So now having looked at loops, we should look at the jump statements that are the break and continue basically. So let's first look at a real scenario. So where we can use the jump statements like break and continue. So let's say you have a program that sends emails to 100 employees, right? And after sending 10 emails, your internet suddenly gets disconnected. So what should the program do? Should it try continue? Should it continue sending the mails to rest of the 90 people? That will also result into an error because internet has disconnected, right? So better is that you break from that loop, whatever is that loop that is sending mails to 100 employees, and just continue your continue your loop after the internet is back, right? So basically break statement is very much useful when you want to break out of loop at a certain condition, right? So let's just try to see through some examples. So let's say we have this list of names, list of strings, and now we say that for name in names. So someone had asked about how do this in operator works. So the for loop basically goes through every item in this container. This is a list. List is a container. We'll look about them in the next session. So we iterate over each one of them. That is, we'll go over each of these strings, right? And let's say that whenever the name, we first print the name, and if the name is scalar, so let's say we try to break from this, right? So if name is scalar, so we can simply say break, right? So what will now happen is this loop will run, like this first string will get printed because the first statement is this. Then the second statement is we check this condition. This condition hits false because this capital S is not the same as small s. So these two strings are not equal. Again, this string is not equal. Now third string is equal. So we'll break out of this loop, right? So let's try to run Python 3 jump statement. So you see that the first three only get printed, right? So the last interview bit will not get printed, right? Dhruv says what should be taken in outer loop and inner loop. So in the outer loop, we generally have the rows that are like vertically. In the inner rows, we have the columns. So the outer loop basically does the processing for a row. So just try to write down this code once yourself about multiplication table. And Dhruv, you will be able to do this very quickly. Just try to write down some programs on matrices. You will be able to understand it beautifully then, right? So this is the break statement. Now let's also see a continue statement, right? So let's say that now instead of breaking at some point, we want to skip some iteration. So let's say that for name in names, this first check if the name is scalar, then we will continue. So we don't want to print scalar in small. We want to print S in capital always, right? And then we try to say print of name, right? So now what will happen is only this third string will be missing from our output, right? So let's try to print this. So you see that the third string scalar is missing where S was small, right? So let's try to quickly write down one more program here. So let's try to understand what happens when we have break statement in a nested loop. So let's say now instead of just iterating through these strings directly, we want to iterate through each of the characters as well. So we'll have two loops again. So let's say we want to find out in which string this character I appears. So what we'll do is for name in names, we'll say first let's try to print. We'll use format strings here. We print the name in the outer loop, right? And then we iterate over each character in this name. So we can iterate over each character in name by using for char in name, right? So this char is just a placeholder variable. It could be anything else. So then we can simply say print f found this thing name with the letter. We have found a name which is having the target letter, that is I, right? And then we can simply say that we'll break out of this loop, breaking out of the inner loop, right? And we can say break, right? So one more thing, right? We'll also have to check that if char equals target, right? I just missed this part. So we want to find out in which string this target character appears, right? So inside this if statement, Rohit, what we are doing is we'll check the character whether it equals to the target, right? If it is equal, we'll print that we have found out a name with the letter I, right? So let's try to run this program. So let's see. So you see that how it happens. Scalar in the outer loop, interview bit in the outer loop, found interview bit with letter I, breaking out of the inner loop, right? So whenever you said breaking out of the inner loop, so then the outer loop will basically continue, right? So only the inner loop will break, right? So just make sure you understand this thing very clearly. Whenever we have break inside a nested loop, the only the outermost loop where the break is used gets terminated, right? So then we will go to the next loop, right? So I hope this is clear to you. Just try to write down as an exercise, just try to write down a program that checks if a given number is prime. Try to use the break statement, right? As an exercise, right? Shashwat is saying something. In the Rohit, is your doubt clear? I did not understand continue statement. Dhruv, we use a continue statement whenever we want to skip some iteration. So for example, this was the piece of code. So now whenever the string is name is equal to scalar, we'll continue. We will not go to the line number 14, right? So that is what happens, right? So Ritik, just try exploring this on your own. We are running out of time, so just try exploring this on your own, Ritik. That would be a good exercise. So now, before we end the session, like let's just look at one more concept. So we'll look at functions. So now, function basically is you can consider a function as a black box that takes several inputs, does some processing. So it takes several inputs, will do some processing, and then will produce some output or will return some output and can return some output, right? So that is what is a function basically. So one thing when we write programs is basically we can have a big piece of code file, and then the issue with that will be it will become difficult to maintain, right? So we can use functions and break our code into small tasks that are functions, right? So why do we use functions? For reusability. So the main things for we use functions are for reusability, right? We want to reuse some parts of code. So let's say we have a function that finds maximum of 3 numbers, right? So whenever there is a requirement, we have to find max of 3 numbers, we'll directly use that function instead of writing the same 3-4 lines of code again, right? So the other thing is abstraction. So basically a function, we only need to use a function, we need to know its name and only the arguments that it accepts, right? You do not need to know how it works internally, right? So if you use the documentation of languages and frameworks, you must have seen that you mostly are interested in a function. It will have a well-defined name. You will be able to get through that only what it does, right? So some other use cases are it makes it easy to maintain the code, right? And debugging also becomes easier because once you know that the exact function where my code is breaking, you can get to that code and try to debug it, right? So let's try to write down a simple function. So let's try to have a print function that will simply print something to the screen. So how do we define function is we can just have keyword def. So def keyword is used to define a function. Then comes the name of the function. Let's say the name of the function is print function. And after that, what we can have is we can have a bracket. Inside these parentheses, we'll pass some optional arguments. Like arguments are optional. Let's say we do not want to have any arguments. We can skip. Then we'll have a colon as we have in all our control flow statements, right? Now we'll have some logic here, logic or the main code of the function, right? We can simply say printing hello to the screen, right? So let's now try to see how we can run this function. So to run this function, we simply have to say the function's name and then the parentheses, right? So the parentheses are required. They are a must, right? So let's try to run this thing now. So you can see that it shows printing hello to the screen, right? So also we can have some function. Let's say we have a function add 2 numbers. It takes in number 1 as input and number 2 as input, right? And it simply returns. So a function can also return something like, right? So it is like a black box you can consider. You also know the processing here, right? When you are defining. But when you are using functions, you just treat them as black boxes, right? That have some inputs and basically return some output. So you can simply say here return number 1 plus number 2. So how do we call this function now? So let's say we have a variable x as we take it as input from the user. We take y as input from the user. And let's say then we say print of x plus y. Sorry, this is when we don't want to use the function. Now we want to use the function. So the function is returning something. So let's say if we simply use the same structure we followed earlier, we simply say add 2 numbers, x and y. So will this work? So let's try. So we given 3 and 4. So you see that it did not give any output. Why? Because the thing it was returning, we did not store it somewhere, or we did not print it. So either we can simply say print this thing. So that will basically print the output. It says 3 plus 4 is 7, right? So the other thing that we can do is we can simply say we can store this result in some result variable, and then we can print this result, right? So that will basically print the result now, right? So whatever the function returns, we can store it in some variable. So I hope that makes some sense. Now, basically, one more thing. So if we have a function that does not return anything, so let's go back to this piece of code. So this function print function does not return anything. So now if we try to store into result something and try to print it, so then you will see that what do you expect here? What do you expect here? Anmol, how to take input in same line? We'll try to answer that question later in the next session, Prakash. When we look about lists, Anmol, how to add a line in print statement with the result? Okay, I think I covered that part, Anmol, earlier, right? Dhruv, this is going too fast. Okay. Sorry for this. Like, try to like visit these things. Try to implement them yourself. I think you should be able to get these concepts. Just go through the lecture notes once. All the code that I've written here is available there, very structured, and we have tried to detail every part there. So if we try to do a print here, it will print none because it is not returning anything, right? So here, if you see that, we'll get answer as none, right? So although this thing is not actually recommended, so instead we can simply have a return none. Okay. Sorry, I think I indented it incorrectly. So just make sure, one learning here is make sure you indent your code properly, because if your code is not properly indented, you will get indentation errors, right? So these are the things that we had for today. I hope you have gotten a good amount of idea about control flow. So we looked at, if we do a brief recap, we looked at some operators, relational operators, and we looked at logical operators. Then we looked at conditionals. Then we looked at some examples. Then we looked at the loops control flow, which is very frequently used in programming and software engineering in general. Then we created a program to print a multiplication table. We looked at jump statements, break and continue. Finally, we looked at functions, right? So try to this thing as an exercise. Try to write down this function that returns maximum of 3 numbers, right? So I hope you have understood many things that we have covered. If not, just try to revisit and just try to go through the lecture notes once. So the lecture notes are also attached in the description. Just try to go through them once, right? So any other doubts that you have, you can join the Scalar chat link that is in the description. So for any doubts, there is a discussion forum, Scalar chat we have. You can join that, right? So I hope you have enjoyed this session. So in the next session, we'll start from here. We'll continue about the data structures, basic data structures in Python, the lists, tuples, dictionaries, sets. Just try to look at them before attending the session, right? So also I made that announcement about the certificates. Like if anyone has missed that, yeah, we'll add all the things in the description. Just one thing, let me confirm. Any doubts till this point? One thing I had to confirm, like if there is a quiz that is going to be launched on some social handle. Just give me 1 minute. If you have any doubts, yeah, so let me repeat that thing. So basically we will be providing certificates as well, digital certificates as well, if you attend all these Python series, and at the end of it we'll be creating a to-do application, right? So basically we will be conducting a test, so based on that digital certificates will be provided to you, right? Okay, so one more thing, we have an interesting exercise for you as well. So basically you can just 1 minute, you can go to the Instagram account of Scalar Academy. We will be launching a quiz there. So just go to the Instagram account of Scalar Academy. We will be launching a quiz there just to test your understanding. Our team has created a quiz for you there. You can just attempt it right now. It will be launched as soon as we end the session. Yeah. So the quiz will be launched in the Instagram. You can just follow this. The link will be there in the description, most probably. Yeah. Let me just check it. The notes are available in the GitHub account. So in the Instagram account, you can just go through that. You will be able to find a quiz. So the team must have launched a quiz there. Yeah, let me just post it here as well. So I hope you enjoyed the session, and we'll continue with the same excitement as today's. Make sure that you attempt the sessions if you like today's session, right? And just try to attempt that quiz right now. I hope it was a good experience, and just you can follow us, follow Scalar Academy, and thank you for watching the session. Bye. Bye, everyone. So we learned about conditionals, loops, jump statements, and also about functions, right? So let's just recap some of these concepts. So first we'll recap the things with the help of examples, right? So let's try to write down a program that will check if a given number is prime or not, right? So let us take a number as input from the user. So now what basically is a prime number? A prime number is one which has only two divisors, right? Which has only two divisors. So the first one is the number itself and one, right? And the first prime is two. Basically, one is not a prime. So second, two is the first prime, right? So after that, we have 3, 5, 7, 11, likewise. So basically, we have to write down a program that will tell whether the given number n is a prime number or not. Let me also move this thing to the right. Yeah. So how do we check this thing, right? So we know that a number will be divided by, like the divisors will be starting from, so 1 is a divisor for all the numbers. Yes, Vidhan, we are doing that only. We are recapping the yesterday's concepts. Function concept also will recap. So basically 1, 2, 3, like we have this number n. So the max divisor except n would be could be n by 2, right? Everyone agrees till this point. So from the range n by 2 to n, we cannot have any other divisor, right, except n. So what we can think of is like we will write down a loop from 2 till n minus 2. So 1 will be a divisor for all, right? So we write down a loop from 2 till n by 2. So if any of these numbers is a divisor for the number n, then we can say that the number is not a prime number, right? Do you all agree with this point? So let's say we'll write down a loop for divisor in range of 2 till n by 2, and we do integer division here and plus 1 because this range is exclusive, right? Now how do we check divisibility? We just check that if n modulo divisor is equal to 0, right? Equality operator we checked yesterday, right? Equals 0, we can simply print that the number is n is not a prime, right? And now since we have we came to know that n is not a prime, so we can break at this point. So why do we need to go further, right? We can use the jump statement we learned yesterday. So we can simply say that break here. We do not need to continue the loop, right? So now can we simply say outside whether that n is a prime or not? So let's say if we say this, like if it is not a prime, then definitely it is going to be a prime. But do you see some issue here? Like, will this piece of code break for some point, break for some numbers? So let's try to run this, right? So let's try to say python3 recap.py, and let me provide the number 5. So it says that 5 is prime. It works. Yatin is asking a question, why is n by 2 taken? So Yatin, it is because that we will not have any divisor from n by 2 to n. So let's say that n is equal to 36. So from 19 onwards, so 19, 20, so all these numbers after 18, right? After n by 2. So they will never be a divisor of the number 36, right? So do you get this point now? Except 36, right? 36 basically we will have only 1 and n as the divisors of the number, right? Did you get this point, Yatin? Yatin, is this question clear now? So now basically what we can do is we can try to test for some smaller values as well. So let's say if we say 2, so 2 is prime, okay. If we say 3, 3 is prime, right? But what if let's say we put 4? So if we say 4, then it will give that 4 is not a prime as well as 4 is a prime, right? So why? Because when we do this break, it will continue the execution from line number 21. So we need to maintain some information. Ravi Shankar says, can you please explain this logic once again? So yeah, let me explain this. So let's say a number is like n is equal to 12. So what are the divisors of 12? 1, 2, 3, 4, 6 and 12. So if you can notice that from n by 2 onwards, there will be no divisor, right? Because if we say that when we divide n by 2, we get 2, right? So if we say 12 by 6, we get 2. So if we divide by 12 by 7, we will get something in 1 point something. 12 by 8, we will get 1 point something, right? We will get a floating point, a decimal value, right? We cannot get an integer if we divide n by any number greater than n by 2, except n only. So I hope this makes sense now, Ravi. Okay, so the issue here was when we are saying for a number which is not a prime, it will be printing both the things. So we need to maintain some information that we have checked that number, right? So we need to have some flag here, some kind of variable, let's say a checker variable that is initially 0. So we can say now checker is 1. So if checker is 1, then we will not print. So if checker is 0, then only we will say that n is prime, right? So that means we did not print n is not a prime, right? So you need to maintain this extra variable, right? Did you get this information? So now you see that 6 is not a prime, right? 2 is a prime, 3 is a prime, 11 is a prime, 12 is not a prime, right? But still, can you figure out a particular n where this will fail? Still, there is one corner case missing here. So always try to figure out the cases where your code can break. That is a good thing, right? If you follow that. Vidhan, I did not get your point. So this piece of code will break at n equal to 1. So let us say if we say n equal to 1, it will print that 1 is a prime, but 1 is not a prime, right? Because this range function, inside this range, we are going from 2 till n by 2 plus 1. So let's say n is 1, right? So we will go from 2 till that is 2 by 2, that is 1, 1 by 2, which is 0, 0 plus 1, that is 1. So you see there is no value which will lie in this range of 2 till 1, right? Because this left point should not be greater than the right endpoint, right? So that is why we just need to have one extra check here. That is, if n is 1, then we will not print it is a prime. So if n is not equal to 1, and this is the case, right? Otherwise, we will say that n is not a prime. You can see how we are using the if else that we learned yesterday. So let's now try to see with 1. 1 is not a prime, 2 is prime, 3 is prime, 4. Okay, so this time it breaks with 4. Why again? Because the checker need to have a value 0. So else if checker is 0, right? Or what we can have simply is else if n is 1, right? So just try to figure out different ways to write this thing. Uh, just remember that for else if the syntax is elif. We do not write else if or something like that. Remember this thing. You might make some mistakes here. 1 is not a prime, 2 is prime, 5 is prime, let's say 6 is not a prime, right? So now this piece of code will be working. So Himanshu, Vidhan, I answered that question. We are using a checker because if we have went inside this thing, then we do not want to print that it is a prime, right? Because we have already printed it is not a prime. Himanshu, the today's agenda is we'll be learning some of the data structures or the containers in Python that are lists, tuples, sets, and dictionaries. So currently we are just recapping the concepts we learned yesterday. Yeah, Sumit, I have answered that question. Praveen, I have tried to explain the logic. So basically we are iterating over all numbers from 2 till n by 2. If any of them is a divisor, we say n is not a prime. Otherwise, we say n is a prime. Just in that case, n equal to 1, we need to say that it is not a prime, right? So does that answer your question? Yeah, Ravi, something like that you can do. So let's now continue. So anyone has any doubts, like make sure you try to implement this thing yourself. There could be multiple ways to implement the same program, right? So you will be more clear when you do this yourself, right? Rocky, break is used because Rocky is asking why is break used. So the break is used because that we have already come to know that n is not a prime, right? So there is no point looping further. I hope that answers the question. Uh, so there are a lot of resources, Shamim. You can just try Google it. Yes, Arijit has a good point. We can use square root n. That is a good optimization, but that is not very intuitive in the first moment. So thanks for pointing it out, Arijit. So let's continue if you are clear with this, everyone. So now we will take one more example before we continue. So let us say that we want to print out this pattern. So we want to print this pattern onto the screen. So someone had asked how to print patterns using loops in the previous session. So the observations you can have here is it is a two-dimensional kind of structure. There are some rows here and columns here, right? So every row will basically have, so let's say that the first row 1 has 1 star. Amit says you speak too fast. Okay, let me try to be a little slow. Anand says can return be used. So return can be used in the case we were making a function. So currently we just have a single piece of code. We are not breaking our code into functions. If you had a function, you could have used a return. So row 1 has 1 star, row 2 has 2 stars. Likewise, right? Ith row or basically rth row will have r stars. So hope that you have got this point. Let's say that n is input and we need to print n rows, right? So how will we do this thing? So this is the question right now. So basically, again, you see that you have to loop in two directions here. One is the row and other is the column. So you can have two loop variables here. You can have two nested loops. So the outer loop will basically loop over rows. So it is a good practice. Always outer loop is used for rows and inner loop is used for columns, right? Okay, Amit says that treat audience. Okay, Amit, I'll take your point into consideration, Amit. Thank you for that, Amit. So basically, we want to print this kind of a structure, and the outer loop basically represents the rows and inner loops represents the columns, right? So this is the row 1. This will have the value r equal to 2. This will have r equal to 3. This will have r equal to 4. So now when you are looping over a row, in each row you will loop how many times? R times. So in each row, let's say you have a variable for row. So let's say that it is also a good practice to use variables like R and C for rows and columns. So for R in range of, let's say, okay, for row in range of, let's say we have number of rows equal to n, right? In range of 1 till number of rows plus 1, right? So when we loop over this variable, let's just try to print the row number. Let's just see what happens. Let's go step by step. So if I print 5, so you will see that you get the numbers from 1 to 5 printed. Yeah, I get this point. Sumit, it will be more clear once we are complete with this. So till this point, any doubts? How we are printing the numbers? Any doubts till this point? Now here you have to print 1 star. Here you have to print 2 stars. Here 3 stars. Here 4. Here 5. Right. So basically inside also you need to write down a loop. So for column in range of how many times you have to repeat? 1 till row plus 1. So this will be repeating row times. So here basically row will have the values 1, 2, 3 like this. So let's just print out the column value and separate it by space. So end equal to space. And let's try to print an extra end line so that we get to see it clearly. So now let us see. So what do you see? Leela Manas is asking how long we will take to get data structure. So this is one last example we are taking before we continue. So you can see that we have got this kind of structure or the triangle 1 1 2 1 2 3 printed to the screen, right? So now instead of these numbers we want to print just a star here. So we can simply say print star, right? So let's try to run this now. So you see that we get the structure that we wanted to print, right? If I try to say 7, then we will get 7 rows. So anyone has any doubts till this point? So one exercise for you will be to try to implement this using a single loop. So that will be a good exercise for you. Try to implement this using a single loop. Any doubts till this point? Okay, so let's take one more example before we start with some basic data containers like lists and tuples. Okay, Ashish is asking what does end equal to space means. So that basically means we are separating by space. Bhakti says, can you please repeat? So what part do you want me to repeat? Okay, so let's repeat this logic once again. So if you see that we are basically having some structure like this. So let's say we were to print this thing. So there is one variable that is looping from 1 till 4. So here r is 1, here r is 2, here r is 3. So we can simply write down one loop for r that will start from 1 go till 4, right? Now inside also we need to write down a loop. So inside there is a loop from 1 till r's value, right? So that is why there is this nested loop coming into picture. So right now you just want to repeat each of these values by a star, right? So if Ashish is saying yeah, Vidhan, did you get this point, everyone now? So Ashish, if we just write down this thing, then we will get some issue. So if you just try to print now, so you see that you will get all these things in new lines. So let's try to use the space only here, because by default end line is the separator. The range function is exclusive. So Ashish, the range function is exclusive. The last value is not included, right? Okay, so let's continue now. So one exercise that was given to you was to write down a function that will basically return max of 3 numbers. So I hope you were able to complete this thing. So we will not discuss it now. We want to continue further. Okay, so let's just continue the discussion on functions once. We'll just learn 2 more things in functions. Yeah, we always don't require 2 for loops. Saksham, you are correct. Yatin tried that as an exercise, how to make equilateral triangle. So let's learn one more thing about functions. So let me just recap how we write functions. So let's say that, okay, let me just recap about functions as well. So let's say we want to write down a function that will return max of 3 numbers. So first we write down the def keyword and then the function name, and inside the parentheses we have these arguments, and after the parenthesis close we need to put a colon, and then we need to indent. After that, uh, there are some questions. I am skipping some of the questions because that have already been answered. Okay, so now let's say that we simply return one of these numbers. So the return value is what is getting returned to the caller of the function. So let's say that we call this function max3. We have 3 variables. A is 3, B is 7, C is 5. So we will simply, let's say, try to call max3 with A, B, and C and store the result. And then we try to print the result, right? So let's try to see what happens. So you see that you will get 3 printed because we are printing the number 1, right? So that is basically like how we define the functions, how we call the functions. Since the function is returning some value, that value is getting returned, and we are able to store it in some variable and print that value, right? So the logic to return max of 3 would be, so uh, let's say that we store our max in some variable. Let's say that the maximum number is number 1. So when can number 2 be maximum now? So if number 2 is greater than the maximum one, right? Greater than equal to maximum, then only the maximum could be the number 2, right? You get this point? Now again, if the number 3 is greater than equal to maximum, so then maximum would be number 3. So I'm giving you the optimized logic right itself. So just try to think it step by step. Yeah, you can use the inbuilt function Harsh to find the maximum, and finally we can return the maximum. So let's now try to run this function. So if we run this, we get the maximum of A, B, and C, that is 7, right? So the logic here is basically we store the maximum as 3, then we compare whether 7 is more than maximum. If it is, we update the max. Then we compare 5 with maximum. If it is greater, we update the maximum. Finally, we return the maximum, right? Yes, Harsh, you are right. We can use the inbuilt max function. You are right, Harsh. So let's learn one more thing about functions. So basically, there are some functions that can have some default arguments. So for example, let's try to get into some kind of physics here. So let's say there is a function distance traveled that takes in the time taken, the speed, and let's say that we want the speed to be as 0 by default. And we have some variable for acceleration due to gravity. So let's say that is 9.81. So we can specify some arguments which have default values. We call them as keyword arguments, which can have default values, right? I'm getting some questions. Can we have more than one return? So Aditya, that is a good question. We can have more than one return for one function, but basically the one return which will get called, which will be executed the first time, will be the one that will be returning. So like there could be multiple conditions in your function, and depending on the condition you are returning some value. That is possible. Rohit, like it is up to you. Up to you. You can use VS Code as well. Up to you. Yes. So Abhijit, that is a good thing. Like that is the first point where you should start. I gave you the optimized logic considering the time we have. Okay. So now let us say that we simply want to return. We want to return something, distance equal to time into speed. So speed into time plus zero point 0.5 into, or let's say minus anything, like let's say if they are in the same direction, speed and gravity are acting in the same direction. 0.5 into gravity into time squared, right? So now we can simply return d. So now these kinds of functions are useful when there are some values which can have some default values. Like now we need not pass this value. So let's say that this was not the case. This was not the case. And let's say that we simply say d is equal to distance traveled of, let's say we travel for 2 seconds. So now if you try to print d, you will get some syntax error. So if you try to run this program, you will get syntax error. So you see that missing positional argument, speed and gravity, right? So speed and gravity are two arguments that are required here, right? So let's give some default values to them. Speed is 0 and gravity is 9.81. Now if you run this function, you will get no error, right? Because it is a valid function now. You get this distance traveled, 19.62, right? So that is the concept of default values or keyword arguments, default arguments, right? So does that make sense to you? So also we can pass in some other values here. If let's say we have some speed initially, we can pass it. We can pass it directly, or we can pass it using the keyword as well. So now if we try to run this, we will get this output. Let's try to print this value. So you see that it got incremented by speed into time, that is 1 into 2. So we could also have passed it like speed equal to 1.0, right? So I hope this makes sense. Yeah, we can use constants as well, but let's say that we want to change the gravity value. So we want to pass in something like 9.71, right? So that is the concept of default keyword arguments. We might want to change them in some cases, right? Uh, don't we need to declare the type of the function? Because based on the function type, return type will be there. Yeah, so because Python is a dynamic language, so basically we need not have types for things here. Types are determined dynamically, right? So this was a good question. Unlike other languages, we do not need types here. So Harsh, keyword arguments is the name for arguments which can have default values. So there are two types of arguments, one which have default values, with default values, or without default values. So the ones which have default values are known to be as keyword arguments, right? So is this clear to everyone? So the type of variables, I did not get this question, will the type affect? Okay. So let's continue from here. So there are some advanced things that have been mentioned in the lecture notes. You can just try going through them, right? Preetham, just you can give that at a try. What will happen if you pass it as 1 instead of 1.0? Just give that a try. Okay. So let's now continue. So there is one interesting exercise for you. Just try to have a list as a default argument. So one interesting thing that we can discuss before continuing further. So let's say that we have a function def foo, or let's say anything that takes in one variable a and takes in a list as a default empty. So now if we try to say l dot append a and we try to return l. So now let us say we call foo with 3 and we try to see what gets printed. Then we try to call print foo with 5. So what do you expect here? What do you expect the output to be? So here empty list is there, 3 will get appended. It will return a list containing 3. So we'll learn more about lists right after this. So Pranjal, the lecture notes are available on the GitHub repository as always. You can just access them right now. So basically this is a warning. You should not use default arguments with lists. So let's try to run this program. So you see that you get 3 and 5. It was expected that this will give 3 and this will give 5. But the thing with default arguments is they are basically created only once in the memory. The default arguments are created only once in the memory. So this was very unexpected output. So just make sure you are very clear with this thing. You never use lists as default arguments. So this is something which many people do not know, right? So this list was basically created only once in the memory, Rohit. That is why. So just try exploring more about this thing, Rohit. That would be an interesting exercise. So let us now continue with the data structures part. We'll start with lists, right? So Ravi, Ravi, we got 3,5. Let me elaborate once again. So the thing is, this list was created only once in the memory. So there is one thing known as ID function. So ID function returns the identity of an object. Everything here is an object. So Shivanand, we are covering dictionaries very soon. Vaibhav, we are using VS Code. Yes, Shivanand, you need to revise the earlier classes. So let's try to print the ID of L. So you see that both these lists are stored at the same location in the memory. Just try exploring about the ID function. So basically both of these lists are at the same location in the memory. So basically when we use default arguments, they are only created once in the memory. So this, I know this could be tricky and a little overwhelming. So basically Harsh, Harsh has a good question. So data types are basically the ones which language already provides. And data structures are some things which we can build on our own, right? So we can create a graph data structure. We can create a stack data structure on top of a list data structure, right? So Python provides some inbuilt data types, which we will be learning today, that are lists, tuples, sets, dictionaries. We'll learn the use cases of each of them, right? So Shubham Agarwal has a good question. Won't it be garbage collected? No, Shubham, you can try exploring about it once. You can try exploring about it once. We are using VS Code. I have answered that question, Vaibhav, a lot of times. Shashwat, just try to do this thing once. Okay. So any doubts till this point, we can continue, right? So let's learn about some basic data types today, which we will be using. Yeah, Dhruv, we are covering now, which we'll be using in a broad sense of data structures. So basically a data structure is something which is used to store data efficiently. Right? So we want something that can help us store data efficiently. we want to retrieve the data efficiently as well. And we want to make changes to data as well, right? So there are a lot of operations that we wish to do, right? We want to add things to our data structure. We want to retrieve data efficiently. We want to store it efficiently, right? There are a lot of things that we want to do. So we have some basic data types that we can use to build some bigger data structures, right? So today we will be learning about some data types that Python provides us inbuilt. So that are something like lists, tuples, sets, dictionaries, right? So we'll try to explore them one by one, right? So any doubts till this point? Okay, so let us continue with lists. So basically, let us say that we were to take input from user, a bunch of numbers. So let's say that we want, let's say first of all, we want 10 numbers from input as a from user as an input. So how will we store them? Let's say we also want to store the numbers, store and sort the numbers in some order, let's say in descending order. So how will we do this? So Ravi, these are the data types. Ravi has a good question. So these are the data types that we are learning. On the top of them, we can define our own data structures as well, right? List is a data type. So you can call it that it is a data structure, but the inbuilt data structures are data types. So we can say in short that the inbuilt data structures that Python provides, that the language provides, we call them as data types because they are already there in the language. Yeah, we will cover all these things. We'll cover all these things. So let's say we want to take 10 numbers and sort them in descending order. So how will we do this? How will we take 10 numbers as input? So one way is like we can say n1 is int of input. We can say n2 is int of input, right? We can say n3 is int of input, but won't that be a tedious and messy way to implement this? How will we retrieve the data then? Let's say we want fifth number, we have to write print n5. Is there any efficient way to do this? Again, how will we sort them? So we need a container that can store all these 10 numbers, right? Need a container to store all these 10 numbers, right? So how will we store? So that is where lists come into picture. So we can create a list. So we can say that L is an empty list, or let's say numbers list is an empty list. Now, how do we take input from the user? That is a good question. So in Python, when we say, let's say that we take input, numbers input is input. So if we try to print this numbers input, so what we will get? So we'll get a string, right? So let's say that the user gives these numbers as a string. So user gives 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then, okay. I think we wrote this incorrectly, right? So let's just take 3 numbers as input. Uh, so what is the mistake here we are doing? So let's say we have to take only a single thing as input. So we'll say n is equal to input. Is that the right way? Right? And if we say print n, then we'll get 3. But now this 3 will be a string, right? If we say print type of n, this will be a string. or it is an int in this case, right? So it doesn't allow to take multiple numbers as input, right? So we simply have to say we can use let's say we are saying we can convert them into string. I think that should work. Okay, so if we do int of input, then it will work for only one number, right? But we want to give multiple numbers that are space separated. So how do we handle? Okay, I think I'm using Python here. I have to use Python 3. So okay, that was my mistake. So actually the issue here was, if we see that here we have two things. There is a Python 3 and Python 2. So we just got confused in this thing, right? So I by mistake started using Python. We had to use Python 3. So if we say n is equal to input in Python 3 and we print this thing, then we will get all these things as a string, right? Even if we put one number, then also we will get that as a string. So that is why we got confused here, right? So we want all these numbers as input in a single line, space separated. So there is a function that comes to the rescue here, that is split function. So we can split this string. So let's try to print n here, and then let's try to say n list is n dot split. So now let's try to print what is n list. So if we give 3, 4, 5 as input, now you will see that we get a list of strings, right? Do you all get this point? We get a list of strings here that contains 3, 4, and 5. Okay. So now we want to convert them into integers. So how do we do this? So one way is we iterate over all elements in this list. So we say that for element in n list, we will say that element is basically int of element. So now let us try to print what is n list. So do you think it will get updated? Let's see. So you see that it did not get updated, right? That is not happening for us. So just that we have to create a new list. Let us call this new list is an empty list. Now what we can simply say that new list dot append this element. And then we try to print this new list. So now if you see, you will get this list that contains integers. So this append function is used to insert an element into a list. So to create an empty list, we can use these square braces, right? We can use square braces to create an empty list, and then to insert elements into this list, we can use the append function, right? Any doubts till this point? So is there an easier way to create this list? That is the question. So let me share with you a shortcut that will be very helpful here. So we need not do all this thing. What we can simply say is, we can say L is equal to input dot split. So first we take the input, right? Then we split it. So we will get a list of strings, right? So let's try to print L. So we are chaining these functions together, right? So you see, you get 3, 4, 5, which are strings. Dot split, basically split is a method that will split based on spaces. So that is a good question, Shashwat. So split is a method that simply splits the string. We get a string that is 3 space 4 space 5. So that gets splitted based on spaces and is basically stored in a list, right? I hope that answers your question, right? Okay, so Ashish says you are going too fast. So Dhruv, we are basically trying to take 10 numbers as input from the list, and we will want to store those numbers in descending order. So that is what we are trying to do right now. Okay. So basically, let's go one by one again. So let's just go one by one again. So if I just say L is equal to input and I try to print out the value of L, and let's say I provide the input as 1, 2, 3. So I get this 1, 2, 3, but these are not the numbers right now. So these are basically, this is a single string. So if you see 1, 2, 3 is just a single string. Now we want to convert this into a list. So first we need to split this based on spaces, right? So we say that new list, or basically number list, is L dot split. So dot split is a method that optionally takes a split parameter or the split keyword, that is space, as an argument. Now this will split based on space and return the individual elements. So this string 1 space 2 space 3 will be splitted based on spaces. So 1, we get 1, we get 2, we get 3, right? All of these 3 elements will be stored in numbers now. So if you print numbers and if you print type of numbers, so you will get here simply, let's see, you will get 3, 4, 5 in a list, and their class is a list. So is this clear again? Is this clear to everyone now? Now the thing is, we want to convert them into numbers, right? So there is a function, let's say we want to print sum of the numbers. So if you do it now, you will get something weird, right? So you'll say type error. Sum does not support string. It supports only integers. We need integers here, right? So there is a function that basically is a high order function that is known as map. So using this map function, we can convert every element of this string into an integer, of this list into an integer. So we can just say we want to convert into integer, and we want to convert these elements into numbers list. So if we just try to print this thing now, so let's try to see what happens. So you see that you get a map object. So map is a high order function. We'll try to cover it again, like in more detail. Just try to learn this thing only, that it will convert every element of this list into an integer. Yeah, list works as an array. So Deepika has a good question. Does list work as an array? So list is like an array in other languages. You can index it based on the index. You can access the elements based on index as in other languages, starting from the index 0. So now we want to convert this into a list. So let's say numbers list is list of map of int of numbers. So now let's just try to print the numbers list and try to print the type of numbers list. If we try to do this thing now, okay, just we wrote one extra parenthesis. So you see that now we get numbers here 3, 4, 5. And if we try to print the sum of these numbers, we will get sum of the numbers list as 12, right? So does this make sense to you now? So first we converted every number into this, every element of this list numbers into an integer, and then we converted it into a list because map function returns a map object. So we are doing some kind of typecasting here, right? Shashwat, the line number 37 is basically printing the type here. So we use map is used to convert every element of numbers list into an integer. So like we were trying to convert it by running a loop earlier. So Rohit, we were trying to convert it by using a loop earlier. Right now we are trying to do it in one line. So this map function is a high order function, right? So I hope this answers all your questions. Blackout is asking what is Python. If you want to know what is Python, just revisit the first two lectures. You will get a very good idea. So now we can do this thing in one line, right? So we can simply say L is equal to list of map of int of input, sorry, int comma input dot split, right? And try to print L. So you see that this numbers was nothing but L dot split here, and L was basically input. So we just changed everything to a single line. So whatever we wrote above, we changed. We basically are trying to do it everything in a single line here, right? So now basically you will just get all the numbers here. So let's try to say 3, 4, 5. You get all the numbers here, right? Uh, that is a good question. What is high order function? We'll try to cover that thing later, more detail, right? So let us say that I give the input now as something like 5, 4, 2, 15, 7. So we want to sort these numbers now. So how do we do that, right? So we can simply say there is a function that is sorted function, sorted of L. This will return a new list which will have all these elements in a sorted order. So now let's try to print this new list. So if you see now, you will get all these numbers sorted, right? So is there any doubts till this point? Now we want to understand the other things that we know about data structure. We need, that is updating the data in this list, accessing the data. So we need to have update, access, right? All these things we want to do, right? There is a sort function also. Ravi, I'm not taking that question right now. Try to explore it. So one more thing, we can take the length of the list using a length function. So there are all these methods that Python provides us to make our day-to-day life easier. So to write programs easier, Python already provides us with lot of functionalities, lot of methods. So we can simply say length of L. That will simply give the length of the list, right? So you see that the length of the list is 5, right? So what if now we want to print the original list? So what do you think? Will the original list be sorted or not? What do you think, everyone? Will the original list be sorted or not? Yeah, Himanshu, that is a good question. So it is not in place sorting. So basically, if you see, the original list remained the same, right? It was not sorted. So if we want to sort the list in place, so we can use the sort function, right? So sorted function and sort function are two different functions. So we can simply say L dot sort. And let's say we want to sort in descending order. So we can say optionally reverse is equal to true. So this will sort and then reverse. So basically sort in descending order, right? So let's try to print L now. Now you see that this original list L got sorted in descending order, right? Yes, you're right. Yes, Karthika, you are right. We can write the line number 55 and 56 in the same line. Okay, Pranjal, so like map was just a function. So it basically, you did not go into the depth right now. So map was just a function that is converting each element into an integer, right? I tried going step by step basically. Like if we were to do this thing naively, like using our own logic, so then we had to create a new list to convert every element to an integer, right? So Pratham, you can use the official Python documentation. Let me just paste that for you, Pratham. You can just go through the official Python documentation. Okay. So let's now see how we will access a particular element of this list. So let's just comment all this thing above. Vignesh, I did not get your question. So right now we want to see how can we access a particular element into in a list. So let us say we have a list L is equal to 1, 2, 5, 6, 7, and let's say minus 10. So we can access any element at a particular index by just writing the index in the square brackets, right? It is similar to other languages. We can just pass in the index. So basically, if we write down this first element is at index 0, next one is at index 1, next is at index 2, next at index 3, index 4, and finally last one is at index 5. So yes, predefined function for sorting in descending order. Okay, so next, let's say we want to print last element. So what we can do is either we can say length of L minus 1, because the last index will be length minus 1, or Python has a powerful way to access the last elements from the last. So we can simply say minus 1. So that will give us the last element. Minus 1 means that from the last first element from the last. Amit, how to get certificate? So we will be sharing more details later about this. So we will be having a test. You have to attempt the lectures and we will be having a test in the end, right? Mayank, we haven't created tuples right now. So you see that's how we can access a particular element, right? So now let us say that we want to simply update our list. So we want to add an element. Let's say we want to add 12 to the end of the list. So we can say L dot append 12. So let's try to print L now, right? So you will say that 12 is getting appended to the list, right? Okay. And let's say we want to insert at a particular index. So basically list maintains the order, right? So if we want to basically insert the element at a particular index, so how do we do that thing, right? So we can simply use the function that is L dot insert, right? That we will be passing the index. So the first thing you can see is the index. Let's say we want to insert in the beginning, we'll say 0, and let's say I want to insert minus 1000. Let's just try to print L now. So you see that minus 1000 gets added to the insert, right? Shashwat will be sharing the details in the last session, right? Any doubts till this point, how we can insert and how we can access the elements? So now let us say we want to remove the last element, remove a particular element. Yeah, we can also change a value at a particular index. That is a good question, Ravi. So we can simply say, let's say L of 1 is equal to 1000. Let's try to print L now. So you see that at the first index, the element gets updated to 1000. Pratham, we will cover this thing later. Fine. So also we can remove the elements. So we can simply say that let's say we want to remove the last element. So we can say L dot pop. Pop basically will remove the last element and it will return that as well. So let's say we store it in X and then we try to print what is X. And also we try to print the list. So basically, let's see what happens. So you see that the last element that is returned will be 12, right? Chirag, mutable and immutable is we will cover when we will look at tuples, dictionary sets. So if you see that 12 is the last element that got removed from here, right? Now let us say we want to remove a particular element, right? So how do we do that? So that is, you just try to think about, like just try to research on that, how you can remove a particular element. So there should be a function for that as well. So let us say we want to remove the element 1000, right? L dot remove 1000, and let's try to print L. So this should basically remove the element 1000, right? So there are a lot of these methods that you can try searching in the documentation, right? So I hope you have got a basic idea how you can basically make changes, how you can retrieve the data, how you can sort the data, right? Any doubts till this point? So you can create a nested list as well. So now one more thing, like let's say you want to check if an element is present in the list or not. So at times we want to check the membership property. Check membership. That is, a particular element is present in the list or not. So we can simply say here, let's say print, let's say we want to check whether 5 is present in the list or not. And let's say whether uh, minus 10 is present in the list or not. So there is this in keyword that we looked up yesterday, right? So you see that 5 is also present, minus 10 is also present. Let's see if 10 is present. 10 is not present here, right? Okay. Uh, Ratnesh is asking. Yes, Ravi, just try to search about that in the documentation. Rutnesh, about what arguments? Yes, Rohit, you can look up, learn about stacks. Okay. So one more thing. So we looked at the join operator, the join function. Sorry, we looked at the split function. So let's say that we had the string 1, 2, 3, 4, and we tried to print what is s dot split, right? So let's try to see. So we looked at basically split method. So let's say we have this string 1, 2, 3, 4, 5. So if we say s dot split, so this will basically return a list of strings. Now let us say when we want to join a particular join the elements in the list. So how do we do that? So basically we can say we want to join them, let's say by space dot join of what is s dot split, right? So if you see, you will get back the same string. So let's say I store this list s dot split. If I try to print s list, so the question that we will have today in the quiz will be based upon this join operator. So try to understand this. So basically, we can simply say that, let's say we want to join them based on no particular space, without space. So we can say this empty string dot join s list. Now you will see that we got these elements joined, right? So join operator, as the name suggests, is used to join the elements in a list. how to make nested lists. So Pratham, you can make a nested list something like this. So let us say we have a list of lists. So if we try to print A, you will see that it is a list containing lists, right? Does that answer your question? Yes, we will be covering list comprehension as well. Okay. So I think, do you people want to cover the tuples as well, or this is it for today? Yes, I have covered the 2D list part. Okay, so what we will do is, let's just not cover new concept right now, because it will become a lot overwhelming at this point, right? So let's just take up any doubts that you have, right? Let's just take up any doubts that you have. So I am taking up some of the doubts that we have. So first of all, we wrote s dot split inside the join function because we want join function needs a list, right? So let's say we have a list of integers 1, 2, 3. Or let's say we have a list of strings 1, s1, s2. So now when we say space dot join a, so we will get s1 and s2 joined by a space, right? So join basically takes in the string list as an input and joins the elements of the list separated by spaces, right? So that is why we wrote. So basically, let us say if we have a is equal to s1, s2 already, we try to do now. So if we try to say space dot join a, it will give us some issues here, right? It will not give us what we wanted. So basically, the a is basically simply a string. So now that strings elements, individual characters are basically joined by spaces. So the individual characters, that is s1 space s2, all these are joined by a space. So we wanted the in strings themselves to be joined. So that's why we said a dot split, right? So I hope that answers this question. So any other questions that you have? Okay. So I think that is it for today. We have covered a lot of concepts. So we will be posting a quiz now. So as yesterday, we will be posting a quiz as I announced in the starting of the session. So you can just go to the Instagram page of Scalar Academy. There'll be some exciting prizes to be won. So you can just go to that Instagram account of Scalar Academy. That link is present in the description, and simply you can answer the quiz that will be sharing. So let me share the link here as well. So this is the link. I will be sharing a quiz here within a few minutes, and we'll be selecting winners based on the responses, right? So this one is going to be a little bit challenging than the previous one, the quiz we had yesterday. So hope you are all excited for this. So we have repeated the join concept with them. Just repeat, just try to go back and try to implement it yourself, right? So Amit, it is not mandatory to attempt the quiz. It is not mandatory. So just that if you can check whatever you have learned from today's session, right? So thank you everyone for attending the session, and hope you found the session useful. So just head on to the Instagram page and start giving your answers. We are going to launch it very soon. So the curriculum is mentioned in the curriculum is mentioned in the event that we have on the Scalar page. So if you go to the Scalar website, scalar.com/events, you can find that the link is in the description section as well, right? So thank you everyone. It was nice taking this session and hope you enjoyed. Thank you.
Hello, welcome back to Introduction to Python. So in the last class, we basically discussed briefly over the basic data structures in Python. Right? We paid a lot of attention to lists. We talked about what the mutability and immutability of lists look like. How do you insert something into a list? How do you index into a list? Today, what we are going to do is we are going to take a slight shift, and we will be talking about how to organize your code in Python. Right? So we will be talking about things like modules, how the Python code is executed, things like packages, virtual environment management, and so on. Right? Once again, so after we have covered that stuff, we will come back to the basic data structures. So we will be discussing the remaining data structures like tuples, sets, and dictionaries. All right. Now, once again, if you are new to this stream, we are doing this live Python series in which we start from the very, very basics of Python. And the end goal is to make a complete application using Django, a complete to-do application using Django, and actually deploy it to Heroku. All right, so you will be able to see the previous lectures. If you just go to the video description, there will be a link to any of the previous lectures. All right. So without further ado, let us begin with today's class. All right. So yes, I hope that you can see my screen. Perfect. Cool. So let me quickly exit everything and let me open these things once again. So what I'm going to do is, first of all, I'm going to open a very basic text editor. Right. So as we remember in the first class, we started by coding in a REPL, right, an online code editor. But today, after that, we have moved to a local setting, right? We have moved to a local development environment. So I'm going to open my code editor, which will be VS Code. You can use any code editor if you that you want. You can use something like Notepad++ or VS Code or Atom or Sublime Text or even Vim, Emacs, PyCharm, whatever floats your boat, right? So, but please make sure that it is a code editor. It is not just a text editor or a word processor. Please do not use anything like MS Code, and please do not use anything like Notepad, the vanilla Notepad. All right. So let me quickly open VS Code over here. So I've just opened VS Code over here. Let me also do one thing. Let me open the terminal. So irrespective of whether you are on Mac OS, Windows, or Linux, you will have a terminal. So if you just open this terminal, I'll just open this on the side over here, and I'll just open the VS Code on the left over here. Let me resize the windows quickly. Cool. Now what I'm going to do is, first of all, I'm going to create a new folder for today's class. So let me create a new folder. How do we create a new folder in terminal? We do mkdir, which stands for make directory. So let me quickly zoom in over here. We do mkdir, which stands for make directory, and then we enter the directory's name. So we can do project organization. Right. So now if I do ls, I will see that a folder has been created with the name project organization. And to go inside this folder, I can do cd project organization. Right. So now we are inside this folder, and currently this folder is empty. All right. So let me quickly go over here in the VS Code and let me quickly create a new file. Let me create a new file, and let me create a very simple file, and let me save this file inside this folder. So I am in the home directory over here. Let me go to this folder, project organization, and let me save this file as example.py. All right, perfect. So let us quickly ignore these warnings that are coming over here. Let us quickly close as well. Let's go back to the example.py, and let us cite a very simple hello world program over here. So I'm just going to write print hello world. Right. Now, how do we really execute this? How do we really execute this code using our terminal? We will have to. So I'm in this project organization folder. If I try to list the directory, so once again, ls stands for list directory. If I list the directory now, I will see that yes, there is a file called example.py in my directory. Right? Over here as well, you can see that. So currently, I don't have any folders open, but this example.py is saved in my home folder, and inside that, this directory called project organization. To execute this, I will run a command that will look something like this: Python 3 followed by the name of the file. Right? So Python 3 followed by the name of the file, in this case, example.py. Now, when I execute this, we will get a hello world back. Now, depending on your system, whether you have Python correctly set up or not, you might get an error or you might get a result back. If you are getting an error, then please make sure that you have downloaded the latest version of Python from python.org. All right. So in the first class itself, we discussed how to set up Python. We shared some resources. There was a very nice link that we had shared, which allowed you to install Python on any operating system that you are working on. So please, if you are not familiar with how to install Python, please go to that first video and follow it along. All right. Cool. Now, once we have Python installed, we have to kind of figure out where the Python is actually installed. Because as we know, there are multiple versions of Python. Right? There's Python 2, there's Python 3. Inside Python 3 as well, there are multiple versions. For example, someone might be using Python 3.5, someone might have Python 3.7 installed, and so on. I suppose the latest version currently is Python 3.8. Okay. So since you might have multiple versions of Python installed on your system, it makes sense to know which Python you're currently running in. All right. So there are two ways of doing that. The first way is in the code, you can do something like the following. You can import the sys module. You can import the system module, and then you can print the sys.version. So this variable sys.version, this stores the current version of the Python interpreter that we are running. So if I go over here and I run the example file again, I suppose I did not save it. Let me save that and run the example file again. We will see that I am currently running the Python version 3.8.2, right? The other way I can do is I can come over here and write Python 3 minus version. Right? If I execute this, I will get the Python version once again as the output. All right. Now this tells me what Python version I am using. If I want to find where this Python file is located, right, where this actual executable is located, I can use the which command. Right. So the which, not that magic doing which. This is the which command, and I can type the name of the command. Right. So I can type the name of the executable that I want to find. So which Python 3. This will give me the location of this Python 3 file. So I currently know that this Python 3 file lives in user bin Python 3. All right. Perfect. So depending on what your program is, depending on what your project is about, you might want to use different versions of Python, right? So we will come in a second to how to switch between different versions of Python, how to make sure that we have the dependencies managed in a nice way. But before that, let us go back to our code and let us quickly see how Python really executes these files, right? So once again, we are back in this file. We are back in this file over here. Let us delete everything and let us create several print statements. I will create print. This is statement 1. Statement 1. And let me copy this several more times. So this is statement 2, statement 3, statement 4, statement 5. Right. So if I execute this file, you all know what is going to happen. If I very quickly execute this file, Python 3 example.py, you all know what is going to happen. All these statements will be printed out from top to bottom. Statement 1, statement 2, 3, 4, and 5. Unlike most programming languages, unlike most compiled programming languages, Python strictly executes the file in a top to down manner. Right? So Python will execute this line, followed by this line, followed by this line. And it doesn't really matter what kind of code you have in the file. Python will always read the file from top to bottom and it will start executing things. All right. For example, I could come over here after print statement 5, I could define a function. I could define a function, and inside this function, I could do print inside function. Right. So if I do this, and once again, after that, I can say print statement 6. If I execute this file, what do you think the output will be? So Python will start executing the files. Right? Python will start executing the files. It will start from line 1. It will print statement 1, statement 2, statement 3, statement 4, statement 5. What really happens when Python touches this line? Python will execute this line as well. So Python will execute this line, However, this inside function, this print statement will not be executed. The reason is that when Python is executing this line, this is a line that declares a function. So what Python is going to do, it is going to read this function definition and it is going to create a variable in its memory. It is going to create a variable called foo, and that foo variable will hold a pointer to a function. Okay. So after this, we will print the statement 6. So actually what you will see printed out is statement 1, 2, 3, 4, 5, and 6. But in fact, Python also did execute this line. When it executed this line, it just declared the function. It did not call the function. Right? So if I just run this code very quickly, we will see that yes, 1 to 6 are printed out and the function has not been called. If I want to call the function, I have to explicitly call it. I can say something like foo, and I can call this function using these curly parentheses notation. Now, when I run this code, the statements 1 to 6 will be printed out, and after that, this function foo will be called. So after that, the inside function will be printed out. Okay. So this is very simple. Python simply reads your file from top to bottom and starts executing statements. Whenever there's a statement like a definition, right, a function definition, or whenever there's a statement like a class declaration, so class spam, and we might have something over here, so print hello. Right. So all these things, whenever Python hits line 7 and tries to execute this line, it will not in fact execute this inside line as well. Python will not execute this line. It will just store this. It will just create a class and store that in the variable spam. That is what will happen when it executes the 7th line. All right. Perfect. Vidhan is saying that the code is not properly visible. Can you please change the background theme? So the current theme for the entire thing is dark. So I hope that it is clear to you guys, but let me quickly zoom in. Perhaps this is a little better. Right? Yes, can you guys see the screen better now? Perfect. Ravinder is asking, we could add an error in function foo, which would tell it run top to bottom. Not really. So Ravinder, if something bad happens over here, for example, if I try to do something like print 1 divided by 0. Now in Python, let me quickly open Python terminal over here. In Python, if we try to do 1 divided by 0, we will get an error back. Right? The error is 0 division error. All right. Now, if I try to do something like print 1 by 0 inside this function foo, notice that this line will not be executed unless I call this function. This line will not be executed unless I call this function. So if I have code that just looks like this, this faulty line is inside the function, but the function is not being called. Right? Notice that this line is commented, the function is not being called. This program will run just fine. And I will see 1, 2, 3, 4, 5, 6. I forgot to save it, I suppose. We will see 1, 2, 3, 4, 5, 6 printed out. Right? Now, if I actually try to call this function, that is when I will get an error. Right? So 1, 2, 3, 4, 5 will be printed out. Then 6 will be printed out. And then when I execute foo, the Python interpreter will go inside this function. It will try to calculate this line, and which will result in an error. So I see after the 6 statement has printed, I was calling the foo function, and inside the foo function, I got a 0 division error. All right. When you actually declare this function, this line will not be executed. So if there is an error in this line, that's perfectly fine. As long as the error is not syntactical, as long as the error is a runtime error, this declaration will work just fine. The error will happen when you actually call the function. Okay. Perfect. So let me quickly zoom out over here in the terminal, perhaps, so that this is a little more visible. All right. So the key thing to remember over here is Python executes files from top to bottom. Let's move on then. Now let us move on from one file to multiple files. Okay. So suppose that I create one more file over here. Let me create one more file over here. Let me say this is some module.py. All right. So if I do a listing of my directory over here in the terminal, we will see that we have two files now, the example.py that we already had and the summodule.py that we have just created. Let me come over here inside the summodule.py. Let me include a print statement inside some module module.py. All right, perfect. Now let me try to import this line in the example.py. So let me remove some of the code, and let me come over here and let me import some module. Right? Let me import some module and let us see what really happens. Right? When we try to execute this code, what Python will do is Python. So let us say that we are going to execute example.py. So Python will start reading this file from top to bottom. It will say, okay, I have to import some module. As soon as Python hits this line, it will look for this file and it will start executing this file from top to bottom. So the first thing that will be printed out will be this statement inside some module.py. Once this file has been completed, once this file has entirely been read out, Python will come back to this location and it will print the statement 1. Right? So the expected output here is first this gets printed out, then this statement 1 gets printed out. And as we see, that is exactly what happens. Right? Inside some module gets printed out first and statement 1 gets printed out next. All right. Now, once again, unlike most languages in which all your import statements should be at the very top, right? Whatever libraries you are importing, they should be at the very top. That is not true in Python. You can take this import statement and you can move it anywhere. So I can take this import statement and move it under this statement as well. So now when Python runs my code, Python will first encounter this line and it will print statement 1. After that, it will go to import the module and print this particular code over here. Is that clear? Yes, so let us quickly run this now. Now we see that the things have reversed. I forgot to save it as a course. Yes, now the things have reversed. Right? So we print the statement 1 first and then we import the module. And when we import the module, this line gets printed out. I hope that is clear. Perfect. So there is one thing that we basically learned over here, that whenever we are splitting our code into multiple modules, we should not really execute the code directly. We should not really execute the code directly. Over here, there could be some code that deletes a file. If I'm importing someone else's code, I don't want that code to execute directly. I want that code to be declared so that I can call that code whenever I want to. I don't want to call that code directly. For that, Python provides something else. Right? So currently, let me try to print out a new variable over here. So let me just remove anything and let me just print out a variable called name. Right? So the syntax over here is underscore underscore name underscore underscore. Right? So there is double underscore. And in Python, you can also call this as dunder values. Right? So this is dunder name. The way you would pronounce this is you would say dunder name. And this just stands for double underscore name double underscore. This is a convention that Python uses for a lot of different variables. All right. So you will be seeing a lot of underscores in Python code. All right. Let us quickly try to execute example.py and let us see what we get. When we execute example.py, it says that the name variable holds this value underscore underscore main underscore underscore. All right. And that is how you distinguish whether you are being executed or whether you are being imported, right? So let me come over here. Let me quickly go to this module and let me also include the same line over here. Print dunder name, right? So I'm in some module. I'm printing the dunder name in some module. I'm also printing the dunder name in example.py. And let me quickly import some module from that file. So what do we expect to see? We will go inside some module. And we will execute this line, print dunder name. Then we will come and execute this line. But the value of dunder name for both these files will be different. Right? The value when we are in example.py, that will be underscore underscore main. But when we are in some module.py, the value of the dunder name variable will be different. Let us quickly see what we actually get. So we get over here some module, right? Basically, whenever Python imports a module, whenever you import a module like this, in the module, the dunder name variable will be the module name. So for example, in this case, some module. On the other hand, if you're directly executing the module, if you're directly executing that file, then the name will be dunder main. All right. So for example, in this example.py, I was importing the some module. So the dunder name was some module. But if I come over here and I directly execute some module.py, then in this function, in this file, the dunder name will be dunder main itself. Right? It will be dunder main and not some module. Is that clear? And that is basically how we can distinguish between when our code is being imported versus when our code is directly being executed. All right. Rohit is asking, are these constants? No, Rohit, in Python, nothing is a constant. I could totally come over here and try to change the value. So I could say dunder name equals to hello. Python allows that. Right? I can now print this value of dunder name and it will print out hello for me. Right? So main is printed, then hello is printed. So in Python, everything is changeable. All right. Dhruv is asking, does import also lead to execution of module? So that's a good question, Dhruv. Yes, whenever you import a module, you're actually executing it from top to bottom. Whenever you import some module, you're actually executing that module from top to bottom, which is why whenever you write a Python module, it is never a good idea to have executable code. The way we actually do things is we define functions, right? We define our variables, we define our functions over here. So I can say def foo and print inside foo, right? But I will not call foo. I will not call foo over here, right? So that when I import this module, only this function gets declared. The function does not get executed. If I want to execute that function, I can come over here and I can say some module dot foo. All right. So if I do this, then I will be calling some module.foo explicitly. By just importing this module, Python will execute this module from top to bottom, but this function will not be called. This function will just be declared. Is that clear? Yes. So once again, if I quickly save both these files and run them, then we will see. Interesting. Nothing really happened. Oh, I ran some module, my bad. So if I just run some module, then I should not get any output. Right? I should not get any output. But when I run example.py will actually import this module. This function will get declared, and then it will finally call this particular function. If I comment this out, if I comment this line out, then you will see that just importing this module will not execute the function. So if I just import this module and try to run this, we see no output because the function got declared, but it did not get executed. All right. Okay, moving on. Now, if you want to detect whether you have been run as a module or whether you have been imported, how will we do that? Well, very simple. We already know that if our dunder name is equal to dunder main, right? If the value of this variable is this, then we have been executed. Otherwise, we have been imported. Yes. So which is why a lot of the times in Python code, you will see something like this. You will see something like this written out. If dunder name equals to dunder main, then you will actually call some functions. So perhaps you will call the main function over here. So def main code print code is being executed. Right? So let me quickly come over here. Let me try to run example.py. Let me try to execute example.py. And over here, we see that, yes, we get the output code is being executed. Why does this happen? So the interpreter starts from the top. The interpreter tries to run this line. When it runs this line, a function is declared. After that, it will run this line. It will check if the dunder name variable is actually equal to dunder main. Yes, it is, because we have executed the module. And then it will finally call the main function, which will print this particular line. On the other hand, if I try to import this module, so let me create one more file over here. Let me create a file called importer.py. And inside this importer.py, if I try to import example, and if I try to run importer.py, I will see nothing will be printed out. Because just by importing example, I am not calling the main function. Remember that when inside importer, when I import example, then this dunder name variable for the main function will contain example. It will not contain this dunder main value. So this code will not be executed. This function will not be called. Right? Now you understand basically why you see this kind of line in Python code if dunder name equals to dunder main. All right, and this is a very common pattern that you will see in Python codes. Perfect. Let us move on then. So far we have been talking about different files, but these files in Python, the correct term for them is modules. So every .py file is a module in itself. Now we can go ahead from modules to packages. So there's something called packages in Python as well. What we can do is, if we want to structure our particular program as nested directories, right? Or if we want to make sure that we are in different namespaces, what we can come over here and do is we can nest our code into further directories. So let me give you an example. So currently, this is what the code looks like. This is what my directory looks like. So this is the current directory. Right? Inside this, I have an example.py, I have an importer.py, and I have a some module.py. Now let me create another directory inside this. So mkdir package, right? And I'm going to, so now if I look at it, I will see that a package directory has been created. Inside this, currently there are no files. Let me create a file inside that. Okay, let me create a file inside that. And let me say inside package or package module, let me call this package module.py. All right, perfect. So let me quickly show you the tree once again. So we have example.py, we have importer.py, then we have a directory package. Inside the package directory, we have a package module.py, and once again outside we have some module.py. All right, now let us go to importer and let us try to import package module. Let us try to import package module. Right. Let us try to import package module. Let us see what happens. Let us try to run Python 3 importer.py, and we get an error. We get an error saying that, hey, there was no package named package module. So what really happens is, when you try to import it, Python will try to look in this same directory. I mean, the actual thing that is happening is much more complicated. But what you can understand for now is Python is trying to look in this same directory. In this same directory, there is no file called package module.py. Why is there no file? Because that file is inside another directory. It is inside another directory. So I can't import it like package module. What I have to do is I have to give the name of the outer directory as well. I have to give the name of the package as well. So I can say something like package.package module. Now what Python will do is it will go inside this Python directory and then look for the package module. So if I run this, I get nothing back. Basically, the code executes successfully. All right. Perfect. Now you don't really need to understand it right now. You don't really need to know it right now. But I just want to introduce one more concept. In packages, you often will see files like dunder init. Right. So once again, we see this double underscore pattern over here. Dunder init is a file that is executed whenever you import a package. Right? So if I say print hello, over here, and if I come to the importer, let me quickly open the importer file once again. If I come to the importer and if I try to import package, then if we run this file, we will see that hello is printed out. The reason hello is printed out is because whenever Python imports a package, if this file exists, if the underscore init underscore.py file exists, Python will execute that. Okay, this file will initialize the module for us. Is that clear? Now there's a lot more to packages and modules and namespaces in Python. We are not going to go into so much depth because that is basically beyond the scope of what we can cover in 1 hour. Right? If you want to learn more about it, feel free to go to python.org, and over there you will be able to go through a tutorial that will give you all the insights and all the in-depth information of how packages and modules work. Perfect. Now let us quickly switch our gears from packages and modules to something called virtual environments. So I'm not sure how many of you are familiar with this, but just like on your system, you can install different softwares. Just like that, with Python, you can install different libraries. Right? So for example, if I come over here and I execute Python 3, if I try to import a library, something like matplotlib, this is a library that helps with drawing charts, that helps with some numerical or some graphical data visualization. If I try to import matplotlib, it is telling me that no module named matplotlib exists. Okay, so this library is not available to Python at the moment. Similarly, if I try to import pqdm, perhaps this gets imported because pqdm is installed currently on my system. Right? Now let me quickly show you where these values are, where these things are installed, and how to install a particular library. So if you want to see what all libraries are currently installed with your Python, you can do something like pip pip3 list. And this will give you a list of all the things that you have installed on your system currently, along with this Python. Right, so in this, you will see that TQDM has been installed. So this thing called TQDM, this library called TQDM is installed on my system, which is why I could import it. Right? But nothing like matplotlib exists on my system. Right? There's no matplotlib installed on my system, which is why I cannot import it. If I want to install this, I have to say something like pip3 install and then the name of the package. So matplotlib. So if I do this, this matplotlib library will be downloaded from the internet and it will be installed on my system. It might take some time. So now it is completely installed. Now if I go back to Python 3 and now if I try to run import matplotlib, this will work perfectly fine. Is that clear? So once again, to install a package, install a library, we have to do pip3 install the name of the library, right? And if we want to see what things are installed along with Python, what libraries are installed with Python, we can do something like pip3 list. All right, perfect. Now this is usually what we will usually never do this. This is a very, very bad practice. Currently, what I'm doing is I am looking at the global Python installation on my system. Right? So just like we saw that we were executing this Python 3. Right? So this Python 3 was installed in user bin Python. This is the global installation of Python on my system. Now, when we deal with larger projects, dependency management becomes a challenge. Right? The term is dependency management. That becomes a challenge because some projects might be using a different version of a library, while other project might be using a different version of that same library. Also, managing for a particular project, suppose that you are going to ship your product, right? You are going to give your project to a friend. How does your friend know what all libraries they have to install to make sure that your project works? Right? So basically managing all the dependencies of your project, that is something that we call dependency management. And for dependency management, to keep in mind that dependency management is necessary for us, we never install things in the global Python installation. Instead of that, what we do is we create something called virtual environments. Right? So to create virtual environment, first what you will have to do is you will have to install sudo apt install python 3 virtual env. Right? So the command over here is sudo apt install python 3 virtual env. Right? Now this is if you are working on Linux-like systems. So if you are on macOS, you will have to probably do brew install python 3 virtual env. If you are on Windows, you will have to I think the default installation of Python that you get, the default exe that you get to install Python automatically installs the virtual environment. All right. So if I hit enter over here, currently it is already installed on my system. So it will ask me for my password. I will quickly enter my password, and it is already installed on my system. So it will not really install anything new. But on your system, if it is not installed, it will download and install this package. Now, once this package is installed, we can come over here and we can specify something like virtual env. If I run this command, I will get a large output back. Notice that I'm getting an output back and not an error back. Right? I'm getting an output that is telling me that, okay, you're supposed to pass some extra parameters to this command, which you have not passed. Now, we will be using this virtual environment command to manage our Python installations. Not only Python installations, we will be using this to manage the virtual environments. Okay, so bear with me over here. Let us run a quick command first. What we are going to do is we are going to do virtual env -p. So -p stands for the Python installation over here. And we are going to specify the path to our Python installation. So user lib python 3. Right? After that, we are going to also give it a directory name. So let me give it a directory name called vn. Okay, so what this is going to do is it is going to create a virtual Python installation. It is going to create a virtual Python installation inside this directory vn, right? And that virtual Python installation will be a copy. Right? It will refer to this Python. It will use this Python executable. So as soon as I hit enter, interesting, user lib python 3. Let me quickly see which python 3. Okay, it's not user lib python 3. It's user bin python 3. Right? So my bad. I entered the path incorrectly. So it is user bin python 3. When I hit enter, it will create a virtual environment. So notice that the output says created virtual environment using this CPython, right? Using the Python 3.8 interpreter. Apart from that, it also tells me several other things. It tells me that these all things have been installed. Right? These all things have been installed. So let us quickly see what our directory looks like now. A new file, a new directory called vn has been created. All right, a new directory called vn has been created. And if I try to do a tree in this, I will see that inside this vn directory, there are lots and lots of things. Right, so inside this vn directory, there are tons and tons of things. Inside this VM, there's a bin in which we have several files over here. There's a lib in which we have tons of other files over here. Right? So this is a virtual. This is an isolated Python environment that has been installed for you. Right? Now, it is not activated yet. So for example, if I do Python 3, if I try to run Python 3 right now, the Python 3 will be executed from this location. Right? That is not going to help me. To activate this environment, what I have to do is, I have to enter something like this. I have to say, so notice that this is the name of the virtual environment. I have to say source vn bin activate. Right. So inside this vn folder, there's a directory called bin. Right. Bin stands for binary. Inside this bin directory, there's a file. There's an executable file called activate. So what I have to do is I have to execute that file, and I have to basically source it in my terminal. Right. That will make sure that whatever exports, whatever things the file has changed, whatever environment variables that file has changed, my current terminal takes them over. So if I execute this, two things will happen. So first of all, you will see your prompt has changed. So earlier my prompt said pragya at zen. Now notice that my prompt is saying pragya at zen, and it is also showing me that I am currently working in this VM. Right? I am currently working in this VM. The second thing that has happened is your virtual environment has gotten activated. So now if I look at which Python 3 will be run, if I try to execute Python 3, instead of getting that user bin Python 3, the Python 3 that now will be executed will be inside this VM. Right? So this is my home folder. This is my home folder. Inside this, I have this directory, project organization. In that, I have created this virtual environment. And in that, inside bin and Python, there's a Python installation. So if I try to run Python 3 now, this Python installation is called. Now in this Python installation, by default, there is no library installed. So if I try to import pqdm, it gives me an error. If I try to import matplotlib, it gives me an error. Notice that in the default Python installation, all these libraries were available, right? But in this new Python installation, these libraries are not available. So let me quickly exit, and let me also try to see by pip3 list. Let me see what libraries have been installed. And in these libraries, these are some default libraries that will automatically be installed, right? But anything like tqdm, matplotlib has not been installed. All right. So currently I'm working in an isolated Python environment. If I want to install something, suppose I install tqdm in over here, pip install tqdm, my bad. This tqdm library will be installed in this current virtual environment. Right? As long as this virtual environment is activated, this tqdm library will be installed in this virtual environment. Now, if I do pip list, now I will see that tqdm has been installed. All right, and the nice thing is that whatever packages, whatever libraries I install in this virtual environment, they will remain in this virtual environment. It will not affect any other virtual environment, or it will also not affect my global installation of Python. Right? So that basically allows us to isolate our dependencies, to isolate our project and libraries. Okay. So currently the virtual environment is activated. If I want to get out of the virtual environment, I have to enter the command deactivate. Notice that this command will work only when the virtual environment is activated. If you try to execute this command otherwise, so currently I'm out of this virtual environment. You know that because my prompt has changed back. Right? My prompt has changed, gone from virtual environment back to just pragya at zen. Right? So if I try to run this command now, it will give me an error. It will say that, okay, deactivate command not work. This command will only work when you are actually inside the virtual environment, when you have actually activated the virtual environment. Now, if I try to run with Python 3 again, I will see that I will get user bin Python 3. Okay. Very quickly, once again, if I do source vn bin activate, and now if I run with Python 3, once again, my Python installation has changed. And to deactivate, I can do deactivate. All right. Perfect. Yes, this is so. Pratham has a very nice point over here. Pratham is saying that this is like an incognito mode for Python. Pratham is saying that this is like an incognito mode for Python. Exactly. All right. Perfect. So I want to leave you with this over here with respect to the virtual environments. There's a lot more to working with virtual environments, managing dependencies, right? Installing and shipping dependencies to other people, right? There are things like Docker. There are several other things that you use as a seasoned software developer. But we are not going to discuss all of that today. If you want to learn more about that, feel free to go to, once again, python.org, and you will be able to get much more information over there. All right. Now let us quickly switch gears once again, and let us go back to the data structures that we have been discussing. Okay. So let me quickly go back, and let me create a new file over here, and let me save this as datastructures.py. And let me save this in the Python organization folder. Perfect. So far in the last class, we have discussed about the most basic data structure, which is a list in Python. Yes. Does everyone remember how to create a list? So if I want to create a list with the numbers 1, 2, 3, and 4, I can say my list, or something like my list equals to, and what is the syntax? This square brackets, right? 1, 2, 3, and 4. Right. Now I can come over here and print my list. So if I try to execute this, Python 3 or ds.py, if I try to execute this, I will get that list printed out. Right? If I want to create a list of all the numbers from 1 to 1000, how can I do that? If I want to create a list from 1 to 1000, then how can I do that? Will I have to type everything one by one? Not really, right? I can use this range function that we have discussed. So this range function takes 3 parameters: the start, the end. Notice that this end will be excluded. So 1001 will not be part of my result. And the step, right? So it will increment and steps of 1. So if I say my list 2 equals to range 101, if I try to print my list 2, I will get a weird output. Right? If I try to print this, I will get a really, really weird output. It will say that my list 2 is range 1 to 1001. Right? It doesn't really give me the list. If I want to create a list, I will have to explicitly convert it into a list. The reason is that this range function gives you back a range object, which is sort of a lazy object in Python. Now you don't have to worry about what lazy and what eager competition right now is, but just understand that this range function, when you call this range function, it will give you back a range object. If you want to actually see what's in this range object, you have to convert this into a list explicitly. So if I try to execute it now, this huge list will be printed out. All right. Perfect. So this was the basics about lists. Yesterday, we also saw how to index into lists, how to find things from lists, and so on and so forth. Right? Today, let us talk about some other data structures. So let us talk about tuples. Tuples are very, very much like lists. Right? So tuples are almost exactly like lists. There's one crucial difference between tuples and lists, though. The difference is that lists are mutable. Basically, once you have created a list, you can change it. On the other hand, tuples are immutable. Once you have created a tuple, you are not allowed to change it. Right? It is not changeable, right? You can't change it. You can definitely create a new tuple. You can definitely come and create a new tuple, but if you have already created a tuple, you cannot change it. Right? So let us look at an example. Just like this list has the syntax of square brackets, just like that, a tuple has a syntax of round brackets. Right? So I can come over here and I can say my tuple equals to 1, 2, 3. Right? So this will be a tuple, and I can print my tuple. Right? So let me remove this huge list from here so that we don't clutter our terminal. So if I run this, I will see that the list has been printed and this tuple has been printed. All right. Now let me quickly show the difference between lists and tuples. So if I try to change this list, my list of, let's say, 0. If I take this first element, I can change it to something like 100. If I run this, then after this has changed, my list will be, the first element of my list will be 100. But if I try to do the same for the tuple, if I try to do my tuple 0 equals to 100, then let us quickly see what happens. When we try to execute this line, we got an error. The error said tuple object does not support item assignment. Basically, for any index in the tuple, you can't assign a value to it. You can't change the value. All right. So tuples are immutable. Is that clear? Perfect. Now, if you want to create a list, if you want to create a list that has just one item in it, suppose the number 1, then how do you do it? You can simply come over here and say my list equals to 1. Yes, you can come over here and say my list equals to 1, right? So this will give you the list just 1. But what if you want to create a tuple with just one value in it? What if you want to create a tuple with this one value in it? My tuple. Will this work? Well, let us quickly see what happens. Let us quickly see what happens when we execute this. We get a list back, but this just looks like the number 1, right? This just looks like the number 1. In fact, if we print the type of my tuple over here, if we print the type of my tuple, then we will see that it is not a tuple at all. It is an integer. The reason is that this bracket notation, right? This round bracket is also used to club expressions. Right? These brackets are also used to club expressions together. So to distinguish a tuple with one element with just the number 1, what we have to do is we have to have a leading comma over here. We have to end it with a comma. Now if I try to execute this, this tuple will actually be printed, and you will see that the type is now tuple. All right. Perfect. So tuples are exactly like lists. It is just that tuples cannot be mutated. So whenever you are looking for a list that others cannot change, you will use a tuple. Other than that, the indexing and everything else remains exactly the same. Now, once again, when you were creating a large list, you could say my list equals to list of range of 100, and that will give you a list of 100 elements. If you want to do the same with a tuple, you can say tuple of range of 100. This will give you a tuple of 100 elements. All right. So firstly, we get a list of 100 elements, then we get a tuple of 100 elements. This is a tuple because it is delimited by these brackets, by these round brackets and not the square brackets. Okay. Prakash is asking why this extra comma is there. Right. So back when we did this, my tuple equals to this. Right. Why did we have to include this extra comma? Right? That is the question. So let me quickly once again answer it. So suppose that we are doing something like 1 times 2 plus 3. Right? Suppose that we are doing 1 times 2 plus 3. We've all studied BOD-mass. Right? We have all studied BOD-mass or PEG-mass, whatever you call it. So what will be the order of these operations? Multiplication has higher precedence than addition. Right? Multiplication has higher precedence than addition. So 1 times 2 will be executed first, then 3 will be added. So the result over here will be 5. If I want to override that, if I want to say that, no, please execute this thing first. Right? If I want to say, please execute, let me make this 10 perhaps. Right? So the current result will be 23. If I want to execute this thing first, then I will have to explicitly put this in brackets. Yes, I will have to explicitly put this in brackets. Well, this will give me the answer 50. Well, what if I do something like this? What if I do something like this? This is just saying, take the number 1, and this number 1 is in brackets. Right? This number 1 is in brackets. So basically, we are not really doing anything. Right? I could come over here. I could write 1 plus 3. 1 plus 2 is the same as this 1 plus 2. Right? So these brackets are not really doing anything. These brackets will be completely ignored. Now we want a tuple over here. Right? By these brackets, we are not seeing the mathematical expression 1. We want to specify a tuple, and to distinguish the syntax between a mathematical expression and a tuple, we have to give an extra comma at the end. All right. Perfect. Cool. So this was very briefly about tuples. You will use tuples whenever you want to use a list, but you want the list to be immutable. Let us quickly move on to something called sets. All right. So if you have heard of sets, set is nothing but just a collection of objects. Right? A set, mathematically, a set is just a collection of things. Right? In Python, sets mean a little differently. So sets, once again, they still are a collection of things, but they have some other properties associated with them. The most important property is that sets are implemented as hash sets. Right? So if you're not familiar with what hashing is or how hash table works, don't worry about it right now. When you actually take a data structures and algorithms course, you will be able to understand how hashes work and how hash sets work, right? And why they are important. But for those of you who are familiar with it, Python sets are implemented as hashes, which means that a lot of the operations, indexing into it, checking if a value is there or not, inserting and deleting into it, not indexing, inserting, deleting, and checking if a value is there, they are amortized constant time operations. Right? Now, to create a set, we have a different notation. So once again, this is for a list. This is for a tuple. For set, we have to use this notation. This notation is for a set. All right. So let us quickly see how sets work. So I will say that my set equals to 1, 2, 3, and this will create a set. If I try to print out my set, let's quickly see what gets printed out. So 1, 2, 3 has been printed out. Let me just remove this thing. Let me just remove the previous code over here. Right. So this 1, 2, 3 will get printed out. Okay. Now, just like list supports a lot of different operations, sets also support a lot of different operations. To actually see what all operations sets support, what you can do is you can go inside your Python REPL. You can go inside your Python REPL and you can type help set. Right? And it will tell you all the different things that set supports. So it will tell you that, okay, this class has many different methods. So some of these are called magic methods. These methods that start and end with underscore, these are called magic methods in Python. Right? But apart from that, it has some methods like add, clear, copy, set difference, difference update, and so on and so forth. Right? Set intersection, checking disjoin, checking subset, and so on and so forth. All right. So very simply, if you want to insert something into a set, you will say my set dot add, let's say the value 10. And now if I print my set, the value 10 will be included in the set. Right? So the value 10 is included in the set. Now notice the thing that when I added the value 10, the value was added towards the front. Right? The value was added towards the front. It was not added towards the end, which is surprising. Right? If I try to add perhaps another value, so let us say that I try to add the value 123, right? This some random value, and if I try to print it once again, now the 10 has been added after 3. In the previous run, the 10 was added before 1. Now it has been added after 3. That's weird. Right? So the point over here is sets are always unordered. Sets are unordered. You can never ever rely on which order the elements will come out in. When you insert something into a set, the set tries to ignore the order. It does not try to remember the order, which is why it can do some operations much more quickly. Right? So if you want the order to be preserved, don't use something like a set. Instead, use something like a list or a tuple. All right. So sets will always be unordered. The order can change arbitrarily. All right. Perfect. Now let me quickly show you why sets are so powerful. So suppose that I have a list, my list. So let me erase everything. Let me create my list, and I have a very large list. Right. So I have a list of all the numbers from, let us say, 1 to 1 million. Right. 100,000 and 1 million. Right? This is my list. If I try to find if a particular element is in my list, then how should I do it? I can do something like print some element like 9999 in my list. Okay? Or perhaps 99999 in my list. Yes, I can come over here and do something like this. So let me run this code, and we quickly get the answer true. Right? We quickly get the answer true. Let me try to increase this value. Right? Let me define an n, or not int n. I will just say n equals to 100,000, 100. Right? So suppose this is my n, which is basically 10 million right now. 10 million. Right? And let me define the number value equals to n minus 1. Right? Or let me just write it over here. So I will check if n minus 1 is inside the list. Right? Because I'm creating a list of all the numbers from 0 to n, excluding n minus 1 will be in my list. Right? So I should always get true back. Let me try to run this once again. It took some time. Right? It didn't execute immediately. It took some time. Let me add one more value over here. Let me add one more 0 over here. Let me see how much time this takes now. So it is taking much more time. Right? It is taking much more time. So the reason it is taking time right now is because it has to do a lot of memory allocation. Right? The time currently is not just constrained by this operation, by just checking. It is also constrained by the time it has to spend to create this particular memory. So instead of doing this, let us create a smaller list. Let us create a list of just 1,000 items. Let us just create a list of 1,000 items. But let us do this thing again and again. Let us do this loop again and again. So I will do for underscore in range 1,000 or 10,000. I will do this thing 10,000 times. Right? n minus 1 in my list. It will just check if n minus 1 is present in my list or not, and it will do that 10,000 times. Right? And finally, I can print Done. Right? So let us see how much time this currently takes. Let us see how much time this currently takes. It was done very quickly. Right? Let me try to increase the number of iterations. Let me try to increase the number of iterations. And now we see that this takes a very, very long time. Right? Now this takes a very, very long time. The reason is that in lists, if we have to find a particular value, if you have to search for a particular value, that searching is linear time. Right? That searching is linear time. On the other hand, if we are looking at sets, then the search is order of one time, amortized order of one time. It takes this constant time. So if I do this with a set, you will see that it gets done very, very quickly. Right? So once again, if I do this with a list, this will take a long amount of time. So it is taking several seconds, and finally it will be done in some time. It is taking quite some time. Now it is done. But if I switch this to a set instead of a list, if I use a set over here, then it will give me back the answer immediately. Right? Because checking if a value is present in a set is very fast. All right. Perfect. Now, just like we have sets, we have something called dictionaries. Right? So once again, this was used to denote list. This notation was used to denote tuple. This notation was used to denote set. Well, for the dictionaries also you have the same notation. This is also used to denote dictionaries. Right? Now, dictionaries are maps. Dictionaries are mappings. So dictionaries, they are not the dictionaries that we see, that we actually hold, right? They don't have word meanings. These dictionaries are mappings. So they have some key and they have some value. For example, I can come over here and say my dictionary, or let us say squares of numbers, right, equals to, and now I have to use a different kind of syntax over here. I have to use a key colon value syntax. Right? So I can say that the square of 1 is 1. Then I can say the square of 2 is 4. I can say the square of 3 is 9. I can say the square of 4 is 16, and so on. Okay, so basically what I'm saying over here is that if you look at the square of 1, that value is 1. Right? If you look at the square of 1, that value is 1. Now, how do I get the square of a particular number? If I want to get the square of 3, I can do something like square of squares of numbers, and now I can give it a key. So these things on the left of column, all the things on the left of column, these are keys. All the things on the right of column, these are values. If I give it some key, if the key exists in my dictionary, then this will pull out the value. Right? This will pull out the value. So if I just try to print this, we will see 9 getting printed out. Right? We will see. I guess I misspelled the name. Right? We will see 9 getting printed out. All right. So dictionaries are very powerful if you want to store mappings, if you want to store a key value pair. Now, just like sets, dictionaries in Python are also implemented using something called hash tables, which is why the indexing, or not the indexing, basically the indexing, yes, in this case, the indexing is there. Indexing, searching in a dictionary, right? All these things are very, very quick. Inserting, deleting from a dictionary are very, very quick. All right. I suppose that we can end it at this point today. I wanted to go into much more depth of all these data structures, but unfortunately, we do not have the time. All right, so let us complete that some other time, and let us end the lecture with this. Okay, so once again, if you go into the video description, you will be able to find a link to some questionnaires. You will be able to find a link to a chat where you can basically go and discuss with your peers, with all the people who are watching on YouTube. You will also be able to discuss with the instructors. So I will also be present in the chat. If you have any questions, you can go over there and ask. So the links are in the video description. If you want to see the previous videos of this series, the links for that is also in the video description. All right. So I hope to see you the same time tomorrow. All right. So 6:30 p.m. to 7:30 p.m. tomorrow. And tomorrow we will be looking at some more advanced concepts of Python.
Welcome everyone to the day 5 of Introduction to Python series. Today, we will be discussing mostly about file handling in Python. So just let me know if you can hear me and see the screen properly. Okay, great. So let us get started today. Let's first discuss what is the agenda for today. So basically, first of all, we will be discussing about how to open text files, how to read to text files through a Python program, how to write to a text file. Then basically we will see the different modes in which we can open a file, right? And mostly like the motivation behind working with files is, let's say you want to write down a program that will take in a large chunk of text file, and let's say count the frequency of every word. So let's say it returns the word which comes the maximum number of times, right? So if you are to write such a program, you will have to deal with files. And also many of the times you will be working with APIs, so then you will be reading or basically reading the input in JSON format. So we'll also look at how to read and write a JSON file, how to read and write the CSV files. Like let's say you are working with a spreadsheet file, then you can export it to a CSV file, right? So we will see how we can use Python programs to read data and write to CSV files. So basically the agenda for today is, first section we will discuss how to read and write from text files, then second section read and write from CSV files, and third section reading and writing to JSON files. So this is the agenda for today. Do let me know if there is any questions. So once we start, we will be taking up questions after some amount of time. So like once we are done with the first section, then we will take up the questions so that it does not interrupt the flow for everyone. Does that make sense? So how to set up VS Code in Python, that question must have been taken earlier. So just Google it if you do not understand. The winner of the quiz, Prakash, would be announced on the social media page itself. So that's okay. Let's get started now. So let's start with the session. Basically, why do we need to operate with files? So basically we want to write down whatever data we have in Python to some kind of permanent storage, right? Which we can retrieve at any time. So the program that you will run in Python, that will be working in the random access memory, right? That will be working with the RAM, but you want something to be stored permanently, that is in a non-volatile kind of memory, right? Where it will not go away. So that's where you want to write to disk files, right? So basically what all operations do you need to work with files? So you need to open a file, and then you will have to perform the operations that you need. So let's say perform read or write operations depending on the kind of program that you're writing. And third step, you have to make sure that you close the file that was open, right? So this is the basic flow. Okay. Yeah, about JSON files we'll discuss. And yes, we did not have any class yesterday, so we are taking the part of yesterday today, right? So let's continue. These are the three operations that we will be needing to perform when working with files. So first of all, let's do one thing. Let's try to create a file. So let's say I create a new file in this folder. Let's name this as hello.txt. And let's say we have some text here. So there is some text here. This is, let's say, line number 2. And let's say here we have some mathematical string, 2 plus 5 is 7, right? So this is our file hello.txt, right? So now, first of all, we want to open this file. So how do we do this in Python? Basically, there is a function named as open. So here you provide the file. As you can see here, you provide the file and then you provide the mode. So in which mode, and then the encoding, and like there are some of these optional arguments. So basically, let's just first provide the file name. So we are having this file1.py in this folder day5_live. So we'll create the file name here as hello.txt. So because this is a relative path from this directory where we have this Python file, right? Does that make sense till this point? So then basically what we can do next is we'll provide the read mode. So we are currently reading it. So we'll say we have the read mode. Read mode is specified using R keyword. So that's how we will open this file, and this will return a file handle. So basically the file handle is here F, right? So now whatever operations we need to do, we want to read it. So we can use this file handle that is returned, file object or handle, right? So let's try to read something. So let's say f.read, and let's try to print whatever is the output. So this read function is basically what we will use. So let's see what will be the output for this, right? So yeah, let's wait for the terminal to open up. Okay, so let's go to the day5_live directory, and let us try to run this program. So let's say python3 file1.py. So you see that whatever was there in the text file, you could read it, Does that make sense? So this read function basically is returning everything what is there in this file, right? So let us say we want some specific characters. So if you have noticed earlier, like when you are writing, so it takes an n, that is an integer, as an input. So let us say we want to access only the first 5 characters in this file. So let's try to run this now. So you see that only the first 5 characters were input, were read from the file, right? So basically, optionally, you can provide the number of characters in case of a text file, right? Otherwise, it will read the entire file. Does that make sense till this point? Okay. So basically, just keep your questions and we'll take them up once we have understood how to read and write the text files. By default, we are working on text files. So by default, whenever you use open command, it works on text files. So that you can just remember. Now, let us say that we want to read line by line. So how do we do that? So we can say that f dot read line. So read line is a function that will read a single line. Let's try to print the output. So if you see that after there, so there is a file pointer that is being moved when we read something from the file. Okay, so the open function basically returns the object of the file that we can use to access the file contents or modify the file contents. So f is basically file object used to access or modify the file contents. Yes, Rohit, there was no session yesterday. Okay, let's continue. So what you noticed that the output was first of all there. That is why, because we read the first 5 characters. Now you see we get whatever is there after this. So you see we get the space and whatever is remaining in this line, right? So basically why this happens is, like, let's say we comment this line, comment this first line. So you see then we will get the entire first line. So what is happening is there is a file pointer that is getting moved. Once we read something, the file pointer will get shifted and the read process will start from that particular read head, right? So we can also know that where is our current file position. So let's just try to see. There is a function f.tell. So if we say print f.tell, it will provide us the file pointer. So let's try to see. So you see that when we are at the start of the file, it is at 0th position. Let's first read 5 characters and then try to print it. So then you will see that it has moved to the position 5. So that is, so like this is the position 0, 1, 2, 3, 4, and this is the position 5 where this space is happening. So after all this, the entire line will be read. So I hope you have understood everything till this point. So this will give us the current position of file read head, right? So that is till this point. Now let us say that we want to move our file pointer to the starting of the file. So that also we can do. There is a function f.seek. So here we can specify, let's say it asks 2 things. One is the offset and one is the whence parameter. So this whence parameter is used where we want to tell from which position, like from the beginning or from the end. Let's not consider this at the moment. You can just look up at the documentation for this. Let's just provide the offset to be 0. So now let us try to print where is the pointer. And let's try to run the program. So you see that it moved to the position 0. So f.seek 0 will basically move the file pointer to position 0. And we see that we get the entire first line, right? So does that make sense to everyone? So also now let's say we want to read the next line. So our file pointer after f.read line would have moved to the next line. So let's try to print that. So you see that it is at the 24th character. So now if we again do f.read line, it will print us the next line. So let's try to see. You see that okay, let's try again. The thing here is the second line contains just this end line character. So if we have to do it once again, then we will get the next to next line. That is what we require. That is, this is line number 2. So basically every end line is counted as a single line. So what actually will be stored here would be a single end line character, right? So that's why the next time you see an end line character, let's just remove these end lines and try to do it again. So now you will see that you get all the 3 lines, right? So also one thing you notice is there is one extra end line coming here. So that is because this f dot read line in itself contains an end line character, and this print additionally prints one more end line character. So to remove this, what we can say is we can use the space as a separator, or let's just use nothing. So this is not a space, this is just a blank character, right? So if you will observe now, you will get whatever you had in the file. You will get all these 3 lines, right? And these are the file pointers. Let's just comment them, right? So you see that, let's also comment this part. You see that whatever was in the file, we have read that entirely, right? So if let's say I give one more end line here, then you will observe we will get one more end line, right? So I hope this makes sense to everyone now. Any doubts? So I'm taking up any doubts you have till this point about reading from the file. So if reading is clear, then we will move to writing to a file. So anyone has any doubts till this point? Okay, let's assume there is no doubt. One more thing, since I did not get anything, let's just see that there is one more function that will give us all the lines in the file. So let's just comment everything. So there is a function that is f dot read lines. So let's say we want to get all the lines. So we can simply say f dot read lines, and let's just try to print the lines. So yeah, Dhruv, f is the file object that you are using. So basically f is the file object. Yeah, f dot tell we will use once again, right? First, let's just see that the f dot read lines function will basically give us all the lines that we have as a list. So you see it is giving you a list of lines, and in each line you can see that there is an end line character, right? So Rohit, I'm not answering that question right now, how to reach the end of the file. You can explore it once. So let's just go to f dot tell once again. Yeah, so let's now try to call f dot read line. So that is a good question. Gyapa Shravan is asking, what if we do f dot read line at the end? So let's just see. So you see that we will just get blank line. So let's just see. Try to do it multiple times. You see that we'll just keep on getting a blank line. So no, f dot read lines will basically read all the lines. F dot read lines will read all the lines. So basically f dot seek function will be used to get to the starting, and then if we do f dot read line, it will give us the first line. You see there is some text here, right? We get the first line. Now f dot tell function will basically print what is the current position of the file head where we are using to read. So f dot tell will tell the position for the file head. You can see it is at character 24. So if you count, there are 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 23 characters in total, and one will be the end line character. So that's why this character T is at 24th index. We are using zero based indexing, right? So does all of your doubts are cleared now? Yes, Keshav, you can try to think how you will do that. Okay, so let's now continue. So we now know how to read from a file. One more thing before we go to writing. So you can also loop at, so let's first go to the 0th position. You can simply loop at this file object. So we can say for line in F, print line. So this F object, when you loop over, it will iterate over each of these lines. So let's just comment the entire code. You see that it simply loops over every line. So you can simply do this if you want to loop over the lines, right? Does that make sense? Okay. There is no attendance link. Like for the certificate availability, you will have to give a test that will happen after the end of the series. We'll share the details in the end session. So Richa, you need not worry about that. Okay. So let's continue. So let's now think about how we will be writing to a file. So once we have discussed about reading to a file, now let's go back and see how we will write to a file. Okay. So let's just open another file. One more thing. So let us say we try to open a file. Let's just 1 second. So let us say that f is equal to open demo write.txt. We are opening this, so now we have to open this in a write mode, that we can say using the W keyword. So let's now try to run this program and see if anything happens. So you see that this file does not exist. So this file named as demo or write.txt does not exist in our page. So let's try to run this python 3 file1.py. So this file does not exist. So what happened is this file got created. So you can see demo write.txt file got created, right? So did you observe this thing? Okay, let me take up a few questions. So Ravi, it is giving a new line because there is a new line in the line itself, and one new line is for the print statement itself. That is why. Yes, Dhruv, you are exactly correct. These two things are for the same purpose. Saurabh, I do not know about the shortcut that you are asking. Ravi, you can try that thing once and let me know what happens. Okay. So let's now try to see the file got created. So basically, if file does not exist, it got created. So let's just do one more thing. So, and one more thing is, like, basically once you open a file, it is a good practice that you close the file at the end. So because what happens is the resources are being allocated that will be working on that file. So you need to use the f.close function that will basically close this file, right? So let's now try to see if we have something in this demo write.txt. So hello, this is a demo line, demo write file. So now let's see if we run this code. So what do you think will happen? Will the file contents be overwritten, or what do you think would happen? Let's now try. So if you open this file demo write.txt, you will see that whatever was there got erased. So this write mode simply opens this file in the write mode, and if file exists, it basically clears the content. Exists, then basically it overwrites the content. Right? Does that make sense? Okay, so Dyapa is asking, what if I will print the character F? So let's just see what happens. Let's just see. So you see that it is a file object. So see that it is a text io.text.io wrapper, mode is W, encoding is UTF-8. So this is the file name. So you see all the attributes associated with this file, right? I hope that answers the question. Okay, so let's now not take any further questions. So we'll take, so just I'll take the questions after some time, right? Okay. I've already answered that question. The certificates will be provided, and like you will have to attempt a test for that. Okay. So now what we want to do is we want to write something to this file. So again, we have a function f.write, and let's say it takes in any string as the input. So let's say this is line 1, and let's again say f.write. This is line 2. Let's just copy this. I'll use the shortcut, and let's say 3, 4, 5, 6, right? So let's try to run this program and see what happens. Sorry, file1.py. So if you will go to this file, let's open the file demo write.txt. You see that everything got written without any end line. So all of this has been written in a single line. So just make sure you understand this thing. So we have to give the end line character by ourselves. So we have to say that here we need to say that \n character by ourselves, right? So let's now try to run this. So if you will see now, you will see that all the lines are basically written in a separate line. So that is because we have provided this \n character, right? Ravi is asking if I want to write integers like 1, 2, 3, 4, etc. in the file, can I write using .write or only string is allowed? Yeah, so basically it will allow only string. So let us say you have some integer. Let's say you have x equal to 1. You try to say f dot write x. So that will not work. So you will see that type error, write must be a string. Write must have the arguments as string. So what you can say is you can simply typecast this to a string, right? So let's try to run this now. So you will see that you will get the string character 1, right? So you have to convert whatever you are writing to the file to a string, right? So now that we know about how to read and write files, now let's also see, we also know that how to close the file. So this is basically required. Why? Because you want to free up the resources. So what there is a garbage collector in Python inbuilt. So but the issue is that will be doing its operations based on some interval of time that is like dependent on the platform and like dependent on some other factors, right? So it's better to be safe that you close the resource. Otherwise, if it's left open, there might be some corruption in your file. So just make sure whenever you open a file, after you are done with the operations, you just close the file. So the 3 steps that you have to follow are: first, open the file; second is perform read write; and third is close the file. So I hope everything is clear till this point. Now let's just see one interesting thing. So let's try to open a file which does not exist. So let's try to do this thing. So let's say I say f is equal to open. I say hello2.txt and I try to open it in read mode. So if we already saw it in the write mode, it will get created. Let's now open it in read mode. So let's see what happens. So you will see that no such file or directory hello2.txt. So now to handle such cases where you get exceptions during the runtime. So this is basically known as an exception. So the errors which you get during the runtime are known as exceptions. So you need to make sure that your code is handling these exceptions. So we have some kind of exception handling mechanism. So what we can do is we can have a try block. So inside this, we will try to open this file. So exception handling is basically trying to catch the errors which can happen on runtime, right? So now once we try this thing, so there is an except block as well. So here basically you will handle the exception. So here you will have the whatever you are writing, the instructions to be executed, and here you will basically in the except block basically you will catch these errors. So let us say that print some error occurred, right? So let's now try to see what happens. So you see that whenever we went to the first, the program flow is it will go into the try block. It will try to open this file, but there will be some exception occurring, right? And then it will go to the except block. So let us say that we are trying to open this hello.txt, which already exists. So you see that no exception will be occurring. So this code will not go to the except block. And now finally, there is one more block you can have, that is the finally block. So here you can say that this will be executed in all times. So here you can simply say f.close. So if the file was opened, you can simply close this. But you should simply check if f exists. So if f is existing, so let's say if f is not equal to none, then we can say f.close, right? So now let's also try to print here, print that file is closed. So you will see that file is closed. Let's now try to do the same thing with hello2.txt. So you will see that here also some error occurred and still the file is closed. Why? Because let's try to print what is in f. So you will see that it okay, I think that the previous resource was not closed. Let's try to comment this thing and try to run this piece of code. So we are trying to run only the line from 70 to 80. I'll take up the questions in a few minutes. So you see that f is not defined. So let's now try to see. Okay, f is not defined basically here. So let's not do this finally block in this case. We should do it only when this was open, right? F is not defined. So I leave it up to you to think about this part, how you will handle this case, right? So what we generally do is, we, instead of writing these things like try, except, and finally f dot close. So once again, let me just take up the questions before continuing. So here we have taken up, let me just take up some questions. So, okay, attendance and assignments. So we don't have any assignments. Can we read the text from image using Python? Just try to research on this. That is a good question. Overwrite happens if the file is already existing and we are trying to write. So using the write mode, and we are trying to open it in write mode. So try basically is a block where we will write some instructions that will get executed. And in the except block, you can just catch the errors. So like, let's say that you do not have anything like this, and you try to open hello2.txt. So you will get some, okay, we cannot have simply the try block. We need to have the except block as well. So you will see that file not found error. So you got some error during the runtime. So to handle that case, there are exceptions, right? Rohit, you can just try to think about that. Okay. So now that we are clear with some of these things, so we want to make this thing. So f dot clause is working if, so f is defined, right? Here f is defined, then only f dot clause is working. So let's say we have try, we have except, print some error occurred, and then we will say finally f dot close. Let's do one smart thing here. Let's say we have one variable error occurred equal to 0. So we can simply set it to 1. So if not error occurred, then only we will close the file, right? So that is how you can handle this case, right? Okay, sorry, we need to say if not error occurred. Yeah, so now you can see that some error occurred because hello2.txt does not exist. Also, our code will not go inside this closing file because f is not existing, right? And not error occurred is set to 1. So let's say if we read this file hello.txt, then it will be closing this file, right? So I hope you get this idea. Let me take two more questions before we continue. Pavan, you can try exploring that thing. F dot close is working. Basically, f is defined in this case. So hello.txt is basically existing, right? So if I see that hello.txt file exists, right? Will we get error if file doesn't exist and we open the file in write mode? So Technoram, we have considered that case earlier. So basically that file will be overridden. A new file will be created in that case. Okay. So now to handle all these cases, what we have is, we have something known as a context manager in Python. So let me just tell you that part. Okay. So basically, to make our code cleaner and to not handle these things manually, so there is something known as a context manager. So that allows us to manage the resources effectively. So basically allows us to manage using and closing of the resources effectively. So basically, let's say how we want to open a file. Let's say if we forget closing the file, right? That might create some issues. So for that purpose, you have the context manager. So you can say that with keyword is used to use the context manager with open hello.txt in the read mode, and let's say as the file keyword, let's say f, we are opening it in the read mode, right? So now we can simply perform the operation. So let's just say print f dot read lines. So in this case, you need not basically handle this scenario of closing this file. So let's just try to print the what is the f object storing outside of this. So you will see that it stores this thing, but the Python will handle this, the context manager will handle this thing for us, that it will close this file as soon as the operations have been done, right? So you see that it is an effective way of working with files. Just make sure that you use this context manager so that you will not have to worry about this try, except, and finally kind of blocks, right? Okay. So now I think we are done with the first part of working with text files. So if you want to work with binary files, so then you can use the mod F, work with binary files. You can use the mod E as well. So let's say you want to open a file in the read mode, open a binary file in read mode. So how will you do that thing? So you can simply say with open hello.txt, hello, let's say some binary file. And let's say we can simply append the modes that we are using. So if we have more than one mode, so we can simply write them like this. So RB simply stands for read mode and binary file as F, right? So here you can see that, here you can say f.read, something like this, right? Okay, so you can try exploring more about binary files and about this context manager through the official Python documentation. So just Google it, you will get the official Python documentation. Just try to explore more about these things. So now let's come to working with CSV files. Just taking some questions and coming to working with CSV files. Dhruv, try to see what will happen. And Shravan also try to think. So Rohit, the with keyword with operator is simply used to open the file using the context manager. So the context manager is some internal thing in Python that handles opening and closing of the resources. So it will automatically close this file for us whenever we are done with working with the file. It will see the suitable time when it should close the file, right? So it will make sure that we do not get into any trouble. I have just now explained the context manager again. Just try to explore more about this, right? That would give you more idea. Okay. So let's now go with working with CSV files. Okay. So now we will simply see how do we work with CSV files. So a CSV file is something like this. So let me just create a file. Let's say, so basically let's create a file here, demo csv.csv. So it simply looks something like this. So let's say we have we want to create a file that will store the name, serial number, roll number, name, and the marks of a student. So let's say we will have some keyword, first row as roll number, and let's say name, and then the marks. Let's say 1 ABC, and let's say 1 and 97. We say 2 DEF, and let us say 99. So this is a CSV file. So Pawan, we will not be able to use a CSV, use a file after it has been closed by the context manager. Just try to explore more on this part, right? Okay, let me take that question. So Deepika is asking, what is the difference between read and read line? So the read function is basically used to read the entire content of the file. Read line is used to read a single line at a time. So a CSV file is what I'm talking about currently. Okay. So it simply stores basically the full form of CSV is comma separated values. So as you can see, there are some elements here which are separated by comma. So this is basically a CSV file. Okay. And it is generally used where we are working with spreadsheets. So if we are working with spreadsheets, let's say if you have used Google Sheets, so you can export that file in a CSV format, right? So it basically allows us to create, let's say, store some data in a structured manner. So there are some columns here. The columns are roll number, name, and marks, and the rows are basically the entries. So it is a tabular data. If you can see, it is a tabular data, right? So CSV is basically used to work with tabular data, right? So now we can use the open keyword and open this CSV file, but now you have to do some processing, right? So let us say we open this in the read mode, right? So let's say with open as f, and let's just try to print f.read. So if you try to run this python 3 file2.py, so you will get all the data in this file. But let's say we want entry by entry, so we want the first entry, right? Or let us say we want to convert it to a dictionary where we can access the roll number, name, or marks using the keys. So the CSV library is there that will basically make all these things easier for us. So what we can do is we can simply import the CSV module that already exists in Python. That will make most of the things easier for us. So now what we can see what we can say is, we will create a reader here. So we can simply say reader is, reader is CSV dot reader. So this will return a reader object that we can use. Sorry, here we have to pass the file also. So the syntax is the CSV module name, and we are using the reader function of this module that takes in the CSV file and the dialect. So dialect is something you can explore, not something very important right now. And then some additional parameters that are optional. So after this, you can simply work on every row in this reader. So for row in reader, you can simply print the row, right? Let's now try to see what is the output here. So you will see that we can get every row in the form of a list. So the list will basically store the entries column wise, right? You get the first column, comma, second column, likewise. So it becomes easier to operate on the CSV file. So let us say that you want to get the name of all the students. So you can simply say that print row of 1. So now you will get the names of all the students that are A, B, C, and D, F. Let's say you want the marks. So you can simply say row of 2, because you know it is the second column, right? Yeah, it is like an Excel file, right? Exactly. So that's how like you can read from a CSV file. Now let us say that, let's try to see if, let's say, our CSV file had some spaces here after every comma. Let us say there were spaces, and we try to do the same thing. So now if you see, we will get some extra spaces here as well. So you see, you are getting these extra spaces here as well, right? So what you can do is, there is an optional argument that you can specify here, right? You can specify here an argument that is skip initial space is equal to true. So now let us try to see. So now you see that you will not get any space here, right? So there are a lot of things that this CSV module will make very easier for us. So let's say like if your CSV had quotations around some of the elements, so then also there is some quoting parameter that you can specify. So I leave that to you to explore, right? So that's how you read the file. Now one thing is, like, let's say we are specifying this parameter. Let's say there were some multiple parameters that we had. So now this dialect solves that problem for us. So basically just try exploring onto that. I have written about this thing in the notes. Try exploring on this dialect. Yes, so we are getting the header also. So just try to see. So we can simply skip the first row. So Pawan has a good question. Just try, we can skip the first row. Just try exploring more on that part, how you can use the CSV module to skip the header part, right? So now we know how to read from CSV files. Next, let's now also see how to write to a CSV file. So it will be very similar. So like we are creating a reader object, here we'll be creating a writer object, right? And we will be passing the list to that. So let us say that again, I want to open a marks.csv file, and we will be opening this in the read mode, in the write mode, because we are writing to a CSV file as file. So I'll take up questions at the end. Let's now see. We will create a writer object this time. Writer is csv.writer, and we pass in the file object, right? And then we can simply say writer dot okay, writer dot write row, and simply we will pass in what is the row here. So we will pass in it will be a list. So the list contains roll number, name, and then the marks keyword. So there are 3 columns here, and then we can simply say that writer dot write row. So here we will specify the roll number, that is 1, the name, that is ABC, and then the marks. Let us say marks will be an integer, so 97. Then again we can say writer dot write row. We specify the list for the second entry, right? So here we can say 2 and DEF, and let us say that 98. So now this will simply write down all these 3 rows to our CSV file. Let's now try to do this Python 3 file2.py. So if you will see that, a marks.csv file has been created. So that contains all these 3 entries, right? So I hope you have got a basic idea how we can operate with CSV files. You can try exploring some of the operations and go through the official documentation of CSV module, right? So that will make more sense, right? So similarly, there is one thing you can explore, how to get this, the content in a dictionary. So there is a dict reader keyword as well. So you can simply say here is dot dict reader. So just let's try to see now. Now, if you will see, we will get dictionaries instead of lists, right? So let's say you want to print the roll number for every entry. So you can simply say that. Now one thing if you notice is you did not get the header row. So Pawan, now you are getting only the entries. So you can simply say row of roll number. So you see that the roll numbers are 1 and 2. Similarly, if you want the names only, you can say this thing. So you get ABC and DEF, right? So now I think you have got enough idea. So basically why we are doing this thing is because reading and writing CSV files is common thing when you will use, let's say you were to automate the report generation. Let's say you have some particular analytics module, right? There you have some data that you want to extract to CSV file. So you can write a simple script that will automate these things. So it will automate the reading and writing part to a CSV file, right? Let's say you have a big database and you want to generate CSV files using script, or you want to manipulate and work on the data. So you can have these small Python scripts that will work on the data, right? Which is stored in the CSV file, right? Okay, so there is one additional library that you can explore. So there is a pandas library that we use very often in data analysis and data manipulation. Just try exploring on this. There are a lot of good official documentation. You just go through that. You will see that we can do a lot of things more easier, right? We can do a lot of analysis very easier. We can generate graphs as well, graphs, charts, and a lot of things. So let's say you wanted to find out how many students, or basically you want to group the students, group the marks in basis of grades. So you can use the some of the things that pandas provides, right? Okay, so any doubts till this point? Okay, so I might have missed out on some questions. Let's now continue. I think those were answered. Okay, so now there are 2 things like here you have to explore. One is the dialect keyword and one is the pandas library. Now let's start with working with JSON files. So we are done with 2 parts of our today's session, that is working with text files and CSV files. So now we will look at working with JSON files. So what JSON is basically, this is a very popular format. It stands for JavaScript Object Notation. So it is a very popular information interchange format that we use frequently. So when working with APIs, so if you have heard about the terms, so that just don't be overwhelmed if you haven't heard. So APIs are there that are application platform. So you can just explore more about APIs. And whenever we generally fetch data from APIs, so we generally do it like the response basically is a JSON format, right? So we need some kind of mechanism to work with JSON files effectively. So how does a JSON simply look like? So it basically looks very similar to the Python dictionaries you have. So there is a key and value pairs that you have, key and value pairs, right? So let's just try to see how a JSON file might look like. So I'll just show you. Just give me 1 second. So I'm pasting one link here, like you can also see it. This is basically providing a list of to-dos. So this is a basically this URL, if you go, it gives you a JSON response that is basically a list of to-dos. So tomorrow, if you see, tomorrow we'll be working on creating a to-do application using command line interface. So we will be working with JSON there as well. So just make sure you explore more about it. I have just given you a basic idea what JSON is. So it is basically very similar to Python dictionaries. So let me just copy the part here. So this will be simply a JSON here that has the key as user ID, title, and completed as true or false. So this is how a JSON might look like, very similar to Python dictionaries. So you have key and value pairs. And like here you can have lists as well, right? So you can have a list as well. So this entire thing would then be again like this is also a JSON format where you have a list of small to-dos, right? So let's say here it is 2 and 2, right? So there is a mapping between Python objects and JSON entities. So Python objects and JSON entities, you can basically have some kind of mapping. So like in JSON, so a list in the Python is basically a array in JSON. So whatever you see here is a array. So it is an array of to-dos. So a list in Python is array in JSON, right? So you can just see more about this. What is the mapping between different things? So let's try to basically have this thing in our JSON file. So let's create a simple JSON file. Let us say I create a file to-dos JSON.json. Let's open this file to-dos JSON.json and let's paste this JSON that we have here. Let me say here task 1. Let's say task 1 and let's say task 2. So we want to read this file and store this in a dictionary, right? So we want to extract this information and store this in a dictionary, right? Yes, you are right, Ravi. It is an object. So a dictionary in Python is an object in JSON. So let me just confirm as well. So what is our goal here is now we want to read this JSON file and we want to create a list. Like since this is a list, we want to basically, let's say we want to find out how many tasks in our list are completed, etc. So we will have to effectively parse this data. So there are two operations. One is serialization and one is deserialization. So serialization is the process of converting Python object to a JSON string. And simply deserialization is the process of converting a JSON string to a Python object, right? So in different languages, you must have come across, like if you have worked with APIs, you must have come across these two terms. So when we will read a JSON file, we will be doing what we call as deserialization. And when we will be doing the serialization, that time we will be writing to a JSON file. So here we will be doing a write operation. Does that make sense to everyone? Here we will be doing a read operation, right? So basically a dict maps to an object, a list maps to an array, list or a tuple, both of them map to an array. And a string basically maps to a string. str is what we have in Python. In JSON we have string, and int, long, float, all these kinds of numbers map to number in JSON. True maps to true. The in Boolean things, only the first character is small. False maps to false, and none maps to null in case of JSON. So this is the kind of mapping we have from Python to JSON, right? I hope that makes sense. So now let us try to open this file, right? So any doubts till this point? Let me take up some doubts. JSON files will have JSON objects and JSON arrays, right, Ravi? Right. So everything in the JSON file is a JSON string. Any doubts till this point to anyone? So the serialized data, Pavan is asking, will the serialized data be a JSON string or a binary data? So the serialized data will be a JSON string, right? It will not be a binary data. We serialize and deserialize because we want to get the data in our Python code, right? So we will have to basically access it. So let's say we want to access the information. Let's say we want to access how many of the tasks are completed. So we want to parse this data. So for that we need to deserialize, that is convert it to Python object. So the Python object here would be a list, right? And this list will be having a dictionary. So it will be getting converted to a list of dictionary in Python. Whatever you see above will be converted to a list of dictionary, right? Does that make sense? Vishnu, we have only integers floating point. Just okay, let me just not write here long. Intent float. That makes sense, right? So Python has objects, right? Dhruv, there are objects. There is a list object. There is a dictionary object. There is a floating point or number object. There is a Boolean object, right? So we'll be mapping the object to the JSON entity, right? We are mapping the objects. Okay, let's now go into the actual action of doing the serialization, deserialization. Yes, Ravi, you are right. Whatever you have said is correct. Okay, let's continue now. So first of all, what we will do is we will have to import the JSON library, right? So we import the JSON library, and then what we'll do is we will use the context manager with open todos underscore json.json. We'll open this in the read mode as file. So now what we will say is data is json.load of this file. So it is very similar how we read the CSV files. So there it was a reader function. Here we have a load function that will take the file object. And let's just try to print the data. So you will see what happens next. So let's say Python 3 file3.py. So what you see is we get a list, right? If we just try to print the type of this data, you will see that it is simply a list, right? Class list. And let's say we access the first element, so that will be a dictionary. So first element is simply a dictionary. Let's try to print what is the first element, data of 0. So that is simply user ID, title. So you see this dictionary with key value pairs is returned to us. So that is how you can simply deserialize the data. So you see deserializes supporting file type object containing a JSON to a Python object. So this function is simply, load function is simply deserializing the JSON data, right? And mapping it to the Python object, right? So that's how we simply do this thing. There is a similar function that is json.load s of file, of string. Here you will pass the string, not the file. So you can basically deserialize from the string as well. So you see that loads function deserializes a string, bytes or byte array to a Python object. So this you can try exploring your own. Okay, so now that we have seen how to read the data, let's now try to see how we can write to a Python file. Sorry, write to a JSON file, not a Python file. So if similarly, we will open the file, let's say with open, let's say we have let's say marks.json. We want to have marks JSON file. We are opening it in write mode and as the file object. So now what we have to see is we have to create a dictionary. Let's say we will be writing a dictionary to a JSON file. So I create a marks dictionary, and it is always better if you write a dictionary in Python using this like moving to the next line. So whatever keys and values you have, just write one key value pair in a single line. So just say that, let's say roll number is 12, and let us say that the name is simply ABC, and the marks are, let's say, 99. So this is the marks dictionary, and we'll be writing this to our JSON file. So we will simply say, now similar to the load function, we have a function that we call as dump function. So we can simply say json.dump, and here you see that we'll pass the object. The object here is a dictionary. So let's say marks of the marks dictionary, and we will also have to pass the file. So that is the file object. So now let's try to run this code. So if you try to run this code, you will see that a file marks.json would have been created. Sorry, a marks.json. Now here you see that we are getting this dictionary or this JSON string that we wanted, right? So a dictionary maps to a object in JSON, right? So we get this JSON object, right? So that's how we can simply read and write to a JSON file. Now, one thing is, let's say you want to write this thing in a more cleaner way. So there are some optional parameters. You can simply say indent is equal to true. So there is one parameter, indent is equal to true. Let's see what that does. So now if you see marks.json, so you see that it has been well indented, right? So if you want to write to the file in a more cleaner way, so this is basically we are trying to pretty print the JSON file, right? There is one more parameter that we can say, that will be sort keys is true. This sort keys will simply make these keys in a sorted manner. So let's just try to run this. So if you see, you will get marks, name, roll number. So all the three keys have been now sorted in a lexicographical order, right? So you can try exploring more such optional parameters. But this is the basic idea of reading from a JSON file and writing to a JSON file. Similarly, you can write to a string. So for that purpose, you can simply say that json.dump s, and here you will have marks dictionary. So let's try to see this also. So let's just print what will be json.dump s of marks dictionary. So you see that you get this dictionary. So you get this string. So this dictionary was converted to a string now. So if you see the documentation of dump s, it serializes object to a JSON formatted string. Here also we can pass an indent is equal to true and sort keys is equal to true. So then you see that it will be pretty printed, right? So you get the output in a cleaner way, right? So I hope now you can operate with JSON files very easily, right? Ravi is asking a good question. Can I sort based on the values? Just try exploring on that file. Why we use files? We use files because we try to operate on large chunks of data, right? We want to store the data in some kind of non-volatile memory, right? So if you see, the databases also ultimately are storing whatever is there in the database in some kind of files, right? But that basically use some data structures like B trees and D plus trees. So let's not get into that, right? So any doubts till this point? So we serialize JSON to string. So we say, serialize the Python object to the JSON string and deserialize the JSON string to the Python object. I hope that answers the question, Shravan. Anyone else has any doubts? Okay. So one last thing before we end the session. So we will just see how we can work with a API and get the response. Okay. So there is one library that is known as requests library. So that allows us to work with APIs. So APIs is something you should try to explore once on your own. Let's say that there is this URL from where we will get the response. So if you try opening this URL in your browser, you will get a list that is a JSON list, right? So now we want to get that here. So we can simply say response is equal to requests dot get at this URL. So we will get the data that is present at this endpoint and store it in the response variable. And then we try to read this. So we can simply say here to-dos is equal to JSON.load s. So now response is simply a string. So we want to deserialize the string to a Python object. So we simply say response.text. So whatever is the text of this response, that will be a string, and we will simply convert it to a Python object, right? So now let's try to print the type of to-dos. So if you see here, it will take some time because it is fetching the data. So it will be simply a class of list, right? So now let's say I want to print the first 5 to-dos. So I can simply say print to-dos colon 5. So it will print from 0 to 4 based indexing. So we are slicing the list of to-dos, right? So because to-dos was a list object, it will take some time. Not sure why it is taking a time. Let's just once try to print the first to-do only. Okay. Or what I can do is I can just store this response in a text file. So let's store this response in to-dos JSON. So I have stored the entire response in to-dos JSON. So now what I will be doing is instead of fitting to this URL, so this is something you can explore once on your own. Okay. So let us simply do this thing with open to-dos JSON.json in the read mode as file. We will simply say that load the to-dos. Now just the thing that will change is here we will load from the file. So we can say to-dos.load. Instead of load s, we will use load function. And here we will pass the file object, right? And now let's try to print the first to-do. So now you see that the first to-do got printed. So let us say now we want to find out how many to-dos are completed. So we can simply have a count. Let's say we have a count completed is equal to 0. So then we will simply say that for to-do in to-do, since this is a list, and then inside we have a dictionary. So if to-do of completed, so here we have a dictionary which will have a completed key equals to true. Then we can simply say that increase the count completed. And at the end, we can simply print the count that is completed, right? So you see that out of the total to-dos, let's also print how many we have, print length of to-dos. So out of 200 to-dos in this file, 90 of them have been completed. So you see how powerful file handling is. So like we can operate on a large chunk of data very easily, right? We can also do any other kind of processing that we need from this data, right? This to-dos JSON. So I hope now you can write down small programs that will be reading from either text files, CSV files, or JSON files, and writing to these kind of files and doing some basic manipulation, right? So that is it basically. I am done with the part that we had to cover, done with the agenda for today. Now there are some things that you have to explore. So there are some files. Let us say you want to work with zip files. Let us say you want to work with OS path. You want to work with moving or renaming files, etc., etc. So there are some libraries that you can explore. So let me just name them for you. Let me just do one thing. Let me share the screen. So let me just share a different screen. Okay, so I hope you can see this lectures 5 notes file. Yeah, Pooja is asking, instead of to-dos, can we take any other variable? Yes, we can do that. That is just a placeholder to store that particular thing, particular object of list that we have. So if you can see this, so you can access the notes for today's session over here. And if you found this repository helpful, you can also star this repository. If you can see that at the top, you have this star and watch. So just star and watch the repository so that you can keep getting updates from this repository, right? So in the end, we have mentioned similar things. So you can just explore some of these libraries like pathlib, os.path, shutil, and like if you want to write Python objects to disk. So currently we have seen writing Python objects to files like CSV and JSON. So if you want to write them to disk, so there is a library pickle. So just try to explore that library as well. So if you go to this Python documentation, let's say you want to see your current path, or like you want to print the absolute path, so you can simply say import os and os.path.absolute path. Let's try to do import os, and let's just try to print os.path. Let's see what happens. Okay, so os.path is again a module. So os.path.current directory. So this will give us the current working directory. You see, it will print dot is the current working directory. And let's just try to pass in some file, current directory of, let's say, or let's just try to see if there is a, okay, absolute path. Let's just try to print the absolute path for the dot directory. So you see that it will give us the absolute path, return a absolutized version of the path name path. So you see that it gives me the entire path till the current directory, right? So just try exploring these libraries, os.path. If you want to move the files, copy the files, if you want to have, let's say, rename the files, so you can just try exploring these libraries. Pickle is about Python object serialization. And we also have some other libraries, data compression. So let's say you want to work with zip files. So if you want to open zip file, extract zip files from a Python script, that also you can do. So try to explore all these different libraries that are mentioned over here. So then you will be able to become more proficient working with the file handling, right? Okay. Okay, sorry, the console is not visible. Let me share the console. So basically what I did here was, yeah, what I did here was, one second. I just imported the OS module and just I tried to print os.path dot. So we can just try to print the current working directory. So you see that it will print the current directory. That is, okay, sorry. It is a string. It is not a function. It is just a string object. So you see it prints dot. And let's say we want to get the absolute path. So this abs path will basically return the absolute version of a path. So here, let's say, let's go get the absolute path for dot. So it will print the entire path for this, right? So that is how, like, just try exploring these libraries. Just try exploring the OS libraries, path library, shutil, pickle, all these kind of libraries, right? So you can see them in the Python repository, Scalar Academy /intro to Python, right? So you can just see it over here. Just start this repository, watch this repository. You can just keep getting updates directly, right? Okay, so that is it. Any other doubts do you have? That is it for today's session. If we recap, we covered working with text files, working with CSV files, JSON files, and also the next steps, right? Okay, any doubts now? So Ravi is asking, just before we end, let's take one more question. What is the way to explore all the libraries? Just go to the official documentation that we have linked in this lecture notes. Just go to the documentation and try to read. Just see any function that you want to use and just try to explore, right? Great. So see you tomorrow then. In tomorrow's session, we will be learning, or basically tomorrow's session will be applying the concepts that we have learned today. So basically in tomorrow's session, we will be learning applying the concepts that we have learned till now. We'll be creating a to-do application in command line. So that will be working in command line. So that is it for today. See you tomorrow, everyone, then. And head on to the Instagram page and start answering the quiz right away. So see you tomorrow. Bye. So today's agenda is basically we will be creating a to-do application as we had discussed yesterday. So today we will be applying all the concepts that we have learned till now. Completely, we will be applying all the things we have learned, starting from the flow control, loops, and file handling, and even structuring our code into separate files. So we'll be building a complete application that we will be using in our command line. So just to give you an overview, we will be creating a to-do application where you can create some to-do lists, and in those to-do lists you can have some to-dos that you can mark as complete or incomplete. So once we get started, it will be more clear. Okay, so let's get started. Yesterday's class was there. It was on file handling, and you can see the link in the videos section of Scalar Academy channel. Okay, let's start. So basically what we want to achieve, first let's write down some things. Let's create a file. Let's say readme.md. So I have created a file here where I'll be listing down all the requirements that we will be needing. So in this to-do CLI application, let me first structure our today's session. So how we are going to basically go about creating this small to-do application. So first of all, we will be finalizing the use cases and like how we'll be running our application. So what will be the final commands that will be running in the command line, right? Then we will be basically structuring our code into separate files, and then finally we will start the implementation, and then we will be doing the implementation along with testing, and finally we will be able to run our application, run and use it. So that is how the total flow will look like for creating this to-do application. CLI stands for command line interface. So we will be able to run our application right here in the command line. So what we want is we want to create some to-do lists, and inside each of the list we will be having some to-dos, and those we can see, we can add, update, delete, or we can mark them as complete, right? So you can use this application to track the to-dos that you have, right? So it will be a great learning experience. Let's get started. So any doubts till this point? So the structure of our today's session will be first of all clearing the functionalities we need in our application. So we will be able to figure out what all commands we'll be able to use at the end, and then we will be starting with the structuring of code and finally the implementation, right? So does that make sense to everyone? Okay, fine. So now let's look at what all are the use cases. So basically what we want. So let's write down the use cases. So we want that we should be able to create a, Ravi is asking to-dos in the sense that it is tasks to be done. Exactly. To-dos means the tasks we have to do. So we'll be able to create and update, retrieve all the things. We'll be able to do all the things through command line. So we'll be having a end-to-end application which we can use. Sounds great, right? So we'll be able to create a to-do list. So what all we want from application? To create a to-do list, right? And basically to show all the to-do lists that we have. And then we should be able to add, edit, delete, mark as complete, incomplete, etc. Right? The to-do items present in those lists. So basically you want to have multiple lists, and in each list there will be some to-do items, right? So let's say you have one list for your academics, one list for your projects, etc., etc., right? So you want to be able to create multiple lists and add to-do items in those particular lists, right? So you also want to show all the to-do items in a particular list, right? So these are the four basic functionalities that you will kind of need, right? You can add any extra functionalities that you can think of later. So we will start with these four functionalities, and we will try to see how we can implement on top of it any extra requirement that we get, right? Does that make sense to everyone? So now let us also see what will be the commands that we'll be using. So the commands to basically use our application. So if we are clear with how we will be using our application, it will become more easier for us to write the code, right? So commands to use the CLI application. So Priyansh, we are using Python. So we'll be creating this application end to end in Python. So this is an introduction to Python series, and that is why we are building this thing in Python. In the next week, you will do the same thing using the Django framework in Python. Does that make sense? Let's continue. So the first command that we will kind of need will be to have some list. So let's say we will use two prefixes. So we'll have some prefixes for the commands that are basically list and to do. So for some particular list, we will use the prefix list, and for the commands to do, for adding, updating, deleting the to dos, we'll use the prefix to do. It will be more clear once we see this thing. So this part we are not going to deploy. This will be a command line application. We will be able to use it directly in our CLI. The deployment part we will see for the Django application we will build in the next week. Hope that makes sense. So we will be able to show all the lists that are available. List show. So this command will basically show all the to-do lists that we have, right? Then we will have a command to create a list. So list create the list name. So this will basically create a list with the given name, that is list name, right? Then we will have a command to basically use a particular list. So we will be adding to-do items in a particular list. So we should be able to use that particular list. So we can say that list use and the list name, right? So this will basically select a particular to-do list. Then we will have the commands for to-do part. So we should be able to add a particular to-do. So to-do add in the to-do title, right? Then we should be able to see all the to-dos. So let's use to-do all to basically show all to-dos in the selected list. This will be to-do add to-do title will be used to add a to-do item in the list, right? Just ask any questions you have right away. So we should be able to take up questions at that instant only. Okay. Yeah, Vishnu is asking what is to do here. To do is basically a task that is to be done. Is basically a task that is to be done. So it could be like, it could be something like example basically learn loops in Python, right? So this might be a to do, right? Example could be watch the previous lecture again, right? So you can have some tasks that you have to complete. That is basically termed as a to do, and a list will be a collection of to dos. So a list is simply a collection of to dos. Does that make sense now? So you can group your to dos in some particular lists. So let us say you are studying 5 academic courses in the current semester. So then you can have one to do list for each of the courses, right? Then you can have some items in each of them, like prepare for the next exam, build the next project, example, etc., etc. List use list name. So Aniket, are you asking about this thing? Yes, Ujjwal, the code will be available. Vidhan, I have repeated that. Let me know if there is any doubt. Aniket, a to-do use is nothing. A list use command is there that will be used to select a particular to-do list. So let's say you have 4 lists for your 4 academic courses you are enrolled in this semester, right? Yes, so Dhruv is asking what is meant by list use. So list use, list name will basically be used to select a particular list. So let us say that you have these lists. Let's say you have some courses, course 1. For course 1, you have a list, for course 2, for course 3. Now inside course 1, you can have some multiple to-dos. It could have some to-dos which could be like, let's say, read topic A. It could be like attempt test X, example, etc. Right? Similarly, course 2 can have some to-dos. Does that make sense now? So we have to select a particular list before we start doing any to-do operations. Before we start adding, editing, deleting, or marking as complete, right? List is Ravi has a good question. So Ravi is asking list is a keyword. So basically this command we are not executing in Python. So this we will execute in our command line. So like you say Python 3 app.py. So this will run the app.py file. Now once it starts executing, we will be able to enter these commands. So consider them as some of your custom commands which you can run on top of the Python application. So these are the commands that you have created yourself. So you will actually have to parse these commands and actually run the particular function in Python file, right? Okay, Ravi got it. Anyone else has any doubts? Okay, so then also you need to have to do edit, to do remove, and let's say to do complete to mark it as complete, and then let's say to do incomplete. So now my question to you is, for all of these 4 commands, what all extra information do you need? Yes, exactly, Ravi. It is command like ls, pwd, etc. So we'll be able to run our application through the command line. We'll be giving commands right here itself. My question to everyone is, for these 4 commands, do we need any extra information? So let's say to do all will give us the ID and title of to dos. So what all should we pass in these 4 commands as well? So which to do are we editing? Which are we removing? Which one are we marking as complete? So we need some identification here. What is that thing? So what do you think should we use? Should we use the ID? Should we use the title? What do you think would be a better idea? Yes, so we need the list items, but should we use the ID or the title? Great. Most of you are saying ID. So we should use ID ideally because it will be a particular identifier. 2 to-dos might have similar names, but that is also not quite feasible, not quite realistic, right? So we can use either one of them in this scenario. So let's stick with ID at the moment. So let's say we are using the item ID, right? Let's say we are using this thing. So all of these commands will have the item ID as an additional argument, right? So till this point, anyone has any doubts? Also, we need one command that will be help command. So it will basically print all the commands we can use in our application. And one command should be there to quit our application, right? So this quit command will basically use to exit the application. So what we will be doing is we will be running our command prompt. So like you see, this command prompt appears. So if I do Python, so then, okay, let's use Python 3. So you see that this command prompt keeps on appearing. So let's say we give some command 1 plus 2, that is 3. So now again this command prompt appears. So we want something very similar. So our application should be giving us the prompt after every command and until we type quit. So in this case, we will be typing exit. Until we type quit, the application will be running, right? So does that make sense to everyone? Okay. So basically complete will basically mark the item as completed, mark the to-do item with item ID as complete. And this will, let's say, mark the, so let's say you want to track your progress. How many items, how many to-dos have you completed from the given list. You want to know that statistics. So you want to have a Boolean variable with every to-do task that you will say whether that is completed or incomplete. So this incomplete will similarly be used to mark the to-do item with item ID as incomplete, right? And this is basically used to edit the item with item ID. One more thing. So this edit isn't complete. So here we need one more thing. Here we need the new title as well. So let's say by mistake we typed some incorrect title. So after when we are doing an edit, we need something else. We need the new title as well for that particular to-do task, right? Does that make sense? And in this case, basically we will remove the item with item ID, right? So with ID equal to this, let's say. So till this point, anyone has any doubts? So we have basically figured out our requirements. So we are done with our first step. So this was basically figuring out the requirements and the uses of our application. So that is how you should basically proceed when starting with building a project from the scratch. First of all, figure out all the requirements and how the end user will be able to use your application. So let's now move to the second step, that is structuring our code. Yes, Dhyapa, I am saying that it will only edit the title. So the to-do edit item ID, new title will only edit the title, because we are just storing one information for our to-do right now, that is title. Yeah, that is the rename functionality, exactly. Yes, we will be using the list. So we will figure out now how we will basically structuring our code and how we will be implementing. So basically we also have to figure out where we will be storing our data. So here we will need to figure out a few things, where to store the data and how to manipulate the data, right? So let's think about this now. So we have listed down the commands we need for lists, for the to-dos, and some of the trivial commands, help and quit, right? Yes, we have that, Prakash, we have this. So we have to do remove item ID. Okay, that we have considered, Prakash. Great. So now how should we implement? So the thing is, we need somewhere to store our data. So right now we are not aware of the databases that we can use. We will cover that part in Django. So right now what we can do is we can have a JSON file. So yesterday we learned about how to store data in a JSON file, how to retrieve data, how to store data in a JSON file. So let's have one file for the lists that will be simply. So let us figure out where we will be storing the data. So we can have one file that will be, let's say, lists.json, right? So now it will simply store. So there are two options here, like either it stores a list of to-do lists. So basically, let's say it could be something like storing the name here. Let's say it stores list 1, it stores list 2. So it could be a list, something like this, right? Yes, Ravi has a good question. If we want to implement removing an entire list, so we need to have additional functionality. So that is what I'm saying. Let's go with these 4 use cases in the beginning. Then you can add on top of them any extra use case that you might consider, right? Yes, Ashish, we will see that part. Ashish, we will see that part, how we will be getting the ID. So that is a very good question, Ashish. We will be seeing that part. So Ashish has asked a very good question. So we will be seeing this part, how we will be extracting the ID. That is a really good question. So one approach was this, we have a list. But now the issue with this list is, so let us say we want to check whether a given list exists. So in our code, there will come a condition where we will have to check whether a given list exists or not, right? So before this command, if you see before the list use list name command, you must be sure whether that list exists or not, right? So we need to have this functionality to check whether a given list exists. So now if we are doing this in a list, we have to iterate over all elements. So using the above approach, we need to iterate over all elements. So need to iterate over all list elements. So we need to figure out a more optimal way, right? So what we can do is, instead we can store it, uh, as a dictionary of to-do lists. So store it as a dictionary of to-do lists. So it could look something like this now. So it will be having a dictionary, and each it will be a dictionary of dictionary, and to-do list is also a dictionary, and where we will store the title and the created at the time. So let's say we will also store the time at which we created that dictionary. So this also might be useful in some analysis part. So we also store the created at part. So we can remove this for time being if you say, but let's use this part as well. So we will have it as a dictionary of dictionary. Here we will have the title, and let us say here we will give the name, and then the second part of this dictionary will be the created at key, and here we will store the time instant when we created this particular list. So this is the structure we will be using to store our list.json file. So any doubts till this point? Yes, so if we store it as a dictionary, the thing that will become easier is we will be able to find whether a particular list exists in our database, or basically in our JSON file. So we just have to check. Sorry, we forgot to give a key here. The key was the title. So the title is the key, and the value is again a dictionary. So you might say that this is a bit redundant here, that we are storing title as the key, and inside that also we have the title as the key. So to handle this part, what we can have is, we can have here the file name. So the file name will store the name where we will actually store that file. So what we will do is, for every list we will store a separate file. So a separate JSON file for each list. So we'll try to segregate the files. So for every to-do list, we will have a separate JSON file. Does that make sense? So here we will store the file name, right? So now we can simply check whether a given to-do list exists by checking if the key equal to title. So if the title key exists or not, right? Okay. So the purpose of dictionary of dictionaries is, we want to store some information about each list. So basically this to-do list has some information, right? So let us say we want to know when that to-do list was created. So we can simply say, let's say this is our data. So we can simply say data of, let's say this title is simply list 1. So we can say data of list 1 of created at. So we can simply extract any kind of information. Let's say after some time you want to have some additional data here as well. Let us say you want to have some more data, like maybe you want to have used instances, like how many times you have used count. So this could be some integer, right? So let's say anytime you want to modify or add some extra data on top of it, so then it will become easier. So our JSON file, lists.json file, is basically a dictionary of dictionary. So it is having a dictionary which inside have a dictionary. So each dictionary element refers to the list item. So by a particular key, you can access the particular dictionary of that list. It will store two things at the moment: the file name and the created at time instant. Does this make sense till this point? Yes, Ujjwal has a good question. Key can be ID as well, but let us use the list name at the particular instant. Yes, Dyapa Shravan also has a good point. Why to use multiple lists? So we are just doing this as we are starting out as a beginner. So we want to segregate our code or our data into multiple files so that it becomes easier for us to visualize the things, right? So that was a good question. So let us just start with this. Now we have figured out how a to-do list will look like. So how a particular list.json file will look like. So let us say how this list1.json will look like, right? So here we will simply store a list of to-do items, right? So it would be something like a list which will have a particular item, and each item will be, let's say, a dictionary. So here we will have the information title. Let us say it is the name. We have the created at time instant. Let's say it is some time. And then we will have the completed key that will store true or false. So it could be, let's say, false initially, right? So it will be having such multiple to-do items. Does that make sense? Okay. So basically now we have figured out how we will be storing our data into files, right? So each to-do item is simply a dictionary. So does this point make sense till now? Yeah, file name will simply mean the to-do name only. So let's say it would be something like list1.json. Yes, we will be doing everything using Python program. So we will not be doing anything manually here. So Ravi has a good question. We will be writing code for each and everything. Okay. So anyone else has any doubts till this point? Otherwise, we can continue. So now we have figured out how we will be storing our data and manipulating the data. So for manipulating the data, we have to simply read the JSON files and simply serialize and deserialize the data. So as we learned about yesterday, serialize and deserialize the data, right? So Rohit, try to think about this. Rohit has a good question. Rohit, try to think about that. Okay. So now we are clear with the requirements and how we have to store the data. Let's now start with implementation and structuring our code. So what we will do is we will simply have a file that will be, let us say, app.py. So I have created this folder to do CLI live. So inside this folder, we will create a file, let's say app.py. So this will be our main file. Okay. So let's open this app.py. So this will be our main file that we will be using, right? So is this clear till this point about the requirements and storing the data? Okay. So now what we will do is, as you have learned earlier, so we want to have a main function here. So if you remember how we structured different files, so here we will be having different files in our code. So let's have the, let's use the double underscore name, and which we call as dunder name. So we'll check if this is equal to double underscore main, dunder main. So then we will basically have a main function that we will call. So let's create a main function that we will be calling. It takes in some arguments, let us say, which are nothing right now, no arguments. So here now we will simply say that started the to-do application, right? So now what we want to do is we want to take input from the user, command as input, as long as the user does not hit the command quit. So let's simply type, let's simply have a while one loop. So this loop will execute, it will take the command as input, right? And then we will have to parse this command. Also, let's give the command prompt as well. And let's simply say that if command of 0, sorry, let's simply say if command equals to quit, then we will simply break out of this while loop. So does this point make sense till this point? Let's try to run this program. Yeah, while one or while true, both are both works. Let's try to run our application. So see, our application would look something like this. It will start the to-do application, then it will ask for the command prompt. It will ask from user the command as input. So we will be giving some commands. Let's say we'll give to-do lists or show. This will show all the to-dos that we have. We'll give some command like to-do create. We'll say that list one. So right now there is no functionality here, so we'll have to implement this. Pratham, I use the $sign just because it is clear to the user that we have to give some input here, right? That is the main reason for giving that thing. Does that make sense? Okay. So now what we will simply say is, let's say quit here. So it will simply break the application. So we went out of the application. So that's how, yes. So Ravi, as you're saying that we can consider the case also, so that we can do as the extra functionalities, right? We are just building the basic application right now. So now it is better to have a function that will simply parse our command and return the command name and arguments. So as you saw that there were some commands that are having some arguments. So what we will do is, so let's try to structure our command syntax. So first of all, we have the command type. Command type could be a list command or a to do command. Then we have the command name that could be show, create, use, add, all, edit, something like this. And then we have some extra arguments. So the way we will be structuring our command syntax is, we say that there are three things here. One is the command type, other one is the command name, and other thing is the command arguments. So we'll try to extract all these things. So we'll have to split this input. So we'll get some strings separated by space. So split the string separated by space, right? So let's have a separate function. So basically what we'll do is, we'll get the command name and the command arguments from a function that we'll call the parse function. It will take the command as input. So let's define a parse function that takes the command as input. So just see that how we are structuring our application into different functions. And after we complete this parsing thing, we will go ahead to basically structuring the commands into different module. So let's do one thing. Let's not implement this thing right now. Let's start with seeing how we will be implementing the commands. So what we will do is, let's say this will return the command name and command arguments. Here we will be simply checking, we'll be having some conditionals. So something like, let me complete this part. So it could be something like, if command name is quit, then we will simply break. Else if the command name is something like, so there could be a scenario where the user enters an invalid command. So we'll handle that case as well. Here we'll simply print that please enter a valid command, right? And something like else if command name is, so there was a command use. So I'll tell you that we'll have to handle separately. So we'll see about this thing. Let's simply write down to do here. And else if it is a command of the type to do. So this also we'll see. Okay, command dot split. So here what we can simply do is, we can simply say that command type is command dot split of 0. So the first thing will be the command type. That is, after we split the first element in that list of strings. So else if command type is to do. So I'm writing these use and to do things here separately. I'll tell you in a bit of moment why we are doing this thing. Let's simply skip it for the timing. Then any other command that we have will simply be having a command dictionary. So what we will do is, instead of hard coding each of the things, so let's see how we'll structure this thing. So we'll just complete this function later. So this function will simply take the command as input and returns the command name and arguments. Okay, so let's create a folder that will be storing commands. So we want to segregate our commands from our application. So parse is a function, Dhruv, that we will be using. So it will simply be returning the command name and arguments. Okay, I'll try to go a little slowly here. So Ashish, the underscore name is equal to main simply means that when we run our application, this variable will be set to this main underscore underscore main, and this will call the main function. You can just go through the day 3 of our Python series. This was explained in more detail. So let's create a folder. We'll create a folder that will be commands folder, right? So now inside this command folder, we will have 3 files. So let's have one file as underscore underscore init.py. So this will be the first thing that will be running when we import this commands directory. So we will be using this commands as a module that will be importing. And one thing we'll have is list.py. This will be for working with the list commands, and one file for the for working with the to do commands. So to do's.py. So now if I open all of these things, I have these 3 more files. So in the init.py file, so parse is not an inbuilt function. So parse is a function that we will be implementing. So we'll be implementing this. We'll get to it after we structure the rest of the application. So there are some things I might go a little bit fast over here, because we will be it is mostly that you will have to implement yourself after we finish this session. So let's just increase the pace somewhat. Don't feel overwhelmed. You will be able to understand most of the things. So here we will have a dictionary of commands that will simply map the command name to the function. So it will simply basically map the command name to the command function. So then we will be having a very ease to use that function. So we will be able to understand this thing in a while. So let us say we will here import the lists as well. So we'll import commands.lists. So this will simply import the lists.py file, all the functions that are there in that file. We will also import the commands.todos file. So just see that we have to pass the folder name as well. So whatever imports we do in our project, we will be doing this from the the root directory. So this todo CLI live is the root directory. So here we have commands directory. So that is why we say import commands dot lists. So this will import all the functions that we have in the list .py file. So here we have some function, let us say def show list. It will take some arguments. Let's say just we are going to print the arguments. We'll have some function as create the list. We'll take some arguments. Here we'll simply print the arguments. Similarly, we will have some function, let's say use the list. So here we'll pass some argument, print the args, right? So in list, we'll have these 3 functions, right? So now we imported all these 3 functions. So now we can map this show key to the function. So we can simply say lists.show lists. So now when we will be calling this function, we can simply use this dictionary. So what we'll do is we'll import this dictionary in our app.py file. So what we are doing is we are trying to get rid of hard coding these things, so that we can simply use the function directly by mapping it with the key as the command name, right? So next thing is we'll have the, let's say, use command. Here we'll be using list.useList. We have the create command, lists.createList, right? Then we'll have some command for to dos. So let's say here we have def add item. We'll take in some arguments. Simply let's say print the arguments for time being. And let's say we have def show items. It will simply show all the to dos that we have available. So let's just skip rest of the functions. Let's just go with these 2 by the time being, and these 3 functions. So we can simply map the all command to simply to dos dot show items, right? And the add command to to dos dot add item, right? So we simply imported these functions by using this import statement, and we are mapping the command name to the command function. So it will become very clear in a moment. In just a moment, let's make it very clear. So what we'll do is, here we will simply import the commands. So if we import the commands module, this will simply run the init.py file. This will simply execute the init.py. It will create this dictionary, and you will be able to use this command name to map to the command function. Then you can execute this. So it will look something like this. So here you would be able to say something like, let me just show it to you. You'll be able to say commands. Okay, let's do this thing. What we'll do is, more specifically, we'll say from commands import the commands dictionary. Right. So then we can simply say here is commands dictionary of the key we will be having is command name, and then we can simply call this thing. So this is basically a function. This is a function that we can simply call with the arguments. So here we can pass in the command arguments, right? So you see that this is a very good way of calling a function. So we are trying to generalize our thing so that we have to not write many more cases here. So we don't have to hard code each of the cases, right? So whenever a new command comes, then we have to simply create a mapping over here, right? So does this point make sense now? So this will simply be used to call that particular command. So we don't have to hard code the command name directly. So we can use this init.py file, add any extra command that we have here directly, right? So any doubts till this point? Okay, so it seems like there is no doubts. It will become more clear. Okay, so this part will become more clear in a moment. So let's just try to run our program till this. Okay, what is parse? Parse is also going to be clear in a moment. So in the interest of time, let me just use this thing. So the code is basically available in the GitHub repository. Let me just use this parse function. Let me just copy this thing. Sorry. So yeah. So here, let's just go through this parse function first. So it will split the command, then this will return a list. Then the command type is simply command list of 0. Then if the command type is help or quit. So these are the two commands which are separate. So we can simply, so see that we are returning the command name and argument. So here we return command type as the command name and there are no arguments. So we return an empty list. Otherwise, the type could be a list type or a to-do type. So it is a list type, then we extract the command name. Then the command name has to be in either show, use, or create, right? So then we return the command name and the arguments will be whatever is following the second index. So whatever is after the second index. So the first index was simply list, and second index could have been something like use, and after that it could be something like list 1, right? So does that make sense? So in this case, cmd list of 2 onwards will be simply storing this list 1, right? Will be storing this list of strings, right? And otherwise we can return that it is an invalid command and empty arguments. Otherwise, if the type is to do type, then we will simply take the command name, and now it has to be in the list that we have, that is add, all, edit, remove, complete, incomplete. So for the time instant, we are implementing only add and show functionalities, right? So add and all, so only these two. Rest of you will have to try that as an assignment. So first, let's just try to run whatever we have created till this point, and in the else cases we'll return invalid, and here also we return invalid, right? So let's now see what happens if we run this. So just skip that these two commands for the time being, use and to do. let's try to run our Python program. Python 3 app.py. Okay, there has been some mistake here in the line number 42. Okay, let's just have something here, print use command. So let's try to run this now. Okay, so there seems to be some mistake here as well. Okay, we missed out the comma here, right? So now let us try to see, let's try to see what command we have. So we'll see that we say that, let's say list show. Okay, commands dict is not defined. Okay, so it has to be commands dict. I just used command here, right? So let's try to run this list show. So if you see that the arguments are empty, if we say list add, or sorry, list create, if we say list add, it would give an invalid command. So please enter a valid command. Why? Because for the list type of commands, we just allowed the show, use, and create. So Vidhan, we will go through everything once again. Let's try to add the functionalities right now. So let's say that if we say list create list one, so you will see that the arguments here are list one. So why? Because see what happens is, okay, command asks you did not understand, Vidhan. So let's go one by one once again. So first of all, we take the command as input, then we find the command type, then we call the parse function with the command name. It will return two things. So it will return the command name and the arguments. So let's go to the parse function. Then it will simply have the command list and the command type. Now, so let's see the list commands. So here we have list and we use the add functionality. So list add. So the command type would be list. So we will get to this else if part. Now the command name is simply add. So add is not in this list. So we will simply return invalid. So you saw that we got please enter a valid command. And if it was a create command, then it is inside this list. So we'll return the command name, that is list command, sorry, create command, and the command argument. So arguments here would be list one, right? So arguments is whatever is after the first thing here, right? So you see that then this gets returned. So we get back here. So you see it is not a quit command, it is not invalid command, it is not a use command, it is not a to do type command, but it is the else command. So what will happen is the commands dict will have a mapping. So it will have a mapping. So the create maps to list dot create list. So this will simply be, so commands dictionary of command name, this part, if you see, this part will map to list dot create list. So it will map to list dot create list. And here what you can see is, here we will call this create list function, that is simply printing the arguments, right? So we are passing the command arguments and that is simply printing the arguments. So does this make sense how we have structured our code and how it is working? Let's try to run this. Let's say list create list one. So it will simply show the arguments. Let's say list show empty arguments. Let's say list use list one. It will say use command. Why? Because we are printing that thing over here. Okay. Okay, it makes some sense. So let's continue. So one thing for the time being is, let's make some simplifications here so that we'll be able to finish on time. Okay. So let us make some simplifications at this time instant. So that is, let's say that we are working with only to do type of commands. So let's also call this thing here commands dictionary of command name and command arguments. So let's first quit from here. So now let's try to say to do add. So let's just so I'm making some simplifications right now to make it easier. So we are not having multiple lists for the time being. For the time being, that you have to do as an assignment. What we are having is we will be working on a single to-do list. So you can just add some functionalities here that we are skipping. So that code is available. If you want to see that particular thing, that will be available in the GitHub repository. So currently we are working on a single to-do list. So we'll have some commands like to do add the task one. So you see that it will print the argument. So currently it is going to this todos.py and the add item function. So let's also try to print here inside add item function, right? So let's exit here, sorry, quit here, and let's try to run. Now we'll say to do add task one. So you see that it prints that we are inside the add item function, right? So what we will do is, let's say we'll be working with a single file, that is, let's have this file as list1.json. So let's have this file list1.json that has simply an empty list. So we have created that thing manually for the time being. So that part would have been done in the code that is available in her GitHub repository. For the time being, let's work with this list1.json, right? So now what we have to do here is we will be getting inside this function add item, and we simply have to open this file. So what we have to do is we will open this file with open. So with open, let's say list1.json, and here we can simply say that the mode is read mode. Sorry, we have to open it in read plus write mode. So for that we will use r plus mode, that is read plus write as to do list, right? And we will import the JSON module, right, as we discussed yesterday, and we'll simply say that data is JSON dot load, and we can simply say here we'll pass the to do list. So let's try to print the data that we have, and same thing we will do in the show items also. So here also we'll say that with open, let's just copy this thing for the time being. So we can make our code more modular. We can have this thing in a separate function that will simply return the data. So what we can do is let's also do that thing. So let's simply say that get data function is there, that simply takes the file name, list name. So we can simply do this thing. We'll open this thing. Let's currently say that list name is list1.json, and we will have read mode only since we are just extracting the data. And let's say that the data is an empty list, and finally we will return the data. So what we'll say here is data is simply get data of this list1.json, right? We'll copy that part here as well, and next time we'll be opening this in the write mode. Why? Because we'll have to add this particular to do item that will be given. So how we'll extract the title? So the title will simply be arguments of 0, right? That is the title. Arguments will be a list containing the title, right? So we can simply extract it like that. And then let's do one thing. Let's simply add this. So we'll say that data dot append. So what we will be appending is a dictionary, right? So that dictionary is simply having a title, that is simply this thing title, and the created at time instant. So let us say that let's just use the string here for the time being. So we'll try to modify that thing as an enhancement that you can do as an exercise. So the current time will have to be taken from the time library, so that you can try exploring once, right? So next thing that we will do is, now we will simply say that here we will say json.dump. So now we'll have to write this thing. So we can say json.dump. The object is simply data, and the file pointer is simply to-do list. This thing we discussed yesterday. That we will, Rohit, that you can just explore in the official Python documentation, how to use datetime. That code is also available in the GitHub repository that we have, where we have already implemented this to-do app. And next thing that we do is, we will pass, let's say, sort keys is equal to true and indent is equal to true. So these are some additional parameters that we are giving, as we discussed yesterday. Yes, for created at, you have to use that datetime module. Okay, so now in the show items function, what we will do is, we'll simply get this data. So let's say, now what we'll do is, we'll iterate over every to-do item in this data, and then we will simply just print it. So there is one thing. That is for index comma to-do item, there is a function known as enumerate function. So this simply returns two things: the index as well as the list item. So in this case, we want the ID as well. So as someone asked that question, how we'll get the ID? So the ID will simply be the index of the to-do item. So this particular thing will give us index and the to-do item. Let's simply print the index, comma, will print the to-do item. Let's use index plus 1 and to-do item of the type. The key of this will be a title. So to-do item is a dictionary that contains title and created at columns, right? So we are printing the title at this instant. One thing that we can do is, if length of data is 0, then we can simply say that print no to-do item in this list, and we can simply return, right? So that is how we will simply operate with these files. We'll be adding data and we'll be extracting the data. Let's now try to run our program. We will be getting some errors. Let's try to see and debug them. So it's very hard that everything will work in the first go. Let's quit this thing. Okay. So now let's try to run this. So we'll say that python3 app.py. So we simply say to do show. So this is not a valid command, because the valid command is, you see, it is to do all. So show is for lists, which we have not implemented. So to do all. So it says that no to do item in this list. Let's now try to say to do create, and let's say that we create some to do item, task 1. Okay, so this is also not valid, because create was for lists. For to do's, we have add command. So let's say to do add task 1. So it does not print anything. So that must have been created. So as a better user experience, we should have given some output that it was created. But now let's try to see it manually in the list1.json. So if you see the list1.json file, you see that we got this task created for us, right? Let's try to create one more task. Let's say that we say to do create task 2. Okay. Sorry, it has to be to do add task 2. Then you will see that task 2 has been created, right? Then now let's try to say to do all. So it will give us all the to do's that we have: 1 task 1, 2 task 2. So now let's also try to see how we'll get the time. So 1 second. So we can simply use the from datetime import the library that is datetime. So we can simply say here created at, and we'll have datetime.now. So let's try to see in the Python terminal here, Python REPL. So from datetime import datetime. So let's try to see what datetime.nav gives. So it is some kind of object, and if you see datetime.nav gives us an object that contains year, month, day, time, hour, minute, seconds, etc. Right? So we have to convert it. So I'm just using a formatter. So there is a function strftime that will format this thing. So if you see, this will give us the formatted time. So just try exploring on this strft time function. I am just using it at the time instant. And one more thing that we had to use was the completed key. So this will simply store false at at this particular instant, right? So this has to store the false variable, right? So does this make sense to everyone now, how we are doing this thing? Now let's just empty our list for the time being. Let's just empty that thing. Okay. So now let us try to see. Also, let's add one functionality. Let's also show how many items have been completed, how many tasks have been completed. So let's say that completed variable is 0. So we can simply check if to do item of completed, if this key is simply equal to true, then we can simply increment the count completed plus equal to 1. And outside this, we can simply say that print. So we will use format string. So hash of, okay, completed out of total is how much, length of data tasks have been completed, right? So that is how we'll do this thing. So let's now try to run this to do application that we have built in till now. So we'll simply say to do all. So it will say that no to do item. We'll say to do add, let's say task 1. Let's say to do add task 2. Now let's try to say to do all. So you see that we get listed all the tasks and 0 out of 2 have been completed. So let's also say to do add task 3. Now let's try to say to do all, right? So now do you understand how this to do application is working? So we have only implemented the minimal functionalities till this point. That is showing all the items, to do items in the list, and creating all the creating or adding a particular task, right? So now on top of it, there are a lot of functionalities that we listed down in our requirements that you have to implement. So edit functionality, remove, complete, incomplete, and simply you have to work on this list functionality also. Currently we are just having one single list, right? So let me give you a demo of how our final application should look like. So let me give you a demo of how our final application will look like. So we are going to so there is so if you will open the repository that we have, if you will open, let me share the link with you as well. So if you will open this repository, we have implemented everything here, but just try to build it yourself from scratch. That will give you the most of the learning. So let's now run this application. So let's see what all commands are available. So if you will run the help command, you will see that all these commands are available: list show, list use, list create, list, and then we have the to do type commands and the quit command. So let's try to see how many lists we have currently. So let's say list show. So we don't have anything. Let's try to create one. So list create list 1. So it will say successfully created the new list. Then we can say list show. It shows the list. Then we'll say list use, and let's say list use list 1. So it will say successfully chosen this list. Okay. Now let us try to work with the to-dos. Okay. Let's try to go back once again. So I'll say list use list 1. Then I'll say to do add, or basically to do all. Okay, to do all. So it will say no to dos in the list. Why don't you add one? So let's say to do add task 1. Let's now say to do all. So it says 0 out of 1 completed. Let's say to do add task 2. Let's now try to say to do all. So it says that 0 out of 2 completed. Let's now mark the first task as completed. To do complete 1. Now let's try to say to do all. So now it will say that 1 out of 2 has been completed. Okay. So also let's see how the files are visible. So if you will see that also, let's see the file. Yeah, so we have one list.json file. It stores that there is a list one which has the created at and title. So this is the same structure, the dictionary of dictionary that we looked in the beginning, right? And there is a list folder that will store a particular list1.json that stores all these to do tasks. It has completed, which is true, completed at, and the title, right? So that is how it is happening. You can just look at the source code. So the structure is very similar. We have app file, then we have commands. In that we have init.py, very similar, and then we have list.py, and then we have todos.py. So the structure is the same. Just try to build it yourself once. It will give you more clarity. So let me also share the screen showing the repository. So do you have any doubts till this point? So mostly I am done with this thing. So Rohit is asking a question. Why do we have to use all the commands in one go? Why we can't use all the commands in one go? Okay, so Rohit, we can do that. I was just exiting the console so that it was visible to you clearly. So why? Because everything was coming in the bottom part, right? So just for that purpose. Okay, let me share the screen showing the GitHub repository. Just give me 1 minute. I'm opening the GitHub repository. Yeah, it seems a little complex at the moment, but just try to build step by step. Like, let's once again we'll recap the process, and then you try to build it yourself. We'll recap the process. So I hope you can see the screen now. Okay, so if you go to the introduction to Python, Scalar Academy / intro to Python repository, you will see that we have updated the lecture 6 notes here. If you click here, then you will get to this to do CLI application readme file. So so the first step is you just list out the use cases of your application, list out the commands, list out the JSON files that you will be using. So then let's go to the code. So then we had this app.py file. So if you go to app.py file, we have simply two functions. One is for the parsing of the command, and one is the main function, where you simply take the command as input, parse it, and simply run the command. So for running the command, you are using this commands dictionary, so which you have imported from the commands module, right? And then if you go to the commands module, then you simply see that there are three files. Are you able to see the screen? Okay, there you go to init.py, and here we just listed out the commands and mapped them to the functions, right? So for example, this show lists will map to do CLI / command / list.py dev show list, right? Let's go to that function. Okay, so here we are simply opening this file and listing out the list that we have, right? So just try to create all these functions and try to implement them one by one, right? So that will be a good step-by-step procedure. Just try to first of all complete the to-dos part. We just implemented the add item and the show item functions. Just try to work on edit item, work on remove item, complete item, and incomplete, right? So just try to go function by function, and it will become very easier. So just try to build this thing from the scratch, and if you are stuck, then look at this repository. If you are stuck, then only look at this repository. So Dhruv, you have to simply pull the, so you simply have to pull from this this particular origin. So just you can search about how to update a fork. So Dhruv, just Google about how to update a fork, or you can simply do a fresh fork of this particular repository. So just go to this repository. Just also Google about how to update a particular fork. That will also be useful. So I would recommend everyone to watch this repository and fork it, so that you can simply take a copy of this code. Just go to this to do CLI and try to build this application from scratch, right? So we are done with the session. Do you have any doubts? We are done with the session. Any further doubts you have? So let's quickly recap. So we went from the first step, that was figuring out the requirements, to structuring our code. Then we implemented it, and we kept on testing the functions as we implemented them. And finally, we were able to run some part of the application, right? So just follow this step-by-step procedure and try to build this application, and just try to figure out if you can make any extra enhancements to this application, right? Just try to make your own version where you have any extra features that you can think of, right? So we basically used all the concepts that we learned till now, that is the flow control, the loops, structuring of the code, importing the modules, and basically working with JSON files, etc. So I hope it was a great learning experience, right? So a fork is basically creating a copy of a repository. Great. Okay, so that is it from today's session. I hope you enjoyed this session. Like, it will be more beneficial if you build this application from scratch by yourself, right? Okay, great. So I'll wait for 1 minute if there is any further doubts. Okay, fine then. Thank you everyone for attending this session, and see you everyone in the tomorrow's session. So from tomorrow's session, next week, we will be continuing and working with Django. So more things will be discussed from tomorrow onwards. So that will be announced tomorrow, how we will be structuring the next part of this Python series. So just stay tuned, and thank you for attending. Bye bye.
I hope you really enjoyed taking this course. It's my promise that we'll keep on adding more free courses in future as well. But to do that, please support our free offerings by liking and sharing this video. Also, please subscribe to our channel and help us continue in our mission to provide free quality education via our YouTube platform. Thank you all for joining us. I'll see you again in the next video.
Hello everyone, I am Pragya, and today we will be going over quite a bit of Python interview questions. Right now, these questions are going to be about the core Python language, and these questions are going to be questions that were asked in top tech companies like Google, Flipkart, Amazon, and other places that use Python extensively. All right. So we will begin with very simple questions about what Python is and how things go, and then we will dive into a little more advanced questions about the Python language. Now note that Python is a very big language, and Python is not alone, right? So Python comes with a large ecosystem with itself. So you might have heard of things like NumPy, you might have heard of Pandas, you might have heard of Matplotlib, right? And you might have heard of things like Keras and TensorFlow. Now, if you are interviewing for a Python position, it is very likely that the place you are interviewing for uses some of these technologies, right? Uses some of these libraries. Especially, it is very common for places to use things like Django or Flask, right? Now, today in this particular session, we will not be covering questions on these ecosystem topics. We will be conducting another session to cover questions on these. Today, we will be covering questions on core Python language, questions that are extremely important, questions that you will invariably be asked if you are going to any Python interview, right? So we are going to look at that. And for these particular things, we are going to have further sessions. Okay. Now, if you want some more questions, if you want some more practice material, apart from this session, you can always go on to interviewbait.com/Python interview questions, this link right here. And over here, you will see a large repository of Python questions along with their explanations, right? And you will also see some multiple choice questions at the end that you can try on for yourself. We keep on adding things to this particular repository. So it is always nice for you if you can keep updated, if you can keep in sync with this particular web page. Okay.
the questions that you see here, they are not tied to any particular rule. Whenever you go to a top company, right, or a company that uses Python as its core technology, for example, companies like DE Shaw, a large part of their code base is in Python. At places like Google, Python is not the core language. They extensively use Java. However, a lot of systems in Google use Python. Like places like Instagram, places like Dropbox, they use Python extensively. Irrespective of where you are interviewing for, as long as you have Python written down in your resume somewhere, if you primarily use Python as your coding language, and if you're interviewing for any position that requires Python, then you can expect that you will be asked some of these questions. Cool. So let us dive into the very basic question. Let us start with a very simple question. What is Python? Like, what is Python? So, well, Python is a very high level language. It is an interpreted language. It is a dynamically typed language. It has a lot of features. It has a large ecosystem, right? And there are various advantages to using Python. Especially, Python allows you to write code very quickly, and it has a very high throughput for the developer. So whenever you have an application in which the developer time is more important than the computer time, you use a language, a high level language like Python. Also, Python allows you to very quickly experiment with things, which is why it is used extensively in the academia. So places like data science, places you have to write large pipelines of data, you have to experiment a lot, Python is used over there. It is also a very good academic language. So for teaching students, Python is a really good language. Cool. So let us dive into some details about Python. Please let me ask you a question as an interviewer. So what do you think? Is Python a high level language or a low level language? Well, Python is a high level language. Now, can someone give me examples of high level languages and low level languages? Low level would be things like C, assembly, COBOL. High level languages would be like C++, Java, Python. It is not a strict delineation about what high level and low level is, but Python is usually classified as a high level language. Okay. What about things like strongly typed versus dynamically typed? So first of all, what do these things mean? What does it mean for a language to be strongly typed or to be dynamically typed? And once we know that, what sort of typing does Python use? So Python is a dynamically typed language, not a strongly typed. So we have multiple categorizations. So we have strongly typed and weakly typed, and we have statically typed and dynamically typed. Now Python is a strongly typed language, and Python is a dynamically typed language. Now, what do these terms mean? So a strongly typed language is one in which every particular variable or every particular data that is in memory has a strict type associated with it. For example, in Python, if I do something like as follows, so if I do something like the string 1 plus the number 2, if I do something like this in Python, I get back a type error. I get back a type error saying that I cannot concatenate a string with an integer. So that means that this particular piece of data, the number 1, and this particular piece of data 2, these have strong types associated with themselves, and Python does not automatically convert the types as and when it wants. So there are some constraints about what types can be used with what other types and what operators can be used with what other types. Contrasting this is weakly typed language, things like JavaScript. For example, if I quickly open my console over here and I go to the JavaScript console, in the JavaScript console, I can once again type something like 1. So this is a string. I can type something like 2, which is an integer. But I can also do 1 plus 2. And this surprisingly gives me back the string 12. So this, for a programmer, might not make sense. JavaScript is a weakly typed language. The string 1 and the number 2, they have the types associated with it, but they are not strongly typed. Types can be converted between any of those. So here we see that Python is indeed a strongly typed language. Now, what about a dynamically versus statically typed language? Well, you might have heard of languages like C and C++ or Java. In those languages, we usually write statements like this. So we say int I equals to 10, or we say float b equals to 20.3, or we say things like boolean flag equals to true. Right? Now, these are languages which are statically typed. At the time of writing the program and at the time of compilation, the compiler knows what the type of each variable is. On the other hand, in a dynamically typed language, the compiler need not know what the type of each variable is. For example, in Python, you can simply say I equals to 10. And later on, you can also change the type of I. You can say that I equals to true. So the type of variable I, it is not bound to something. At this particular point, the value that I is holding is an integer type. But at this particular point, the value is a Boolean type. So Python, as we see, is a dynamically typed language. All right. Now, that does not mean that Python does not support static typing. So there is something in Python called MyPy. So let me just add a new note over here. So there's something called MyPy in Python. MyPy is a static type checker for Python. So even though Python is dynamically typed, it supports optional static type checking. So you need not use it, but if you want, you have the liberty of using it. And what this does is, before you actually run your program, it will go through your entire code and it will tell you if you have made any mistakes related to the types. Okay. At the runtime, this does not have any effect. It is just before you run the program, it will check your code statically. All right. Now, there's one more very important distinction between Python and other languages, or one more important property of Python. So is Python a compiled language, or is Python an interpreted language? Interpreted language, if I can spell it. Well, Python is actually an interpreted language. Now, if Python is an interpreted language, haven't you come across things like the Python bytecode? Or haven't you come across files that look like this, .pyc files? These are Python compiled files. What are these? If Python is interpreted, what the hell are these things? So an interpreted language versus a compiled language is not that simple to distinguish. In a compiled language, you have an explicit compilation step. Whereas in an interpreted language, you don't have an explicit compilation step. What happens in Python is you have some non-explicit compilation. So what happens in Python is you have your Python source code. That can be something like some file .py. This is your Python source code. Now, when you actually run this, so you are using something like the CPython interpreter. When you actually call Python some file .py, what happens is the Python interpreter, the CPython interpreter, reads all the code in your file. It compiles it down. It compiles it down to a Python bytecode representation. It does that automatically. You don't have to compile it yourself. And once it does that, it starts executing it from top to bottom, right, in a step-by-step manner. Now, so this basically means that there is no distinction between the compilation phase and the runtime in Python, right? For you as a programmer, it doesn't really matter what phase you are in. You are either coding or your program is either running. You don't see that compilation phase yourself. On the other hand, for languages like C++ or languages like Java, in these you explicitly compile your program, and you might have to make some changes while compiling your program. So if you see a compiler error while compiling your program, you will go back to your code and make some changes. So you can have compile time errors and runtime errors in these languages, C++ and Java, whereas in Python you only have runtime errors. There's no compile time errors in Python. All right. Can you tell me the difference between things like CPython, Python, PyPy, things like that? So what are the difference between these things? So this is a very common interview question that a lot of you will come across, and it is very important to know the distinction between these things. In fact, this is not just important for interviews. This is also important if you are doing any sort of online competitive coding. So it might have been the case that you went to interviewbit.com or you went to codechef.com, and there while you are coding, if you choose Python, you will see many interpreters. So you will see something like Python 3.5. You will see something like PyPy. You might also see Python, right? So what are these things? These are actually different Python interpreters, and they are also sometimes different variations or different styles of Python. Right? So let me go over a few of these. So by default, when we go to something like python.org, right? All of you are familiar with this website. When we usually go to python.org and we download Python from here, what we are actually downloading is the CPython interpreter. Right? Now, Python itself is the language specification. Python is the language specification, just like C++14 is a language specification. C++14 is not a compiler. The GCC compiler is a compiler. Right? C++ is just a language specification. Similarly, Python is a language specification, and the CPython interpreter, which we usually see as python.exe on most systems, or just the Python file on Unix systems, that is an interpreter that basically implements the Python language specification. When we usually talk about Python, we are talking about the CPython interpreter. However, this is not the only interpreter that is available to us. We have many other interpreters. So, for example, things like IronPython. right? Or things like Jython. Now, these different interpreters, they are written in different languages. For example, the Iron Python makes use of the .NET framework, and it allows very nice interpretability between .NET code and Python code. So you can import .NET code in your code. You can export. You can call .NET functions from your Python code. Similarly, Jython runs over the JVM, right? So over the Java Virtual Machine. Jython basically allows you to call Java code from within Python. Now, if you understand these, that might give you the hint that C Python, the default Python interpreter, this actually is implemented using C, and it allows you to easily access C code. So actually in Python, you can use C types and you can make use of C code. You could write a function in C and you can call it via Python. However, these are not the only interpreters. We have several other interpreters, things like PyPy. Now, this might give you the hint that, hey, this is PyPy, so this is probably Python written in Python itself. In fact, it is. So PyPy is a Python interpreter that is written in Python, right? If you all understand that, hey, Python is a really slow language, so PyPy must be ridiculously slow. On the other hand, on the contrary, PyPy is actually way faster than C Python. The reason is that PyPy has something called a just-in-time compiler, right? This is called a JIT. So what PyPy does is, whenever it is reading your file, if you identify hot parts of your code, parts that are very fast loops or parts that are being used very frequently, and it will compile it down to machine code on the fly. So that will cause a lot of speed ups for your code. Now there are other versions of Python, things like Python, things like TypeScript. These are not strictly different interpreters of Python. These are different styles of Python. So apart from providing the core Python syntax and the core Python library, they provide you other interpretability. For example, TypeScript is kind of a mix between Python and JavaScript. Python is a Python runtime in the browser, other things like that. All right. Cool. So please understand this very carefully, that there's a difference between C Python, Python, PyPy, Python, and things like that. And this is a very common interview question. All right. How do we write Python in Python itself? Well, by writing Python in Python itself, what we mean is that you have, what does the Python interpreter do? What does the PyPy interpreter do? It takes some files, right? Takes your code files. It basically reads them, it parses them, right? And basically it creates an abstract syntax tree out of them, and then it executes them line by line. It executes them. Now this entire process, you can code this entire process with any language that you want. So if you code this process in the language called C, there is one such interpreter called the C Python, right? If you code this entire process in the Python language itself, then you will get a Python interpreter written in Python. All right, cool. So let us move on to the next questions then. Now let us dive into some more the nitty-gritties of Python. You might have also heard of things like Python 2 and Python 3. So this is a very, very important question for almost all of you. A lot of the times when you go to an interview, what you see is that people have something like this written in their resume. So they have this skill section in their resume, and in the skill section they write Python 2 and Python 3. Now, whenever an interviewer sees this in your resume, a very common question comes up in the interview, and the question is, can you tell me the differences between Python 2 and Python 3? And guys, this is very important. If you are mentioning both Python 2 and Python 3 in your resume, and if the interviewer asks you to tell the differences, you better know the differences, right? If you do not know the differences, that clearly states that you actually don't know the differences between Python 2 and Python 3, and then it does not make any sense to write both the versions in your resume. The same goes for if you're writing things like C++ 14, right, in your resume. A very common question that comes up is, what is this 14? What does this 14 mean? Can you tell me the differences between C++14 and C++17? Or can you tell me the differences, what's new in C++14 that is not part of C++ older versions? So it is very important for us to understand the differences between Python 2 and Python 3. Now, there have been a lot of differences between these two versions. Perhaps the most important ones were the Unicode support. Right. So Python 3, in Python 3, the string data type, the inbuilt string type, by default supports Unicode, whereas in Python 2 it does not. In Python 2 you have to use something else for the Unicode support. There are many other differences. So the most common difference that you know in Python 2 versus Python 3 is it's the print function, right? So everyone knows that in Python 2 you write print something like this. So print hello from Python 2. Whereas in Python 3, you will write print something like this. So print is now a function. Whereas in Python 2, print was a statement. This is a statement, not a function. Whereas in Python 3, this is a function. Right? So this is one of the more common differences that you will find in Python 2 and Python 3. Whenever you're trying to port code from Python 2 and Python 3, you will see this. Now, whenever you answer this in an interview, the very next question that will come to you is, if you're coding in Python 2 and you still want to use the print as a function, can you use print as a function in Python 2? Well, we can. There is something called the futures module. So you can do from future import print function, and that will allow you to treat the print as a function in Python 2. So whenever you're dealing with legacy code in company, it will be very important for you to always have this sort of import at the top of your code, so that if some other developer runs your code in Python 3 instead of Python 2, your code still works. All right. By the way, let me just give you a quick link. You can actually go to this thing. So wiki.python.org/ yes, this particular link. So I will just paste that link over here so that everyone can see it. You can always go to this link, and this has a lot more details about the differences between Python 2 and Python 3. Now that we know that we have two versions of Python 2 and Python 3, which Python version do you think we should use? Well, Python 2 is kind of dead. Python 2 is no longer supported. There are no more security updates coming for it. So we should always use Python 3 when possible. So whenever you are working at these large companies like Google or Amazon, a lot of their legacy code might be in Python 2. So just saying that, hey, I completely work with Python 3 and I do not know anything about Python 2, or I do not understand the differences between Python 2 and Python 3, is not going to cut it. Even though Python 2 is dying, and even though you should always begin a new project in Python 3, it is still important for you to understand the differences between Python 2 and Python 3. All right. However, please always use Python 3 when possible. And if you are forced to work with Python 2, always use the future imports whenever you can. Always use modules or libraries that allow you to interport between Python 2 and Python 3 code, so that if some other developer runs your code in a different Python interpreter, the code still works. Moving on, let us dive into some more questions. Now we will be going into more of code related questions. So first of all, is self a keyword in Python? Well, turns out self is not a keyword in Python. So a lot of the times we will see code something like this. So we will have some class. So let us say class foo, and in this we will have some function. So let us say def spam. In the spam we will have the first argument as self, and then apart from that we might have several other arguments, right? Now if I print the self is a reference to the instance. But it turns out that I can rename this to anything. I can say some other variable name, other name over here as well. Right? I can totally say some other name over here as well. Also, I can do something else. So for example, I can come over here and I can say self equals to 3. And this code works. So over here we see that self is not a keyword. How do we know that this is not a keyword? Well, whenever we have a keyword, we cannot use that keyword as an identifier. We cannot use that keyword as a variable name. For example, I can't do something like this. I cannot do something like if equals to 3, because if is a keyword. I cannot use that as a variable name. If I do this, I will get a syntax error saying invalid syntax. Similarly, I can't use something like none equals to 3. Similarly, I can't use something like async equals to 3. Right? These are all keywords. Now, if you want to get a list of all the keywords in Python, well, Python provides a very nice library for that. So there's import keyword. You can import the keyword. And from this keyword library, what you can do is you can print the keyword .kwlist. And this will give you all the keywords that are defined in Python. Now, these keywords will change from version to version. For example, the async and await keywords were only recently introduced in Python. These were not available before Python 3.5. Similarly, a lot of the keywords were recently introduced in Python, and the number of keywords in Python will differ from version to version. But irrespective of what Python version you're using, you can always import the keyword library and you can print the list of keywords directly from it. Now that we're talking about keywords, let us quickly go over what each of these keywords are for. Okay. So what is the false keyword for? The false keyword is the inbuilt data type, which is a Boolean, right? So we can have A equals to false. Similarly, the true keyword over here, B equals to true. These both are Boolean types, the inbuilt Boolean types. All right. What about the none keyword? So the none keyword is in fact like a null or a nil value in Python. Right. So if you're coming from other languages, you might have seen a null or nil value. In Python, we call that the none value, and none has the type none type. Right. So I can come over here and say that some value equals to none. So now we have false, none, and true none. What about and? So we have several keywords over here. So we have this keyword and, we see this keyword or, we see this keyword not. So we see these three keywords, and, or, and not. What are these keywords about? Well, these keywords are the conditional statements, right? So these are the Boolean logical operators. Right? So for example, you can come over here and say x equals to true or false. What is true or false? Well, if you look at the Boolean tables of the or word, then you will see that true or false is in fact true. So if I print x over here, it comes out to be true. Similarly, we have and we have not. So if I say x equals to not or false, well, that will turn x into true value. All right. So far we have covered false, none, true. We have covered and. What about as? What about as? So where do we see this as keyword? We see this as keyword typically in context managers, right? So for example, you might have seen something like with open some file name .txt, comma read as f. So what this is basically doing is it is creating this object and it is assigning that object to this variable f. So this as keyword is often used in context managers. Let us look at the next keyword, assert. Assert is used a lot in things like unit tests. So what assert does is assert basically tests Boolean conditions. So you can say something like assert 2 equals to 3. This is called an assertion error because 2 is not equal to 3. It will raise an assertion error. You can also put an optional message over here, and then the assertion error will come up with a message. Assert is used a lot in unit. Now we have async and await keywords. These are used with respect to coroutines in an asynchronous programming in Python. We have the break keyword. Well, break keyword is used in loops. So if you want to break out of a loop prematurely, then you can use a break keyword. Break keyword is valid both in for loops and in while loops in Python. The class keyword is to define classes, right? To define the object-oriented programming class in Python. The continue keyword once again is used in loops. Def is used to define a function. The del keyword is used to delete a particular variable. So currently I have x defined over here. If I say del x, now x is gone. Now if I try to print x, I will get a name error. That x is not defined. Del is used to delete a particular variable. Apart from deleting a particular variable, it can also delete values inside a variable. So I can come over here and I can say x equals to, let us say a list 1, 2, 3, and I can come over here and delete x of 1. This will basically do is it will delete the value at the index 1. All right. So the del keyword, as we see, is overloaded. It has multiple uses. The else if keyword and the if keyword, once again, these are just the control flow operators of Python, the if and else. Similarly, the else thing. Except is used for, as we can understand, exception handling. Finally is also used for exception handling. We will come over finally again. So in the later questions, we will see what finally is for. For is for looping. What is from used for in Python? From is often used for importing something, right? So you can say import random. I can import the random module, or I can say from random import the randin function. Right? This will import one particular variable from the random namespace, right? So from is used for that. Global is used to basically tell the Python that the current variable that I'm using is belonging to the global namespace. For example, I can come over here and say a equals to 10. Then I can define a function, def4, and over here I can say global a. Now, if I change this value, so I can print a, I can call foo, and if I print a again, I will see that this global a has been changed. So this is done by specifying this as a global variable over here. I can, if I remove this particular line, then we will see that a was not changed. It remained 10. So that is what global is used for. We have covered if. Import is definitely for importing things. In is used once again in for loop. Is keyword, we'll look at that later on, is basically is used to do identity checking. Lambda functions, we will cover this. Non-local, once again, we will cover this in the scope part. We've already covered not, we've already covered or. What about pass? This is a very common interview question. What is pass in Python? I mean, this seems like a very simple question, but it is quite often asked in interviews. Yes, so pass is basically used as a placeholder. So whenever we have some syntax in Python, let us suppose we have an if block. So if condition, right? So if 10 is less than 20, right? Now, if inside this if block, I do not want to do anything, then I cannot leave this blank. So I can't say print, okay, I'm done over here. If I do something like this, I will get a syntax error. I will get an indentation error. It says that, hey, I don't understand this over here. There should be something inside this if block. If I don't want to do anything over here, but I still want to have it be syntactically correct, I can use the pass statement. Pass is the no operation statement of Python. So if I just do pass over here, then this thing works. All right. So pass is just a placeholder keyword that we use when we want to make sure that we are syntactically correct when the Python syntax expects a block, but we do not want to do anything. Right. So pass is just a no operation in Python. Okay. Let us see what other operators we have. Raise. Raise once again is used for exception handling. Return is used to return a particular value from a function. Try is used for exception handling. While is used for looping. With is used for context managers. We will take questions over the context manager things later on. Yield is used for generators. Once again, we will see this in some time. All right, cool. So that was all the keywords in Python. We are not going to cover all these particular concepts in detail in details in this particular session. So this session is for the Python interview questions. We are not going to teach you Python over here. However, whenever we come across a good interview question, we will explain that in depth. Okay. So if you want to learn any of these things more in depth, you can always reach out to our interview web page, and there you will find explanations. Or you can always reach out to me personally on LinkedIn and ask for help regarding any of these, and I will be very glad to help you out. Okay. Let us move on then. What is raise? Raise is basically used to catch and raise exceptions. For example, I can come over here and I can say, so I could be doing something. So suppose I write a function, def divide, right? I'm writing this function. I get the numerator and I get the denominator. Now over here, I can check if the denominator is 0. Then I want to raise an error. I want to raise an exception because, hey, the denominator dividing by 0 is not valid. I can come over here and I can say raise exception. I can create a new exception object and I can raise, hey, you cannot divide by 0. Right? So raise is used in this context. Otherwise, I can just return num divided by denominator. So if I call this function, if I call divide of 10, 20, then this works. But if I try to do something like divide of 10, 0, an exception gets raised and my custom exception gets raised. Right? My exception, hey, you cannot divide by 0, that gets raised. So that is what raise is used for. Whenever we use raise, we usually pass an exception with it, but it is not necessary that you pass an exception. For example, I could also come over here and say, try to divide this. If we find an exception, if we find any exception, then just re-raise that exception. Right? So raise can also be used without any exception. So what this does is, whatever exception your try proc currently got, it will just re-raise that from the context. Okay. The raise keyword is same as true in Java. However, the raise keyword is kind of overloaded. For example, as we just saw, we can use raise keyword without an exception. We could also use something like raise from, right? So we can catch this exception as E, and then we could raise a new exception from E, right? So raise is kind of overloaded. It has multiple syntactical uses. Apart from the normal raise exception thing that we usually see in Java, we have other variants of this raise keyword as well. Yes, we have covered all the keywords. Now let us move on to some built-in data types. So here's a very, very famous, very common interview question. What are the built-in data types that Python supports? What are the most common data types that Python supports? So if you're talking about languages like C and C++, or if you're talking about languages like Java, you have several built-in types. So you have things like arrays, you have things like integers, you have longs, you have floats, you have booleans, you have strings, you have byte, and things like that. What about Python? What built-in types does Python support? Well, yes, Python supports a large variety of types. So we have things like integers. So let me do something. Let me come over here and let me define a list. So let me say different values. let me define a list of different values, and over here I will have an integer. I can have something like a float, so I can have the value of pi, for example, an approximate value of pi. I can have a true and a false over here, so these are Boolean types. I can also have a none type over here. Then I might even have a string over here. Then I might have something like a tuple, so 1, 2, 3, or I might have a list, 8, 2, 5, or I could even have a dictionary, so 1 to 1, 2 to 4, 3 to 9, or I can even have something like a set, so 1, 2, 3, this is a set. I can have something like a range, 2 to 5. I can have things like a frozen set, so 1, 2, 3. So these are all the different values. Now let me quickly loop over each value for value in values. Now what I'm going to do is I'm going to print the type of this value, and I'm also going to print the value itself. So we will see what the different types of these values are. So we see that 10 is an integer, 3.141 is a float, true is a boolean, none has the type none type, Python is a string, right? This particular thing in the quotes is a string. This is a tuple, this is a list, this is a dictionary, this is a set, this is a range, and this is a frozen set. All right. Apart from that, we have something that is not commonly seen in other languages, a complex data type. So I can do something like 1 plus 2j, and what this represents is a complex number. So 1 plus 2j is in fact a complex number. All right. So these are all the different data types that Python supports. Okay. Now, what is frozen set? A frozen set is just a set which is immutable, right? So basically, if I have something like a set, so I can say set 1, so I can say value 1 equals to set, right? Or I can say value 2 equals to, I can also define a set using this particular notation, right? So both value 1 and value 2 are sets. Now what I can come over here and do, what I can do is I can say value 2 dot add some other value. So what this does is it changes this particular set. It adds something to it. Oftentimes we would like to have sets which are not changeable. So if you want a set that you cannot change, but you can still do set intersections with it, you can still find the length of that set. We want everything that behaves like a set, but you cannot change it. That is called a frozen set. If I just say frozen equals to frozen set of 1, 2, 3, if I say this, now I have a frozen set. Now if I try to add something to it, I will get an attribute error which says that frozen set has no attribute called add. I cannot add to a frozen set. All right. Cool. So let us look at some more questions. So one very famous question is this: what is step 8 and why it is important? Why is it important? So first of all, what is this thing called PEP? So PEPs are actually Python enhancement specifications, right? So Python enhancement proposals. There's a huge list of this. So what I can do is I can go to python.org, and we can also go to the PEP 008 over there and see what this PEP is actually about. 0008, my bad. Right. So this is the PEP 8, and what PEP 8 is? It is a style guide for the Python code. So it basically tells you how your Python code should look like, what the indentation should be, do you use tabs or spaces, what should the maximum length of line be, what type of string should you use, how should you properly import things, how should you have comments, how should you specify documentation strings, and all these things. So this basically tells you what beautiful, what idiomatic, properly formatted Python code is, right? So PEP 8 is a Python enhancement proposal that basically gives you the guidelines. So once again, these are not rules. Right? The PEP 8 does not give you rules. It gives you a good set of guidelines that you should follow to make sure that your Python code looks good. It is formatted properly, right? To make sure your code is formatted properly, right? That is what PEP 8 is. Now, a lot of the organizations will follow some format of PEP 8. They might not follow PEP 8 strictly. For example, PEP 8 says that whenever you are dealing with Python code, the Python code should not have more than 80 characters in any line. Now, this was enforced way back in the 90s when we were working with terminals. Terminals usually had an 80 character width. So if you had any Python line, any code line that was more than 80 characters, then it would either scroll or it would wrap down. Right. So that is where this particular guideline comes from. Now, on modern systems, it is very common for your monitors or whatever system you're using to have support way more than 80 characters. For example, if I try to write down how many characters this particular screen can support, I will be able to fit way more than 80 characters. So limiting your code to just 80 characters width is probably not something that you should be following right now in this modern world. So a lot of the organizations will follow PEP8, but they might violate some of the conditions of PEP8, and that is basically fine because PEP8 is a set of guidelines. It is not a set of rules. However, if you want your code to be idiomatic, to be properly formatted, and to be readable to other Python developers, it is strongly recommended that you follow at least some basic guidelines of PEP8. All right, and that is why PEP8 is important. Now, there are a lot of formatters like Black. There are a lot of linters that basically lint PEP8 errors that will basically automatically make sure that your code is PEP8 compliant. Right? All the modern IDEs support PEP8 for compliance. And if you are using something that is not an IDE, something like Vim or something like VS Code or something like Sublime Text, you can always add add-ons that will make sure that your code is still PEP8 compliant. All right, cool. Now, with PEP8, there's a common question that comes, and that question is, what things? I mean, what are these things? So, what is PEP? What is PEP the same as PEP? What is PyPI? Right. So these are all very confusing names, and it is important for you as a Python developer to understand these things. These can very well come in as an interview question. Right. So these things are different. PEP stands for Python Enhancement Proposal. Right. This is what we just saw. Right. So PEP8 is one of the PEPs. There are many PEPs. All right. PEP is the default package. So this is the package installer for Python. Right. So let me quickly open up a terminal for you guys. So what we see is we have, let's say that we have Python 3 over here. And currently, if I try to import this module, TLDR, I won't be able to import this module. Right. So I hope that you can see this code. So I tried to import this module TLDR, and it said that, hey, no module named TLDR. So what I can do is using pip, I can install this particular module, TLDR. So it will basically install this module for me. If I go back to Python 3, now I can successfully import this module from my command line. Okay, this does not work. So let's try something else. So maybe I can try importing TQDM. So basically the pip module. So pip minus help. This is a Python package installer. This is a package installer for Python. All right. Cool. What about PyPI? Well, PyPI is the Python package index. Right. Whatever modules or libraries that you can install via pip, they are available on the PyPI index. So you can go to pypi.org, and pypi.org. So as you see, this is the Python package index, and this lists down all the different packages that you can install via pip. Right. So this has thousands and thousands of packages. So over here you can see this is 240,000 different projects, and you will see all sorts of things over here. So all things like Flask and things like Django, all these different modules will be available on the PyPI. Okay. Yes. So pip is just like npm. So it is a package manager, and PyPI is actually the index where all these packages are stored. Right. Cool. Moving on. Let us dive into some actual code of Python. All right. Now, one very common question once again is, what is the difference between tuple versus list in Python? So what is the difference between a tuple and a list? So for one thing, tuples are immutable. Right? So basically, if I define a tuple, I cannot change it. For example, if I say a equals to 1, 2, 3, right, I can print the type of a. So the type of a is tuple. And if I try to change the second value of a, then it will give me an error saying that tuple object does not support item assignment. Right? Tuples are immutable. On the other hand, a list, let us say L equals to 1, 2, 3, lists are mutable. So I can print the type of a list over here. So this is a list in fact, and I can come over here and say list of 2 equals to A, and this will work. So this has changed the list. So lists are mutable. So that is one of the key differences of tuples and a list. There are several other syntactical differences. For example, you must have already noticed that if I'm defining a tuple, so I define the tuple using this parenthesis syntax. So 1, 2, 3, this is a tuple. Whereas for a list, I use the square bracket. Right? For a list, I use the square bracket. So this is the syntactical difference. There's one more important difference. For a tuple, for defining a tuple, I can sometimes omit these parentheses. So I can also come over here. I can omit these parentheses. I can define this tuple as 1, 2, and 3. Right? If I do that, then by default, or the type of T will be a tuple, right? So omitting this syntax leads a tuple. I cannot do that with a list. If I try to define a list 1, 2, 3 like this, then L will in fact turn out to be of type tuple. All right. So for tuples, I can omit these parentheses. Now this is very important because this allows us to very easily form tuples, combine values, and use those values. So I can, let us say I have a function over here. I can define a function foo that takes a value a and takes a value b, and it can return a plus b, and maybe a minus b as well. So this function returns 3 values. So if you were doing this in something like C++, you would have done something like foo returns a type of pair of int comma int with an int, right? You would have done something like this to return 3 values. In Python, you can do that very simply by just returning a tuple. Okay, so that is the core differences between a tuple and a list. All right. Now there's one common mistake that people come up when talking about tuples. So for example, if I do something like this of a comma b, and I try to return a minus b, but I have a leading comma over there. Right? Let us try to see what this does. So if I call print, so if I let me say value equals to foo of 10 comma 5, right? And if I try to print the value, or if I try to print the type of value, I will see that the type of value is a tuple. Even though I return an int, but the value is a tuple. That is because I have this leading comma. Right? So just by putting this comma, I have converted this into a tuple. If I want to make sure that this is an int, I better not have a leading comma over here. So if I do this, now the value will be an integer. Is that clear? So be careful about that. All right. Now this is a very common question, and this is a very important question. So the question goes something like this. Suppose you wanted to, so if you have to print the elements of a dictionary in the order of insertion, how would you do that? Yes. So basically what we mean is, let us suppose I define a dictionary. So I say D equals to some dictionary over here. Right? This is an empty dictionary. Then I can come over here and say that D of A equals to 10. I can say that D of C equals to 20. I can say that D of X equals to 30. Right? And I can also say D of B equals to 40. Now what I want to do is, I want to somehow iterate over this dictionary in the order of insertion of values. So basically what I want to do, so let's quickly see what happens currently. So if I do something like for key comma value in D dot items, print key comma value. So let us see what happens over here. So it prints A, C, X, and B. It seems that it actually printed things in the order in which the elements were inserted. Right? So E was inserted first, it printed out A first. C was inserted next, it printed out C next. X was inserted next, and so on. So this seems to be the correct way of printing the elements of a particular dictionary in the order of insertion. Is this correct? Well, this is a tricky question. So let us look at some history of Python. So currently the version of Python I'm using, so I'll quickly do this for you guys so that you can see that I'm currently on Python 3.8.1. And in 3.8.1, yes, this is true. In Python 3.8, yes, this is true that the dics are inherently ordered. However, in older versions of Python, this was not true. Okay. So basically in Python 2, all the way to Python, in all the Python versions up till 3.5, in every Python version less than or equal to 3.5, right? Dics were not ordered. What does this mean? This means that if you have a dictionary and you insert keys in the order of A, B, C, D, E, F, right? You insert keys in some order, and if you try to loop over this list, so if you try to do something like for key in dict, right? If you do something like this, it is not guaranteed that you get the keys in the same order. You can get these keys in any order, or in any particular order, and that particular order is basically determined by the hash value of these keys, right? So depending on what the value of hash of A is, you will get the keys in the hash order and not the actual insertion order. Right? That was true for a lot of Python versions. Now, this was a common pain point for a lot of Python developers. A lot of the novice Python developers, they assumed that whenever you iterate over a particular dictionary, you will get the values in the same order of insertion, which was not true. Which is why in some Python versions, what the dev said was, let us randomize the order, right? So for example, in several versions of Python, when you try to loop over a dictionary, you will get the same value again and again. You will get the same order of keys again and again. That order will be different from the order of insertion. However, that order will not change. Okay. So if your order of insertion was this, let us say that this was your order of insertion, it could be the case that when you iterate over the dictionary, you get this in this order. You get this in this order, but no matter how many times you iterate over the dictionary, you will always get this in the same order. You will always get this in this order. This was true when Python was using the hash value of the key, right, to determine how to iterate over it. Now, in some versions of Python, what the developers said was, the developers said that, hey, people are trying to abuse this, right? People are misusing this particular feature. So let us randomize the order so that people will see that whenever I try to iterate of the dictionary, it comes out in random order, right? So that people are discouraged from using this property. Okay. So in some Python version, the order might be even random. Now, from Python 3.6, so what happened? Let's talk about Python 3.6 for now. In Python 3.6, what happened was the dictionary was still unordered in Python, right? For the Python specification. In the Python specification, there was no change. Right? The dictionary was still unordered. However, in the C Python interpreter, right? In the C Python interpreter, the dictionaries were ordered, right? Ordered in the order of insertion. All right. This was just an implementation detail. This was just the fact that C Python was doing it this way. If you go to Python 3.6 and if you try to do the same in PyPy, you might not get the same results. In C Python 3.6, this was just an implementation detail. However, from Python 3.7 onwards, dictionaries are always ordered, right? And this is now a part of the Python specification. So basically, no matter what interpreter you're using, as long as that interpreter is talking about Python 3.7 onwards, it is guaranteed that a dictionary is ordered in the order of insertion. All right. Now, this is a very common interview question because whenever you're working in an industry, this bites a lot of people a lot of the times. For example, let us suppose that you are developing some code, right? So you are at Google and you are developing some particular piece of code that you intend to run in Python 3.8, right? Now you intend to run this code in Python 3.8 and you understand that in Python 3.8, the dictionaries are always ordered. So you use this fact, right? You use the fact that dictionaries are ordered. However, one of your colleagues tries to execute a code and that colleague has Python 3.5. That colleague of yours has Python 3.5 installed on your system, on his system, right? On his or her system. So what will happen to that particular person? Your code, which worked in Python 3.8, might break on their system because they were using Python 3.5, and in Python 3.5, bits are not ordered. Okay, so even though this is true, even though you know that in Python 3.7 onwards the dictionary is always ordered, please make sure that you never rely on that. Okay, and in fact, if you still want your dictionaries to be ordered, you can use something like the ordered dict. So ordered dict is available in Python. Ordered dicts are guaranteed, are always guaranteed to basically persist the insertion order. All right, and this is true irrespective of the Python version that you're using. If you want to rely on this property of dict, then please use ordered dict. Do not assume that the person will be using Python 3.7 or a higher interpreter. It could always be the case that you are, because you are not coding alone. You're writing some code for a large organization and you cannot guarantee what the other person is using, right? What interpreter the other person is using. All right. And this is a very common interview question. Okay. Let us see if we have any questions so far and then we will continue. All right. Okay. Siddharth says, I'm confused with C, Python, PyPy, etc. Can you please take 2 more minutes on it? Sure. So once again, C, Python. So let me quickly tell you the thing. So C, Python. So Python is the language specification, right? What the Python language specification tells you is it tells you things about things like syntax. It tells you things like semantics. It tells you things like what the library function should do, right? What the libraries are available, what the library functions do, and so on and so forth. Now, this Python specification, this is just some text, right? This is just some rules and some guidelines that you have laid down. by itself, Python cannot do anything, right? Python is just a book. Python is just a piece of guidelines that is laid down that, hey, this is Python. It is just a concept. Okay, so Python is a language. Now, if you want to enforce that language, or if you want to be able to do something with that language, you have to implement that language, right? Basically, you have to implement some sort of a compiler for that language, or maybe you have to implement some sort of an interpreter for that language, right? So, for example, let us say that we are talking about C++. So C++ once again is a language specification. Now, if you want to implement this language, you can have a compiler like GCC that compiles C++ code. All right. Similarly, in Python, we have several interpreters because Python is not a compiled language. Python is an interpreted language. In Python, we have several interpreters for Python. Right. Now, the most common interpreter, the default interpreter that you get for Python is called CPython. So whenever you go to python.org and you download Python from there, or whenever you are on, say, Ubuntu and you have the default Python installed in your system on Ubuntu or Mac or even on Windows, that is the CPython version. So this is the CPython interpreter. Now, CPython is not the only interpreter. There are many more interpreters of Python, namely things like Jython, IronPython, PyPy, right? Brython, Stackless Python, and many more. Okay, so there are many interpreters of Python. Now, where these interpreters differ is all of these interpreters, they at least follow the Python specification. So these interpreters at least follow the Python language specification. Where they differ is what additional things they provide. So, for example, in CPython allows you to import and run C libraries and code, right, from Python. On the other hand, Jython, this allows you to use Java. IronPython allows you to use .NET code, right? PyPy has a just-in-time compiler, right? So it runs very fast. Brython allows you to run Python in the browser, right? Stackless Python and so on and so forth. They have other such features. Is that clear now? Cool. So one more common question that we have over here is, what is wrong? So what is wrong with import asterisk, right? So all of you know how to import all the things. So you see import asterisk in Java as well. So for example, what I can do over here, I can say from random import asterisk, right? So this is a way I can import things. This is a way I can import stuff from module. The question is, what is wrong with this? Why is this bad? Well, if you import everything from a particular module, what that does is it pollutes your namespace, right? For example, let us say that I have my function over here. So let us say that I have my function randint over here. And what this randint is supposed to do is, it is supposed to, let's say, return the value 4. And you can say chosen via a dice roll, right? So let us say that we have this randint function. If I import everything from random, what will happen is, if I call this randint function now, I will see that I'm getting a type error. This is weird, right? My randint function is not supposed to accept any parameters. But I still can't call it. The reason why I can't call it is, when I imported everything from this random module, turns out that this random module also had a function called randint. And when I imported it, it basically overwrote this particular function, right? So the randint inside the random module, it overwrote my function. So this is a common thing that we see. So whenever you're talking about code, it could be the case that you have multiple variables or multiple functions that have the same name, right? But do different things. So how do you differentiate between these two things? You differentiate between these different variables and different functions using something called namespaces. So basically what we say is, we say random.randint is different from some other module .randint, right? Both the functions have the same name, randint, but since they live in different namespaces, I can still treat them differently. Python understands that they are different. If I import everything from a particular module, first of all, this pollutes your namespace, right? So now, if you have overlapping names in your namespace, they will all get overwritten. That's the first thing. The second thing is, it becomes difficult to understand where a function is coming from, right? Where a function is coming from. So let us suppose I do something like this. So suppose I have some code. I have some values equals to 1, 3, 1, 4, 3, 2, or 5. Let me do something like this, right? And I have import random, right? And I can do print random dot choice values, right? And what this will do is it will select one value at random from this list and it will give it to me. Now contrast this code from this code. Random import asterisk values equals to 1, 4, 3, 2, 5, print choice values, right? Now these two pieces of code, they do exactly the same thing. They take one random value from this list and they print it out. However, if my code is very large, right, if I have a lot of things over here, then to someone who is reading my code, they might not be able to understand very quickly where this function comes from, right? They might try to look for this choice function in this code. So currently it is still understandable that, hey, I don't have choice defined over here, so it must be coming from the random module. But what if I have other modules as well? So let us say from request. So what if I say something like this, right? Now how do I know where this choice method comes? It could come from random. It could also come from request. So this code very quickly becomes unreadable, right? So it becomes difficult to identify where these values are coming from, where these functions are coming from, which is why this import asterisk syntax, it is frowned upon. It is bad syntax. Okay. It is always better that you do not import everything from a module. You just import the namespace itself, and then you can refer to things by using the dot operator. So you can do random dot choice. All right. Okay. Cool. Let us quickly take a couple more questions, and then we can end the session. All right. So here's one common question. So the question is, what is the difference between something like a list comprehension and a tuple comprehension, right? So before we are able to answer this question, we should first know what a list comprehension, what a dictionary comprehension, and maybe what a tuple comprehension is, right? So basically what a list comprehension is, so let us say that I have the list of squares, right? So what I can do is I want to store the squares of first 10 natural numbers in this list, or the first 10 whole numbers in this list. So what I can do is I can say for I in range 10, and I can say squares dot append I into I, right? And then if I print squares, this is what I will get. I will get all the squares of all the whole numbers from 0 to 9. Okay. This is a very common pattern, right? A lot of the times what we see is we define an empty list and we add elements to that empty list, right? We keep on appending elements to that list. Now Python provides a different syntax for this called a list comprehension. Right? What a list comprehension allows you to do is it allows you to write the same code in a different manner. So now you can come over here and say, you can say squares equals to I times I for I in range 10, right? So this is what a list comprehension looks like. And at the end, you get the same result, right? You get the same result. Now it is important to understand what the syntax of this list comprehension is. So whatever you have over here, that will be appended to the list. Okay. This for loop looks very similar to this for loop. Apart from that, we can have several other things. So I can maybe have the squares of only odd numbers, right? So I can say if I mod 2 equals to 1, this will give me the square of only odd numbers. I can also come over here and I can nest the loop. So for I can say for j in range 10. So this will give me repetition. This will give me every previous value. It will be repeated 10 times, right? So these are list comprehensions. You can go and read more about list comprehensions and dict comprehensions on your own. Now, just like these list comprehensions, we have things called dictionary comprehension. So I can come over here and I can say squares equals to, so I can, let me say cubes this time. I can say cubes equals to the key to a particular value, I to the power 3 for I in range 10, right? So if I do this, and if I print out the value of cubes now, I will see that this is a dictionary which holds the key and the corresponding value. So I see over here that the cube of 2 is 8, the cube of 6 is 216, and so on, right? Similarly, so this is a list comprehension. This is a dictionary comprehension. Similarly, we have something called a tuple comprehension. Now, tuple comprehension behaves a little differently. For example, let us say that I come over here and I say the whole numbers. So I say something like this. So I say I for I in range 10. So what I'm expecting over here is I'm expecting what I really expect to see is I expect to see this thing 0, 1, 2, 3, all the way till 9. So this is what I expect to see in the output. But let us see what we actually get. We get back a generator object. This is really surprising. So in fact, this is not tuple comprehension. This is a generator expression, right? This is the correct terminology for a tuple comprehension is actually a generator expression, all right? Now, these generator expressions, they come handy in a lot of different scenarios. Basically, what this generator expression does is it generates these values one by one. So let me quickly show you an example of that. So let us suppose that I have a large list, right? Large list. Let us say I have all the numbers for I in range int1 E7, right? So I'm going to create a list of all the numbers from 0 till 10 to the power 7 minus 1, right? So let us see how much time this takes. So I'm going to execute this now. So I just executed this, and let us see how much time this took. So this took a fraction of a second. Let me try to increase this value. So now I'm generating 10 to the power 8 different values. So that is 1 crore different values. And we see that this is taking a considerable amount of time. It is taking a large amount of time to generate this list because it is actually going on. It is going to the memory. It is creating all these objects in the memory. It is actually going to create this list. So if I do length of large list, I see that this list is actually this long. On the other hand, what I can do is I can say a generator list. I can say generator list equals to I for I in range. And it doesn't really matter how large a value I have over here. I can even have 10 to the power 20 elements over here. And when I execute this, it returns back immediately. Right? It returns back immediately. Because in fact, it did not create a list. It did not create the entire list in memory. It just said that, okay, you want this list? Let me generate this list whenever you need it. So this is basically what is called a lazy computation. Lazy computation. So whenever we are using this generator expression, what this gives us back is a generator object. Right? They give us back a generator object. So what I can do from here is I can say next of generator list. If I do this, I will get the next value in that generator list. So I can keep calling next again and again. I will keep getting the next value in this list. All right. So similarly, I can do maybe the squares of values. So now if I do, I will keep getting the next value. So I get 1, then I'll get 4, then I'll get 9, then I'll get 16, and so on. The entire list is not created on the fly. So for example, I can't do something like this. I can't do the length of generator list because this list is not created in the memory. If I try to call the length of this, what it will actually do is it will try to create that list. So this is taking time. Right? Creating that generator list did not take time. Taking the length of this is taking time because it is actually going to try to create that entire list. And finally, it tells me that, hey, the generator object does not support this length operation. All right. So that is the difference between a tuple comprehension and a list comprehension. There is basically nothing like a tuple comprehension. It is actually a generator expression. Right. So let me correct this. This is actually a generator expression. Now, generator expressions come a lot of the time very handy. For example, let us suppose that I want to add all the values from 1 to 100. Right? So how do you propose I do that? I can do something like this. I can say that, okay, total equals to 0. Then I can say for I in range 100. And I can say total plus equals to I. And then I can print total. Right? This is one way to add all the values from 0 to 100. On the other hand, what I can also do is I can do something like this. Sum of I for I in range 100. Now basically over here, I used a list comprehension. Right? I created this list and I used this list comprehension. However, when I'm creating this list, can you discuss the memory requirements of both these pieces of code? The memory requirement of this piece of code is just order of 1. Right? This takes a constant amount of memory because I only have a couple of variables at any time. I have total and I have I. On the other hand, for this piece of code, I am actually creating this entire list first in the memory, and then I am calling this sum over there. So the memory requirements of this are very large. On the other hand, if I use a generator expression, then the memory requirements of these become the same as the previous code. Now we see over here that this code actually did not run because the reason it did not run was because I missed a parenthesis over there. So now this code, this will use the generator expression and it will actually not create the entire list in memory. Now the cool thing about this is that you can omit these braces. So what I can do is, so notice that if I had a list comprehension, I would have this thing over here, right? Similarly, if I want to have a generator expression, I should ideally, instead of these square brackets, I should have these round brackets, right? But turns out I can actually omit these. I can actually omit these completely and I can still do it. So this thing still gives me the same answer. For generated expressions, I can omit the brackets as long as I'm calling them inside a function. All right. I guess let us take just one more question. So one very common question that we see in Python is, so the question goes something like this, that what sort of garbage collector does Python use? Or basically explain how the Python GC works. Or in fact, this can come in several other ways. So a lot of once I was asked in a particular interview, I was asked this question that, hey, you are noticing something, right? So you notice this, that you are running your Python code and you're monitoring how that Python code is running. So suppose that your Python code is printing some values and you see that it continuously prints some values. However, after some time, it suddenly pauses, right? The printing of the values suddenly pauses, and then after some time, it resumes again. So it could be the case that you are doing something like this. So you have some particular piece of code. So you have some values over here. You have a dictionary over here. You have a loop for I in range, let's say 10,000, and you are doing something over here, and you're printing some value over here as well. So what you are seeing is 1 gets printed, 2 gets printed, 3 gets printed, and it is running smoothly. However, at some particular value, at some, let's say 1490, some particular value, there's a pause. There's a sudden pause. After that sudden pause, it pauses for a couple of seconds and then it continues. So it continues with 1491 and then it runs smoothly again. So this was running smoothly. There was a sudden pause, then it was running smoothly again. Then again, after some values, there was again a pause and then it starts running smoothly again. So what is going on over here? It could be the case that this does not work for your use case. Right? So suppose that you are using you are working on some sort of a producer consumer problem. Right? Now what happens if your process, so suppose you are a consumer, right? You are working in a consumer process and your consumer suddenly pauses. What can happen in that case? So well, what can happen is your queue can overflow, right? If suddenly all the producers keep producing, but all the consumers suddenly pause, then your queue can overflow, right? So you do not want this to happen. So what can you do over here? Right? So this is basically caused by the garbage collector of Python. So this is a very common way in which this question is posed. So let us quickly talk about the garbage collector of Python. So first of all, what does garbage collection mean? So in a lot of languages like C++ or C or C++, we have manual memory management. What this means is that either you have a variable like int array of size 10 that the compiler knows. Whenever your code is being compiled, the compiler knows that, hey, you're talking about an array of size 10 and it will allocate some memory for it on the stack. On the other hand, if you do something like this, if you declare a pointer of AR and then you say AR equals to malloc, right? You allocate some memory using the malloc command. If you do something like this, what C++ will do is it will allocate the space on the heap. Now, once C has allocated the space on the heap, C++ is not going to free that memory. Not going to free that memory automatically. You have to do it manually. You have to free the memory manually. Now, of course, you can do that, but this has a lot of tricky business. So, for example, what if you forget to free the memory? What happens then? Well, this is called a memory leak. And a lot of the times, if you notice that you have a very simple program, or if you're coding in C++, for example, you have a very simple program, but the memory usage of that program keeps on getting larger and larger, even though it should not be using so much memory, but it seems that the memory requirement is continuously growing up, then that suggests that you have some sort of a memory leak. There are other cases as well. What if you free the memory, but you then try to use it? That can totally happen, right? So for example, consider a situation like this. I declared an array, right? I declared an array and I said, let me allocate some memory. Let me allocate some memory into this. So I call this function func with AR, and then I decide to free this memory location AR. Let us say that I'm doing something like this in C++. What can happen is I am thinking that, hey, after this point, I won't need the AR, so I can free it. However, it could happen that this particular function, pass this memory location to some other process, right? Or some other thing, some other particular piece of code that will try to use this AR, this memory location after I have freed it. Now, if I do something like this, I can run into all sorts of weird segmentation faults, right? Or because I'm trying to basically free a memory location that does not exist, that I do not own. Manual memory management runs into all these sort of weird problems. Now, for this reason, several languages that try to be more programmer friendly. I mean, I cannot say that manual memory management is bad and automatic memory management is good, nothing like that. But manual memory management is tedious. Automatic memory management is a little easier for us. For beginner programmers, Automatic memory management is a little easier. So languages like Python, languages like Java, languages like JavaScript, right? Languages like Ruby, all these provide something called a garbage collector. All these provide something called a garbage collector. And what this garbage collector does is it handles the task of freeing memory for you. So you can only allocate memory. So in Python, you can say L equals to, let's say, list of range of 100. So over here, when you do this, some space is allocated in your memory. However, you cannot free it. So one more question that frequently comes up is, if I call del of L, if I do del of L, am I not freeing the memory up? Well, in fact, this does not free the memory, right? What del of L just does is it says that delete, basically unbind the local variable L. Right? This is all it is doing. It is saying that there was a variable X, there was a variable L that was pointing to some location in memory. Just remove that variable. That memory is still allocated. That memory has not been freed. Just unbind that particular variable. That variable does not exist anymore. That memory is still being allocated. All right. So del of L does not actually free the memory. Well, if del of L does not free the memory, then don't we have a memory leak? Well, yes, we do have a memory leak, but we don't have a memory leak because the garbage collector will handle it for us. Now let us quickly see how the garbage collector works. So let me take an example. Let me say that I have some variable over here. So I have x equals to 10. Okay, I have x equals to 10. Now let me import the sys module. Right. So in this sys module, we have a function called getRefCount. So what I can do is I can use this function and I can say sys.getRefCount of x. What this will say is, this will basically tell me how many different variables in my Python code are referencing this same particular memory location. So let us quickly break down and see what is happening over here. So when I do x equals to 10, what actually happens is, what Python says is, let me take this value 10 and let me put it in some memory address. After that, let me create a variable called x. So I have a memory address, let's say 1024. And in this 1024, I put the value 10. Right? This is what I have done. When I say x equals to 10, what happens is x is now pointing to this location 1024. Okay, this is what happens when I say x equals to 10. Now, what else could be that there is another variable, let's say y, which is also pointing to 1024. There is another variable z, which is also pointing to 1024. Sys.getRefCount will tell you, this will tell you all the different variables, this will tell you the number of different variable names. Right? This will tell you the number of different variables that are pointing to this memory location. So if I look at how many variables are pointing to the memory location in which the value 10 is stored, I get back that, hey, 161 different variables are pointing to that. Now, I mean, I just declared 10, right? So how can 161 different variables be pointing to that? Well, it turns out that Python does some caching. For some smaller int, Python does some caching. On the other hand, if I do something like this, if I have a large random number, and now if I try to get the count, I see that the count is just 2. So if I do something like something else over here as well, so hello from Python, right? If I do this, I see that the count once again is just 2. Why is the count 2? Well, for one thing, I'm using this x over here, and for other thing, I'm passing this x in the function as well, right? So there are two particular references to x. First reference is this particular local variable x. The second reference is inside this function. Inside this function, where it is accepting a particular parameter x, that will also be pointing to the same memory location, which is why I see that the reference count of this is 2. Okay. So what Python basically does is, for every object, it keeps a count of how many variables are pointing to it. Okay. So basically, what I am going to do is, I am saying that, okay, sys.getRefCount x. Let me do one more thing. Let me say y equals to x. Now, when I do that, I see that the ref count of x has increased. So ref count is now 3 because there are 3 variables: x pointing to it, y pointing to it, and the local variable and the parameter of getRefCount is also pointing to it. Now, if I delete y, let us suppose I delete y, and once again I get the ref count of x. Now, what will happen? The ref count of x will drop to 2 again, because now the one count has decreased for the value y. Y is no longer pointing to it. So basically, what Python's garbage collector will do is, it is a ref counting. Right? It is a simple ref counting garbage collector. So what it will do is, whenever the count of any particular memory location, whenever the count drops to 0, that means that there are no variables referencing to it. If there are no variables referencing to it, that means that nobody is using it. And if nobody is using it, then I can free that memory up. Does that make sense? So what the GC basically does is, it keeps track of how many variables are referencing a memory location. And whenever the count drops to 0, it frees up that memory location. Right? This is what the garbage collection is. So this is the basic garbage collector of Python. However, that is not the complete story. So let us look at an example. So let us suppose that I have something like this. So say that I have a list L, and in this list I have a value 1, 2, and 3. So what I can also do is in this list itself. So let me basically print versus dot get ref count of L. Okay, so let us see what we see over here. We see that there are two values referencing to this. Okay. Now, if I say L dot append L itself, so what this does is in the list itself, it is appending the same list. Okay. Now the reference count of this particular list has increased to 3. But let us ask ourselves this: even if we delete the variable L over here, will the ref count drop to 0? No, it will not. Why? Because the list itself has a reference to itself. Right? The list itself contains a reference to the same memory location. So the reference count of this particular list can never drop to 0. Right? If it can never drop to 0, then the garbage collector will never be able to collect it, and that will cause a memory leak. Which is why almost all the garbage collectors do something else as well. They basically, after every short amount of time, right, sometime, they will go over all the particular variables, and they will see which variables are reachable. So think of this like a graph. You have several variables. Variables that are pointing to some memory locations. All these memory locations are therefore reachable. Now, if the values stored in these memory locations are also pointing to some other memory locations, then those other memory locations are also reachable. However, it could be the case that there is some memory location M which is pointing to memory location N, and this N is also pointing to N. There is nothing outside of this particular loop. If there is nothing outside of this particular loop that is pointing to any of these memory locations, then these memory locations form a connected component. Right? They form a connected component in the memory graph. Nothing from the outside is referencing them. However, they can't be garbage collected directly. What the garbage collector does is it periodically runs a certain cycle or certain loop to check if there are any such self-referential memory locations, and it will free all those self-referential memory locations that are otherwise unreachable. All right, and this periodic check is actually what causes this periodic slowdown. Right? So we saw over here that this code was running smoothly, and after some time there was a sudden pause. Then it was running smoothly. Then after some time it was a sudden pause. So these sudden pauses are caused usually by this garbage collector, by this cyclic checking of this garbage collector. Okay. Now Python garbage collector has several other things. So Python garbage collector is a generational garbage collector. What this basically means is it basically has three different queues or three different generations in which different memory addresses can fall. You can read more about the generational garbage collector. This is just an optimization that different garbage collectors do to make sure that they are not trying to check the same memory location again and again. Okay, you can go and read more about this. But this is a very common question once again in interviews, that how does the garbage collector work, or why do you suddenly have pauses in your Python program? And this is the basic answer. All right. If you want to learn more about the garbage collector of Python, you can always look up resources. You can always go back to the interview bit website as well, and you will be able to find more examples over there. All right. Thank you guys. Have a nice day. Bye bye.